And hello everyone, welcome back to a new video. So we are finally starting with our C++ course. So let's first start off with talking about what exactly is C++. C++ is a general purpose programming language that can be used to create high performance applications. It was developed by this guy, whose name I cannot really pronounce, as an extension to the C programming language. But you don't need to know C in order to start learning C++. But if you do know C++, it would be easier to learn C, and also the other way around. So if you know C, it would also be easier to learn C++. Because in a sense, C++ is just C, but it automates some things for you, such as memory management, and it also adds objects, which we'll be getting into later. Now, why C++? Because we have languages such as Java, C even, C#, all of these languages, so why would we want to choose C++? Well, first of all, it's a very popular programming language and still used by millions of developers today. It can be used to develop applications on multiple platforms, so Windows, Linux, Android, all of these platforms. You get a really good salary if you decide to go into C++, with the average being about 100,000 US dollars yearly. And this was from Indeed.com in December of 2020. It has a ton of libraries. One of the reasons why I do love C++ is because if I ever want to do something, I can just go search up for a C++ library, and I can use that library to make my code so much easier to write, because I can just import that library and start using it. It has a massive community, so there is a lot of support available. Whether you get it on Stack Overflow or specialized C++ forums, there's a lot of support out there for C++. Now, what can you do with C++? Because C++ is so good with performance, game development is very popular with C++. You can also do some application development, of course, and some websites. I'm seeing some WebAssembly coming out, which will allow you to make websites with C++ even easier than it already is. You can do database manipulation, so you can connect two databases and you can modify those databases with C++. I do have a video on this if you want to watch it right now, but during this full course I'll also remake that video and C++ify it a bit more. Media accessors, OS development, compilers, and a lot more. I'm not going to cover everything because you can do basically anything with C++, and that's the reason why it's general purpose. You can generally use it for anything. Now, what do you need to know in order to follow along with this course? Whilst it is not required, it is highly recommended that you know at least one other programming language, such as JavaScript, Java, C, C#, even Python, although Python is a little bit simple compared to C++, but even Python would be good, just so you can kind of get an idea of it. But if you don't know, you can still follow along without any problems. Just knowing an extra language could make learning C++ a lot easier. It can run basically on any hardware, so if you have a computer that's like 25 years old or something, you still be able to run on that without too much problems because of its high performance. And I will be using Linux, and that means I'll show you how to install it on Linux, how to do whatnot, everything on Linux. Well, what I do on Linux would 99% of the time work on all the other operating systems as well. So you don't have to worry about me using Linux and you may be using Windows or Mac, or even FreeBSD or React OS or whatever you use. So first off, you probably need to install C++. If you live on Windows, I am very sorry to tell you, but I, up until this day, have no idea how to install C++ on Windows. I could never really get it right. and I just assumed I'm too dumb to do it. But if you are on Linux, it's a simple apt get install gcc, or a simple pacman -s gcc. And yeah, if you're on Windows, I think you use something else. I think it's mingw or whatnot. But if you can figure that out, then believe me, you can go through C++ without having any problems whatsoever. All right, I'm going to just navigate, just going to navigate into my folder where my C++ actually is. Or actually, let's rather not. We don't need this. Cool. So here is basically the folder I'm going to use. I would recommend you open up this folder inside of VS Code. If you are using VS Code, if you're not using VS Code, it's perfectly fine. You can still follow along. I'll just be using VS Code because that is the IDE of my choice, the code editor of my choice. So it might not be your choice, but it's what I'd really like to use. I'm going to create a new file. I'm going to call it main.cpp. You don't need to call it CPP. You can call it CP. You can call it CXX. There's a lot of things or a lot of extensions you can use for C++, but I usually just go CPP because that's the more common one to use, and it just makes sense to use it. You can also go C, but then it will be expecting C code. So always try and stay with CPP if possible. You can then either drag and drop this into Visual Studio Code and it will open it up for you. Or you can open it up via, if we go like this, via just using your Explorer. Because this Explorer is exactly what you'll see if you were to use this. So if I were to delete this here, that file there would also get deleted. All right. So I'm going to minimize that. Now here, we can start writing our first C++ program. It's simple hello world. So I'm going to say include, and I want to include IOStream. This is just so we can put something on the screen later on. We'll be getting deeper into including and stuff like that later, but for right now we don't have to worry too much about it. We do want to say int main, and in here we want to put our code. So all our main code is going to go into int main. This is our program. Our entire program is going in there. So it's fairly simple. Also, I forgot to say here, using namespace std. And I'll also be explaining in about 2 tutorials what this does, why it's important or not important, whether you should use it or not. But for the first 2 videos, I believe it's perfectly fine that we can use this, just so we can get the hang of it without it, and then later get the hang of it with it. Anyhow, remember all your lines of code should end with a semicolon except for this include, and I believe this main function doesn't need to end with it either. So remember, semicolons very important. Now to put something on the screen, it's as simple as saying cout, which means console output, because we're going to get the output inside of the console. And then 2 of these smaller than, I believe that's smaller than brackets or symbols. And we can say hello world. As simple as that. We can save this file, and I'm going to open up my terminal here. So I'm going to go to terminal and say new terminal. Now if you're on Windows, you will not be able to use GCC or G++, but I do believe VS Code does come with an inbuilt debugger, as you can see there, which you can use to run your C++ code. But if you're on Linux, then it's as simple as just going to your terminal, saying GCC, or saying G++. It's completely up to you. G++ is just another way of saying GCC. I like to go G++ because that just makes me feel more like I'm doing it specifically for C++. But you can also use G++ or GCC to compile C code as well. Anyhow, so G++ main.cpp. Now if we run that, then if we were to list out what's inside of here, or actually let's go to our folder. As you can see, we have a a.out. This is the output that G++ created. We can go here, and if I were to list out what's in here, you can see there is a.out. If I were to show my Explorer here, you can see a.out. So we actually got an executable. Now to run this, if you're on Windows, you can just double click on the executable file. If you're on Linux, you can say // and a.out. And as you can see, we get hello world. If you do not like that this says a.out, we can say g++ main.c++ -o. This -o basically means the output file name. So in this case, we can call this output, because that's what I usually like to call it, just because it makes it simple. I'm just going to delete this a.out, and then I'm going to run this. It will compile the program for us, and now we have an output. It's the same as that a.out we just had, it's just now we say // and instead of a.out we can just say output, and we get the same output there. Pretty neat, right? We can also move this panel to the right because I just like it at the right a bit more. And we can maybe do this. Cool. Now, what I'm going to teach you is something that is optional. These are some optional things you can do in C++, but it's not really required anymore as of the newer versions of C++. So first off, you can say return 0. This is something that you don't really need to do anymore. I just do it because of convenience, or just because I want to, because it feels cool. But you don't need to say return 0 anymore, because this just basically means this is the end of the program. But C++ made it so that you don't really need this return 0 anymore. It will automatically know when the end of the program has been reached, and that is when this right here has been reached. So you can just say return 0, and it won't do anything in our code. It will just tell C++ that, hey, that's where it ends. But C++ can tell you that automatically. Then what I'm going to show here is also optional. You don't actually ever have to use it, but you'll see me use this throughout the most of the course. And we'll also get into using this later on, but you don't ever actually need to use it anymore because C++ got updates. So we can just say int, and then arg c, and that should be argc, not argv. And here you can say char const asterisk arg v and two square brackets, and that should be an int like that. This is something you can use to get input from the terminal. We're not going to cover this right now. We will be covering this at a later stage. You can save that, and let's try and run this. Whoops. So you always need to compile before you try and run it. Now if we were to run it, as you can see, we get hello world. So it didn't really change anything. It's just so we can get input from the terminal if we ever wanted to. But we'll get into using that later on. Also, if you do not like how this starts right after the words right here, it's very simple to get rid of that. You can just add 2 more of these smaller sign bracket thingies. And basically this always just means add to. And you can say end l. This just means end the line, go to a new line. So if we were to compile this, and I'm also going to run it by saying and twice, so ampersand twice, and then /run or /output, because that's the file we're trying to run. As you can see, there's now a new line, so this is not here anymore, as you could have maybe remembered from here. So you can use endl, although this is optional. So let's start with comments, because I feel they're probably the most helpful thing you can learn in any programming language. So a comment is something that does not get read by the computer. For example, let's say we want to say the below gives an output, right? And then whoops, and then here we can say cout hello world. And we have already talked about this, but we will be covering it again today. So if you don't quite understand, don't worry, we will be covering this again. Now, as you can see, we already get red lines here because it doesn't understand what's here. But if we were to try and compile and run this, then we would get an error because it doesn't understand. This is not readable code. This is code that's readable to us though. And as you're working in projects or maybe following along with tutorials, making your own little files, you can create comments to allow you to kind of understand what was happening here. For example, we can put 2 slashes here, and that will, as you can see, already blur it out inside of my IDE. And it will make it a comment. So there's no more red lines because this means this is a comment and it should not be read by the compiler or by the machine that's executing this. So if we run this, then we won't get any problems because it's now a comment. You can have comments anywhere and how many you want. It doesn't quite matter. I can put these anywhere. It doesn't matter where I put it. As long as we have comments, it's great. Save that. We can run it without any problems because remember, comments don't get read by the program. Now, take note, if I were to put a comment here and type something, this would also become a comment because anything behind these double slashes is considered a comment. So nothing after that is being read. So just take note of that. Now that is a single line comment. It's called a single line comment because if we just clean up here a bit, if we will go to the next line, we can start typing again. And if we want to create another comment, we'll have to do that. So for every line, you'll have to need those 2 slashes, and it's just kind of a mess if you have a lot of lines. So what you can do is you can create a multi-line comment. A multi-line comment is a slash, star, star, slash. Everything between these is considered a comment. So this can span multiple lines. So a multi-line comment, because it can span multiple lines without you needing to be slash or star or anything like that the whole time. So this is a multi-line comment. You can use them however you please. And yeah, just take note that comments exist because they are very important. Even when you get into like these big companies like Google, comments are very important because then the next guy can be like, oh, that's what's going on here. So it just helps explaining and keeping you and the other guy up to date. Cool, now let's talk about outputs. So we are going to talk about 2 ways to get output. First, we're going to talk about cout. Cout stands for console output because here, this is the console. If we want to put something out of there, we use cout. So cout, and then we use these to basically say, send all of this data in to cout. And take note of our semicolon there. They're very important, needed on the end of every line or not every line, every command rather. So just keep that in mind. There are some exceptions though, but for right now, take note that you do need these. Anyhow, so we're saying console output and hello world. That's what we're getting here. We can also, at the end here, we can do this and say end out. And this means end the line. So it will basically go to the next line. If we were to compile and run this, as you can see, now this doesn't happen anymore. It goes straight down. You can still pass things in after end line because remember, it just gives you an extra line. So you can put more things here if you wanted to. But it's usually recommended that instead of using an end line in the middle of your thing, end line should only be at the end, here at the end of your sentence or your end of your output. So instead of using end lines in the middle of your output, what you should do is you should use a \n. And this is an escape character. An escape character basically just means do something that you can't do normally, because we can't say enter. That is not allowed. So how else should we say go to the next line? We use /n, which means create new line. And remember, it's a \n, not a /. And it's not this, it is this. Anyhow, now we can type our things and it will be on the next line. And because we have our end line at the end, our next line won't have anything after it like it had here. So yeah, this is the first way to give like outputs, and you can like mix and match more text if you wanted to. For example, my name is, and then add more here, Steve, for example. And then we can also maybe put another \n here because it's allowed anywhere. And if we were to run this, then we'll get hello world, STSD, my name is Steve. So these basically just means send forward, add to that. But you don't have to worry too much about these right now. You'll kind of get used to them as we go on. So yeah, that is the first method of getting output, and that's the C++ method. There's also a C method that some people still enjoy using. So I'm going to just show you what it is so you can also kind of understand it. But also before we go, take note you can also pass in numbers here. So for example, 22, that's perfectly fine. Run that, and here we go, Steve 22. Okay, now that we know that, let's remove this. So this method is called printf. So printf is basically the C way of outputting text to the screen, because remember, C++ is basically C, but improved. So you can still use a lot of C things inside of C++. So in here, we can specify some text, maybe like hello world. And this is perfectly fine if you want to get some output. Save that. Run it here. Take note, it will not get a new line, so as you can see there. So you will have to specify the \n. So if we go here and we run it, then we'll get a new line. Now you might be thinking, okay, but why use cout instead of printf? Well, it's kind of up to personal preference these days. Usually printf doesn't really get used that much in C++ because it's more of a C method to do things, but you can still use it. One of the reason why people do like this is because, let's say for example, whoops, I hate it when it does that. Just close there and close there. Here I can say how old I am. Maybe I am, and then I want to specify a number. And to do that, I can use, let's say, a %i, which basically means a number. And we're just going to add a \n here. It's not required to add this \n. This is just for a new line. But this %i basically means we're going to pass some data in and put it here. So here we can maybe say like 19 because I am 19. Run that. And take note, I am 19. So I have a comma here after the double quotes. Remember, double quotes are very important because double and single quotes are not the same. So you should always use double quotes if possible. Otherwise you might get errors. Anyhow, so this %i just basically means put a number in here. So we can put this number in there, as you can see there, and then it gets put in there. This is very useful for later on, but it's just good that you know this, because we wouldn't be using printf, but if you do like to use printf, then this will allow you to kind of get the basics around it. Now, so with cout, it would be like this, cout, and we send our data in, I am, and then we send our data in, 19, endal. You don't have to use endal at the end. You can just use the \n if you want, but I find it easier or just more comfortable to use endal. Run that and we'll get the same output, but with different ways of doing it. So it's up to you which you prefer. I prefer the cout method because that's just kind of what I learned and what I liked the most. But you can use printf if you feel you like it. Up until this point we have been using this, but it's actually recommended that you do not use this. And I'll show you kind of why this is being used. But the reason as to why you shouldn't use this is because it can cause naming errors, which just basically means if you import a library, they may also use std, and that could cause errors in your code because now which std should you use? So it's always recommended to never include this using namespace std. Now, if I were to remove this, like that, then what we should do here, because as you can see, we're getting red lines here. So we should actually go here, and with both of these, cout and endal, we should say std : and then it's fine. So basically saying using namespace std allows you to cut off this part from your code. If you're a beginner, then it's perfectly fine to use this for a while because, you know, as you're learning C++, you don't want to code 5,000 lines of code because you have to say std everywhere. But it is also recommended that you learn this off as soon as possible. And I am going to start writing my code exactly like this. So I'm going to remove that using namespace std and always write my code like this. because that is how you should be writing it in order to not get any errors. But if you do want to start, or if you do still want to continue using this, then what you can do, instead of saying using namespace std, is you can use a smaller version of it. So saying using and then std : cout, for example. By saying this, you can remove that std there, and boom, that will work perfectly fine. So this is a much better way than saying using namespace std, because instead of removing the std from everything, it only removes std from one thing. And it's a lot safer to work with. So if you really don't want to use std, I recommend just making a few of these, but I do also recommend you get rid of this habit of doing this. So you can do that, and now we can remove that end line there. And then it's as good as new, but now we just have 2 lines extra here. But I do recommend you try and not do this. Just try and use std everywhere, because if you know how to code C++ by saying using namespace std, then it's very difficult to go back to a time when you don't use it. So let's say you now have to go into a job. Chances are they're not saying using namespace std. They're probably not saying it because they need to organize their things. But if you have been saying it up until that point, then now you have to learn what needs this std beforehand. And that is a really, really annoying process. I take it from someone that actually did go through that, where I now have to learn how to code without saying using namespace std. It was a big pain in the butt. And I would just recommend to allow you to skip that pain in the butt. Just do this. Just say std cout, because then you'll learn when you should be using std and when you should not. And if something is really just too long and you just don't want to do it, you can just say using and boom. But also keep this to minimal. Don't do this with everything. But now I can do that. If we save this, it will still run like normal. So g++ main.c++ -o output, and then we can run that output. As you can see there, we still get hello world. So yeah, this is just something you have to keep in mind. So what is a data type? Now, a data type is basically a type that you can store inside of something. For example, let me just make a nice comment here. A char would be a single character, because that's a character, a char. So S is a char, A is a char. 1 is also a char if it's inside of single quotes. Take note, all chars will be inside of single quotes. Not double quotes, but single quotes. This is very specific. So this one here, that would be a char. But take note, this one here, that's an integer. And this one here, that is a float. Now, you might be getting confused, like what's an integer, what's a float? What's all of this? Okay, so we covered that a char is basically a single character. It's like basically A, B, C, D, or 1, 2, 3 in single quotes here. And there can only be 1 between these single quotes. You cannot add like A, B here. That is no longer a char, so that will be invalid to type. So only A, or only B, or only 1 between these. An integer is a whole number, which means 1, 2, 3, -5, 0, -10, 66, whatever. That's an integer. It's a whole number, and you can just, it's just a normal number, like you count. A float is the same as an integer. However, it is not a whole number necessarily. For example, you can get 1.4. That's a float because it has a 0.4 at the end. Anything that has this 1 point, after that we have a float. So 3.14159, that is pi. Pi is considered a float or a double. You'll see me in this course use those two words interchangeably, but float and double are kind of the same thing, where double is just like a bit bigger than float, and we'll get into that in a second. So this right here, that's a char character. These right here, they're not chars, they are integers or int, and they can also be seen as whole numbers. Take note, they do not have single or double quotes, they're just numbers. And that's a float or a double, or basically a not whole number. So yeah, those are some of the most basic ones. And also we have to cover booleans. So booleans are like yes or no. So if someone asks you, are you older than 18, you answer with yes or no. And in computer language, yes and no are determined by true and false, where true will be yes and false will be no. So let's say you ask the user, are you older than 18? If they answer yes, then that will return true. If they answer no, then that will return false. And you can use this to add logic to your program. And we'll get into that in a different video, but it's kind of out of scope for this one. And you also have strings, which is basically like a bunch of chars added together, but they are instead of double quotes, because strings are double quotes. As you can see here, they are also in double quotes. And I remember, if I was right, on the beginning of the video or at the beginning of the series, I said always use double quotes here. That this shouldn't be single quotes or any other quotes, they should be double quotes. That is because this right here, that's a string. It's a whole word. A string can be basically anything here. That's it. It's a string. If it's inside of double quotes, it's a string. Okay, now let's cover them a little bit deeper, just so we can get kind of the idea of what they do. Now, we won't really be covering the sizes of these, because a lot of times you do cover the sizes, but I believe that's kind of out of the scope of this course. But if you ever want to know the size of a type, of a data type, you can just say size of here instead of cout, and let's pass an int. If we were to run this, then we get 4. That means an int requires 4 bytes of memory in order to be used. If you're trying to program something that has to meet like specific requirements for speed and stuff like that, this can be very useful, because then you can kind of measure how much RAM you should be, or how much RAM you're going to use if you try and use this data type or this data type and whatnot. I'm not going to cover most of them because I didn't feel it's necessary for this video, because it's kind of a lot to take in. But anyways, if you do want to know, chars are 1 byte, integers are 4 bytes, as you can see there. Floats are also 4 bytes, but doubles are 8 bytes, because they can store more data than floats. So a float can, let's say, only store about 12 characters after the dot. I don't know if that's true, I'm just guessing here. But a double can store 24, for example, because it can keep double the amount. That's why it's called a double. Now let's actually get into using these. So to use them, I want to talk about variables. Now, variables are basically containers. If you think of a variable, then you should think of just a placeholder for something. So let's say we get the name of the user. So the user name, right? We get that username. And let's say it's Nick, for example. Now, it's either we have to remember it's Nick, and everywhere inside of the code, we have to make it Nick. Or we can store it inside of a variable, which it just contains it. That variable is just like another word for this right here, that you can use all over the place. For example, let's actually create a little story here. Alright, so here we have a little story. Let's just increase this. Okay. Now, here we're saying, my name is Nick, and I am 24 years old. Tomorrow I'll be 25 years old. I want to change my name from Nick to Jack. My new name is Jack, and I'm 25 years old. Now, let's say this is a story of 30,000 lines of code, right? So you have 30,000 lines like this. Now, you want to change this name, because you now want to change the name of the main character, Nick, to, let's say, Mitch or something. And now, once we did it within a second, if you had a story that is, let's say, 5,000 lines of code, then you have to go and change it individually, and that's going to be a lot of effort. That's where variables comes in. We can store this inside of a variable. So let's create a variable. So I'm going to create a string here. And to create a string, you just say std : string. This string right here can keep text, anything inside of double quotes. And take note, I'm not using namespace std, and actually I want to remove this using that, and I'm going to go here and add our std here as well. There we go. So I'm not using namespace std, but if you were using namespace std, you could probably remove this. But then I'm going to say equal here, and instead of double quotes, I'm going to put something here. So let's say the main character's name is Nick, and at the end I'm going to add a semicolon. So cool, we created a string, but how do we access this string? We access the string by giving it a name. So in this case, I can say main character name. Of course, you don't have to make it so long. In fact, we can just say MC name for main character name. That will also work perfectly fine. You can put basically anything here as long as it's not something that is not normal. For example, exclamation mark. I don't think that is allowed. It might be. No, it's not. As you can see, there's a little squiggly line underneath it. But you can use underscores, and that's about all you'll need. You don't have to use anything other than normal text and underscores. And I don't recommend you do use anything other than normal text and underscores. And also this here is called camel case. Camel case is basically when one does this. My name. That's camel case. So this right there, that's capital case. But you also get a styling of variables that's like this, my name. So you can also do that if you want, but never mix them like this, my underscore and capital name. Don't do that. That's just disgusting. So either go with underscores or with camel case. I like to go camel case with C++, but in other languages like Python and in Lua, I like to use underscores. So it's up to personal preference. But once you have done that, now you can use this. So this Nick here, let's add some quotation marks here to split this string. And now we can go here and you can say MC name. There we go. Now this main character name will be here. If we were to run this, then my name is Nick. Because this right here is just a placeholder. Basically, what's actually being said here, but we use this placeholder, but what's actually being said here is this. That's what's actually there. But we use this to reference that. And here as well, we can change that Nick to MC name. And there we go. Now Nick is there as well. Now let's see what we get if we run this. Hello, or just hello. My name is Nick and I'm 24 years old. Skip that. I want to change my name from Nick to Jack. Now that's very nice, but what about the age though? Because here we use 24, 25, 25. Well, we can declare an integer variable then. We don't have to use std, we can just say int here. And we can call this age. I'm going to call age, or I'm going to make age equal to 24. Now this age can be referenced anywhere here, so I can go whoop and just say age. And take note, yet again, this is the same as saying this, but now we're referencing it from here. And you'll see how useful it can be in a second. And these are 25. So that is interesting. I'm going to show you how to work with that in a second. But if we were to run this, as you can see, my name is Nick and I'm 24 years old. Okay, neat. Now, let's say halfway through the story, we decide, okay, wait, I don't actually want the name of the main character to be Nick. I want it to be Caleb, for example. Save that, run the program, and here, my name is Caleb. I want to change my name from Caleb. So by just changing one line of code here, we changed everything in the story, or not everything, but we changed the main character's name. So that's pretty neat. Now, how will we go about changing that here? Well, this age, we can actually just say here, like that. We can say age plus 1. Because 24 plus 1, that is 25. So if I run this, we get tomorrow I'll be 25, and here he said 24. So you can use plus to add these together. We'll be covering math operators later, but you can use plus to do this. The same here, we can copy this, and here where that 25 is, we can just do this, and boom, there we go. Now age is basically changeable everywhere. So here we have our 24, 25, and 25. Now if I were to change this to 30, the code will dynamically change with it. So I'm 30 years old, I'm 31, I'm 31. So I only had to change one line of code, but it changed everything else with it. But the thing is, you don't always want to change it like this. So for example, with this string here, let's go here to where it says I want to change my name to Jack. Now let's say here in the middle of the story, you want to change the name to Jack, because that's what it's being changed to, and now the main character's name should be Jack and not Caleb. Then we can say MC name is equal to Jack. Don't forget your semicolons. Now we have changed this variable. This MC name is no longer Caleb, it's Jack. And now here we can still use MC name. MC name. So if I were to run this, as you can see, my new name is Jack, and we used MC name. So you can change these later as well. So this age plus 1, you can change it here as well. So we can just say age is equal to age plus 1. And this will change the age to its current value, so 30 plus 1, which will be 31. So now we can just say age instead of age plus 1. So we just cleaned up the code. And take note, these spaces don't really matter, but I'm just using them to make it a bit clearer. If we run this, then there we go. The story still works, but we learned how to use variables and how to change them in the middle of the code. Take note, this age variable here is permanently changed, which means until we change it again, it will forever be this. So just take that as a note. The same here. So if we were to move MC name up here, then this MC name would change as well. Okay, so that was just an example. Now let's actually talk about the other things we can use. So here we can talk about things like, let's talk about char. So char is just char, and let's say letter here, A, that's a char. Simple as that. Next up, we have a boolean, so let's go bool, and let's say old, so if someone is old, and we can make that true. Or if we wanted to, we can make this false. I will show you how to work with booleans later, but yeah, and take note of this char here before I forget, single quotes, not double quotes. Double quotes are for strings, single quotes are for chars. And then we have our int, and then we can also add a float here, so float, and let's say num for number is equal to 3.14159. We can of course also use a double, so let's go double, and we can make this x. And now we can add more values here. I don't know what's after now, so I'm just gonna whoops. Okay, so I'm just gonna add some random things here. So yeah, but take note, this char here, this can hold more than just letters. For example, if we add another char here, we can actually say number. I can make this 97. The reason is because 97 is the letter A in ASCII. So if I were to std, or I'm just going to see out here, and I were to put number here, let's see what we get. We get a lowercase a. The reason is because this 97 in ASCII is a lowercase a. And that means 98, that is a lowercase b. Let me just remove that. So if we were to run this again, then we'd get a lowercase b. So that is why this can also hold some numbers, but take note, if it's not an ASCII value, then it probably cannot be stored inside of here. You can also declare variables multiple times, or before you actually initialize them. So let's say int x and y. You can put them here. You don't have to put anything inside of them. Or you could just say int x. That works perfectly fine, but I'm just showing you can put multiple on one line by doing that, adding a comma. But let's say we just have one. And we can say x is equal to 10. You can do this. It's perfectly fine. And we can even go int y is equal to 9. And then we can see out x plus y. If we run this, then we'll get 19. So you can declare variables and initialize them on 2 different lines if you wanted to. There are more things that I can teach you, but the last thing I'm going to cover is unsigned. So an unsigned number basically means it cannot be less than 0. So if I say unsigned int, this means this integer cannot go below 0. So it can be like 1, 2, 3, whatnot. And if we just see out this again, I just put x here. If we run this, then we'd still get 2. But take note, if I go -1 here, it will not give me -1. It will give me the highest value it can get. So this is where the difference basically comes in. An integer, a normal integer, that can go below 1 or below 0. The reason is, you can get with normal integer, you can get half of this. So you can go half the way underneath this. So if we were to just take this and just go like this and divide it by 2, a normal integer can basically cover this, right? But an unsigned integer can cover this. So this is the difference. While a normal integer can go into the negatives, it can only go about half as much as this one can. So you can use an unsigned integer if you know your value will never go under 0. And you know you'll need to use a massive amount, like a massive number, then you can use unsigned. Probably my favorite part of any programming language is being able to get input from the user. Because let's say you have a nice program where you can chat with someone. Now you just need to get user input in order to make that program work. 99% of programs will require some form of user input. And in this case, this form is going to be text input via the terminal. So there's 2 ways we can get user input that I'm going to show you. And yeah, so the first way is using CIN. CIN is basically what you can use to get console input, but only basically one word. So let's try and do it. So here we have a basic program. I'm going to remove that part there because we don't need it. We can say int, and maybe let's say the user needs to enter their age. So I'm going to say age here. And here we can just tell the user that they should enter their age. So I'm going to say cout and please enter your age. Right? And you'll notice that I'm going to remove this int al here because I wanted to ask that question and let them put the input on the same line. If you put int al there, they'll have to put the input on the next line, which we don't want. We want it on the same line. But that's optional. I just prefer mine on the same line. You might want yours on the next line. It's just what you prefer. So what we can do is we can say CIN or STD, you should rather say. CIN. So if you use namespace STD, you don't have to put this STD there. And then we can say 2 bracket signs or these bracket symbol things, but they're the opposite of the ones you have with cout, because whatever's going into this input should be sent towards something else. This means the direction it's being sent in. For example, this text is being sent to the console to be put out. So it's being sent to console output. While this input is being sent towards, and you guessed it, age. So we're sending the user input into age. And that's also why I decided to break these two up into two, so it's just easier to send them into one another. And let's actually see out what we have. So see out, you are age years old. Okay, let's try and run this and see if this works. So let's see. So you compile and run it, and please enter your age. I'm going to say 18. You are 18 years old. So we just told the computer what should be entered here. Let's do it again. I guess we didn't have to compile it, but anyway, so let's go here and say I'm 99. I'm 99 years old. But what if you did two things here? Let's say 18 and 99. Well, we get 18, so there's not a big problem, right? And yet again, you don't have a problem, 18. So just take note that if you enter more than one thing, it's just going to give you the first one. So this is the delimiter, it's the space. Delimiter meaning it's what splits the two apart. Now let's say you do want to get more things. So let's say we also want to get a string. So std string, and here we can say name. And I'm just going to do that and say name. Please enter your age and name. So what we're doing here is we're stringing the input together. So the first one is going to go to age, and then the second input is going to go to name. And here we can say, instead of you, we can put a name there, name. And I know at the beginning, this way and that way is very confusing, but to be honest, you just have to try and error. Sometimes you will find yourself doing this. Whoa, my bad. Did not mean to do that. Doing this instead of this. That does happen even with me today, but you will get used to it soon enough. Now let's try and run this. Okay, I am 18, and let's say my name is Nami. Nami are 18. That English does not sound right, but Nami are 18 years old. So let's just change that to is. So cool. That's how you can get more things. So take note, the first one here is going to be the first input. Now, what if you don't give it a second input? Whoa, okay. I just can't click my mouse right today. Let's say we give it 18. Then it's just going to wait for us to give it another input. And you'll notice that it just works perfectly fine. So it's going to wait for a second input because it knows it needs a second input. Now that's the first way to get it, and it's great if you really need to get words. But let's say we want the user to describe themselves. So here I'm going to say, please enter your, and instead of age and name, I'm going to say description. Because let's say it's like a police station, you need to enter the description of the guy that just tried to rob you, or something like that. Then this can be what's happening there, and then we can say description. And we can just put the description in here. Okay, now the next input, if I can type, is called getLine. And as you may think, getLine allows you to, well, get the line. So let's go here and say std string, and I'm going to call this desk for description is, and I'm not going to make it equal to anything. Now, we want to get the line of, or we want to get a line and put it inside of description here. What we can do is we can say std get line. And yet again, if you have using namespace std here, then you don't have to put that std there. Anyhow, so std get line, and here we have to say std cin, and this is the method it's going to use to get the input, which is cin. And then we can say disk. So yeah, so it's going to use this method to get what we need, and it's going to store inside of disk. So let's quickly try and see if it works. So I'm going to compile and run this. I'm going to say blue hair. And I never did this disk. We need to display the description in order for the program to work as we plan. Okay, and let's say the description is blue hair. As you can see, description blue hair. So yeah, that's the get line. What if you want to use get line as well as CIN? Because you'll notice something is if we try to use CIN here. So let's go back and say int age, and then here we say CIN. That should be std CIN, and here we can say, and that should be other way around. As I said before, you can still make that mistake, and we can say age. And here we can try and display the age. So I'm going to go \n, which will create a new line, and say age, and I'm going to display age here. Let's see what happens here. And first, we also want to make sure that we know we're trying to get age. I'm just going to move this downwards so they're together with their things. And here I'm going to say cout. What was the age? I'm going to remove that indal. And there we go. Now our code is slightly more clean, and let's see what happens if you try and use CIN with getLine. Okay, so the age we'll say is 19, and as you can see, we get the age is 19, and it's asked for the description, and it just skips it. Now that is because a CIN, I believe, kind of holds like a type of buffer. And whenever we try to use CIN with getLine, since getLine is using CIN, it also uses that buffer. So when you press enter, it's like, oh, okay, CIN has been used. We can stop. So what we can do here is we can say CIN, or that should be std CIN dot ignore. And this means ignore the CIN we have in the buffer. So don't try and use it. We have already used it. You can stop using it. That's basically what we're saying. So now if we try and enter the age and say 20, it allows us to get the description as well. Blue hair, or Hari, that's fine as well. Description blue Hari and age is 20. So yeah, if you want to use them together, you can just use CIN ignore. Otherwise, you can get a line by saying getLine, or you can just get a word or multiple words or input by using CIN. So you can also keep all of this inside of a variable. So if I say int x is equal to, and let's say 4 plus or 5 plus 6, which should give us 11, and it's just adding things together by using plus. Then here if we say x, we save and then we compile and run this. Then we get 11 as expected. You can of course also add more here. So 99, for example, plus 8. Plus 1, that's also possible. There's nothing wrong with that. As you can see there, 119. Cool, so we have covered that you can now put it inside of variables as well. This just depends on what type it is. Is it going to be an int or a float? Because if you could remember, a float or a double basically has something like this. So that would return a float, not an int. An int would not have these right here because this is considered a float. Even though the rest here are ints, this is still a float, so it's going to want to return a float on the end of the day. As you can see there. Anyhow, so I'm just going to put everything in here just to keep things simple. We also have subtracting, so let's say we have 15 minus 7. Then if we let this work itself out, then as you can see here, we get 8. We can also do something like plus 9 here. That's perfectly fine as well. So you can mix and match all of these math things together. As you can see, 17 now. So yeah, you can mix and match them. We also have time. So this is, normal timing, multiplication. So for example, 5 times 5 should give us 25. As you can see there. But take note, if we say 3 plus 5 times 5, we're not going to get what you think we're going to get. We're going to get 28. The reason for this is because it's not 3 plus 5. That's not first, because this is the order of operations we're talking about. If this was first, it would be 5, 6, 7, 8, and then 8 times 5, which is 40. But in this case, order of operations say multiplication comes first. It's always first, depending on what you do. So it's the same as basically saying this. As we know, brackets should, in any math situation, always be done first. Brackets are most important, which means if it's in brackets, it should be done first. And this is basically what it's saying, that, just without the brackets. If you did, however, want to work this out first, you can do brackets like that. This will make it, say, 3 plus 5 and then times. As you can see now, we get 40 and not 28. So yeah, you can use brackets to change the order of operations. Then we have division. So let's say 10 divided by 5. That should give us about 2. You see there. And if we say times 2, then what do you think we're going to get? 4. That means that division was done first. In this case, division comes before multiplication. If it was the other way around, it was 5 times 2 first, then this would have been 10. 10 divided by 10 is 1. But it was 4 because 5, or 10 divided by 5 is 2, and 2 times 2 is 4. Yet again, if you want to change the order of operation, you can do that. And this will make that it times first and then divide. Now you might be going, oh no, what's going on? I don't know math. Don't worry, I was the same. So basically how you can figure out which here is first, if you don't want to use brackets, you can use brackets if you want. For example, we can say plus 9 here, and we can also put brackets here. That's perfectly fine. If you want it, you can even put brackets around this. This is perfectly fine. Brackets are like your best friend. So you can have as many brackets here as you want, and they will do the order of operations for you. But now you might be asking, okay, but how do you know what the default order of operations is? Well, that's where BODMAS comes in. We used to learn this in school. Most of us, like me, just slept on it. So I only know half of it. So I know this is for brackets. So B is brackets. Don't know what O means. Then we have D for division. That is with this forward slash. Take note though, forward slash, before I forget. Division uses a forward slash, not a backward slash. Take that as note. Those two are completely different. Anyhow, and then M is for multiplication or times, A is for adding, and S is for subtracting. So first it would be brackets, then whatever this is, then division, multiplication, add, subtract. So you can just use BODMAS to figure it out. So yeah. We also have one more operator. This is called the modulo operator. It's usually considered one of the more difficult operators to understand as when you start programming, but once you kind of progress into programming, it becomes a lot simpler to understand. It took me about, let's say, 6 months to completely understand modulo. So if you didn't understand it off the bat, it's understandable. It does take a while. If we say 10 modulo 3, we will get 1, and I'll explain why we get 1 in a second, and you can see there. So when we divide, right? So if we go like this and we say 10 divided by 3, right? What basically happens is it's 3 plus 3 plus 3, which is equal to 9, right? And then we can't divide anymore. And then this is 3 times. So what we'll get then is 3 as a return. So if we were to say 10 divided by 3, we will get 3. Of course, it would be a decimal point and not a floating point. Or actually, no, it's not a floating point. But you can see we get 3 because that's how it works. Now what modulo does is it basically finds what's left over. Because as you can see, there's 1 left over here. It's not 10 yet. So what it does is it takes the value we have minus this value here. So then it's minus 9, and that will give us 1, because that's how much is left. So when we say modulo 3, We get 1 because it is 10 minus 9, which gives us 1. We can take another example as well. Let's say 8 modulo 3. You can of course go bigger and say like 89 or something, but you know, that's a lot of math to do. So if we compile and run this, we'll get 2. Because 3 plus 3 is equal to 6. But we cannot add another 3 here because then it would be equal to 9. So there are 2 left. So now we just say 8 minus 6, which is equal to 2. And there we go. That's basically what Modulo does for us. So yeah, that's the basics of Modulo. It basically gives you the remainder of a division, what the number remainder, not the decimal point remainder. So yeah, those are the basic operators. Next up, we're going to look at some functions. So to use those functions, we could say hashtag include and then CMath, and this will allow us to use a lot of mathy things in our program. Yet again, I'm not going to cover everything here because it's just out of the scope of this video. We are not mathematicians, we're just basic programmers, so we just want to know the basics of programming. So we're just going to cover the basics of numbers here. And of course, you can put it inside of a variable again, but I'm going to do it inside of here because I just find it faster and simpler. So first we have POW. This is to the power of, basically. So if I say 5 to the power of 2, we'll get 25. As you can see right there, we get 25. If I say 5 to the power of 3, I think that would be like 121. Yes, 25, I mean, not 21. Where did I get 21? Anyhow, so yeah, 125. And yeah, so that is power. So it's basically saying, in this case, that should be a slash, 5 times 5 times 5. That's basically what this is saying here. 5 times itself, how many times? Then we have square. Whoa. There's square root. So square root basically gets the square root of something. For example, 30, let's go 36. I think that should be 6, if I'm not mistaken. Let's see here. And yes, it is 6. What is the square root of something, you may ask? Well, it is basically when you times something by itself. So 6 to the power of 2. Or in other words, it is 6 times 6. So we compile and run this. As you can see, we get 36. So yeah, the square root basically just gets what is the root of this entire equation if you were to times it all together. And of course you have 25, which we just covered, would be 5. And there we go. Okay, so next up we have rounding. So usually in school you had to round it yourself and it wasn't very nice, whatnot. But now the computer can do it for us. So what we can do is, let's say we want to round up or down depending on which one is highest. So if you remember from school, you basically have, let's say 5.4, right? Whoa, that's 5. That will round to 5. And then you have 5 times 5, which will round to 6. The reason for this is once it reaches 0.5 or higher, it rounds up. That's how math usually works. You round up then. If it is lower than 0.5, so like 0.1, 2, 3, or 4, then it rounds down to 5. So yeah, that's basics of rounding, for in case you may have forgotten. So we say round here, and let's say we say 5.1. That will of course round down to 5. And if we were to say 5.5, then that will of course round up to 6. As you can see there. Now what if you always wanted to round down? Because let's say you might be getting input from the user and you don't necessarily know what it is, but whatever it is, you always want to round down. Well, to do that, you can just say floor. And now it will always, always, always round down, never up. As you can see here, we get 5. If we make this, let's say 5.1, and let's make another one here and make that 5.9. As you can see, it will always round down back to 5. Now, what if we wanted to do the opposite and you wanted to round up? Then that would be seal. This will always round up, so in this case, it will round to 6. So how do you remember the difference between round, floor, and seal? Well, let's start with floor. The floor is underneath your feet. If you want to look towards the floor, you'll have to look downward. So it's going to round it down because you have to look down to look at the floor. With seal, the ceiling is above you. So you have to look up to see the ceiling. So seal will always round up because that's the ceiling. And a round is of course simple as it rounds. Whichever one is closer is the one it rounds to. Cool. Now 2 more we want to cover. So we have if max and we have if min. Sometimes you want to know which of the 2 numbers are bigger. Of course, you can use something like an if statement, which we will cover in the future, and figure out which one is the biggest and which one is the lowest between 2 numbers. Or you can just use if min and if max. So if we go like this and we say 10 here, if max will give us 10 and if min will give us 5, because 5 is less than 10. And here 5 is more than 10, because if max gives us the maximum in this value. If min will give us the minimum. I do believe we can add more. Let's see if we added 15 here. Nope, you can only add 2. My bad. So you can only add 2 here, but you can test those 2 against each other. Of course, we can also switch this. So let's say this is 0 now instead of 10. And this one is 4 now instead of 10. Now if we were to run this, we'll get 5 and then underneath it's 0. As you can see right there. So yeah, that's all there is I wanted to teach you about math. Math isn't that difficult thanks to how programming makes it easy. So most of the time you don't have to do your own math, you just ask the computer to do it because a computer is basically just a massive calculator. So a string is a bunch of characters mashed together inside of double quotes. So these right here are double quotes. Anything between them is a string. That means this text right here, that's a string, hello world. In this case, it's just something readable, but a string can also be something that's not humanly readable. That is a string. So, now that we know that, we can also store a string with an std string. And we can call this whatever we want. We can call this words or something and make that equal to hello. And why did it go to the next line? And now, of course, we can display words here. It should actually just be word because it's one word, but there we go. And now this would still work perfectly fine, and that was a previous command, my bad. And this will work just like with anything. It will display hello now, because we're basically just saying, make this word basic, or make these bunch of characters basically equal to this. We have already covered variables. If you have not yet watched my videos on variables, I highly recommend you do, because 99% of the time we're going to be using variables in our lessons. So I do recommend you know what variables are and you do understand what they do. So yeah, so that's the basics. Take note that this is a variable. It's not inside of quotes. If this was in quotes, it would be something completely different. It's not inside of quotes. That makes it a variable. Same here. We can assign a variable on another variable. Gee whiz. So let's say we copy this and we make this, instead of that, we can say, we can make that x, right? X is equal to hello, and here we can make that x. Take note, word is not equal to x, because that's a variable. That's a string. When it has double quotes, it's a string. Without double quotes, it's a variable, which means word right there is still going to contain hello, because x contains hello now. We're making word equal to the variable x. If we were to put double quotes here, that would make that the letter x and not the variable x, giving us x instead of hello. So that's very important to take note of. Cool. Now we're going to be working with strings, and with some of the things we'll be doing with strings, it's recommended to do #include and then just string. Take note, everything we do here can also be done inside of a variable. I'm just not going to do that because I feel what's the point when we have a cout perfectly waiting for us right here. Or actually, let's do that. Let's create a variable. Whoops. std string, and I'm going to call it str for string, and it's going to be equal to hello world. Cool. And this is pretty simple, just str there, and that will display hello world. So let's start with the basics. How can we get the length of a string? Well, it's pretty simple. We just say str.length. Take note of these double brackets there. We do need them. So it's str.length, and this will get the length of a string. And here you can see it's 11. We can also check it by actually counting it, or by selecting it, and then you can see here it's 11 selected, meaning 11 characters. So this is 11 characters long, 11 letters, including that space. You can do the same with size. If I'm correct, that should return the same value, so also 11, because it's basically the same thing inside of a string. Okay, now let's say this string right here is just hello, and take note, I'm leaving a space there. Now below this, we can say str is equal to, whoa, that should be str, is equal to str plus world. This will still give us hello world, because we're saying this string right there, that variable, is equal to itself plus that. So this will return hello world for us. If I were to comment this out, then we'll only get hello. And the reason I have a space here is so that this, when they get added together, it's not going to add a space automatically. As you can see, there's hello. So you will have to add a space manually. So we're going to remove that space, then there won't be a space between hello and world. Now, one thing I do want to show you is that you can shorten this. This str plus, it's kind of annoying saying str plus. So what you can do is you can say plus equals. It's the same thing. It's just instead of saying str is equal to str plus world, instead of saying this, you're just saying str plus equals, which means str is equal to itself plus something else. So if we were to run this, then as you can see, we still get our hello world. Now there's another way you can do this, and this is by saying str.append, and this will append to this string. So I'm just gonna cut this and paste it here. So now string here is going to be appended to it. It's going to be appended hello world, which means added to the end, as you can see there. So yeah, that's pretty neat. Now I'm going to say world here again. Now, one thing we can also do is we can say pop back. And this will remove the very last letter in our string. So in this case, it will be D right there. So now we'll have hello world and not hello world, as you can see there, because we removed the very last character in the string. Cool. Now, what if we wanted to test two strings together? So let's say we had another one here, std string, and then we can just say str2 is equal to, and here we can say hello world. How can we test that these two are the same? Well, one way we can do this is, I'm going to do it in here, is we can say str.compare, and this is going to compare it with a different string, like str2. Of course, this doesn't have to be a variable. You can just put this inside of here as well. That will work perfectly fine. Anyhow, and this will return true or false, or should I rather say 0 or -1. Where 0 means yes, they are the same, and -1 would mean no, they are not. So if I were to make that a lowercase w, because a capital case W and a lowercase w is not the same at all, then we'll get a -32 actually. So it's actually not 0, -1, it's actually 32. So basically, if it's a negative value, it isn't the same. So if we were to add an exclamation mark there and say capital W here again, then now we'll also get a negative value, but this time it will be -1. So yeah, that's the basics of comparing two strings. There are of course multiple ways you can do this. But if the strings are the same, then it will return 0, always. If the strings are not the same, then it will return a different value. For example, if we make this a capital E, then this won't be actually in negatives. This will actually be very high in the positives, like 8,000, as you can see there. Now, we know that this isn't the same because that isn't exactly 0. So yeah, it will just return a value that's not 0 if the two are not the same. Now there's also another way you can declare a string like this. Let's say you don't want to use an equal sign. Well, it's perfectly fine to put this inside of brackets. This is the same as what we've been having this entire time. Just most of the time you'll see it have an equal symbol here instead of brackets, but as you can see, it still works perfectly fine. It's the same thing. So let's say we want to get a part of the string, like this right here. We only want hello of this entire string, right? Then we can say dot sub str for substring, and let's say 05. Now take note, strings, the first letter is index or position 0. Not position 1, but position 0, meaning H is 0. That's where its position is at. So we're saying 0 here to select the first letter, which is that. If this was 1, then this would select the second letter, not the first, but the second, because it starts from 0. Now, if we were to run this, then you'll see we get hello. And actually, I forgot to save. Now we'll get hello, as you can see there. Now this right here says how many letters to go. So in this case it's 5. So it starts here and then it moves 5 letters, and that goes up until O. If we were to say, okay, start at 3 here, but go 5 letters, then we'll get this one right here at the top. Because 0, 1, 2, and then here's 3. That's where 3 is. It says 5 letters, so 1, 2, 3, 4, 5. That is the letters it's trying to get. So if we were to make this 2, that means start at index 3, or position of L, for 2, as you can see there. So yeah, that's how to get a substring, or a part of a string. Before we continue, I would like to talk about escape characters, because they can be very useful. We have, I think, covered them a little bit in the past. But we have multiple escape characters. I'm not going to cover all of them, but I'm going to cover a few of them. For example, \t. This means tab. An escape character starts with a backslash, and then usually a letter to indicate what it is. In this case, \t means tab. So if I say hello, and then world, and let's say I put 2 more \t's here, and an exclamation mark, then now we will get this. So now everything is spaced out by tabs. So that is pretty neat. Same with \n. \n will create a new line. So if we go like this, then now it would be hello, and then on the next line, world, as you can see there. So if you wanted to, you could just do this and put a \n there, and that will also give you that new line at the end, as you can see there. And if you were to remove that, then now you will only have one line, or it will continue at the end, as you can see there. Cool. Now you might be wondering, okay, but if I have a string, how do I add quotation marks? Well, that's pretty simple. You use a backslash and then quotation mark. So like backslash quotation mark. Same with single quotes. You can either use normal single quotes like this, or you can use backslash single quote, backslash single quote. So let's run this so you can see the output. As you can see here, we have single quotes with the backslash and not with the backslash. And here you can see we have double quotes. Take note, you cannot do this with the double quotes because that will split the string. So if we were to do this, as you can see, E doesn't look right and we have a red line underneath it because these two are now two different strings because it basically looks like that. And that's not how it should be. That's why you need a backslash to escape those double quotes right here. Now you might be thinking to yourself as well, okay, now that's cool, but what if I want a backslash? Because backslashes escape things, so how do I get a backslash? Well, it's pretty simple. Let's say we say select yes, and then we want to give them backslash. No. Now we have two backslashes here, which will result in one backslash because we want to just have a backslash, and backslashes are used to escape. I'm just going to go std and L here again. Cool. So yeah, that's the basics of escape characters. There's a lot more, but you can go Google them if you want to know more, like vertical tabs and a bunch of extras, but I'm not going to cover so many of them. I'm only going to cover the most used that you'll probably see. Now let's go here and say, hello. My name is Steve. You should call me by my last name, Van der Westhuizen. And that's actually my true last name, for any of you that may have been wondering. Van der Westhuizen. Anyhow, now we have this very long sentence, and of course you could make this just equal to as well. That's perfectly fine. But I'm just going to keep it like that for now. Now, let's say we want to find a specific piece of text in this sentence right here. Like my, for example, like, hello, my name is Steve. So then we want to find this my there. And take note, we don't want to find this my, we want to find this first one. So what we can do is we can say str.find, and we just say my. And this will search this string for that character or for that piece of string inside of it, and we'll return the position of it. As you can see, it's 7. So if I were to highlight this and go down here, as you can see, 8 selected. It says 8 selected because that's 8 characters, but remember, this returns the index, the position, and it starts at 0. So there might be 8 characters selected here if you start counting at 1. So 1, 2, 3, 4, 5, 6, 7, 8, as you can see. But it starts at 0. So this is a 0, 1, 2, 3, 4, 5, 6, 7. And that's where we get that. It starts at index 7. But what if we wanted to find my from the end instead of the beginning? Like if we wanted to find this one here. Well, then instead of saying find, we can say rfind. Whoa. For reverse find, and that will find the one from behind, the last one. And as you can see here, 47. If we were to select this, go here, it's 48. Just minus 1 and we'll get 47. So yeah, that's how I can find something inside of a string. Now what if we wanted to just find the first of a specific letter? For example, let's say we want to find any letter in A, I, U, E, O. So just vowels. Then we can say find first of, right there. And here I'm going to say A, I, U, E, O. if I were to run this, then we get 1 because 0 and then it finds E at index 1, and E is one of these inside of here. So it's basically searching for one of these characters and trying to find it. If we were to remove E here, then it's going to find O first. So if I go here and I run it, as you can see, we get 4. Because 0, 1, oh, let's go here, 0, 1, 2, 3, 4, as you can see. So we'll find the first of a letter. And of course, you can also say find first not of. So we'll try to find one that's not one of these first. Let's go hello. So it will skip this one, definitely. And if we run it, then we'll get that comma right there at index 5. So 0, 1, 2, 3, 4, 5. Because the comma is not one of these, because it's find first not of, instead of find first of, which is 2 different things, but they work hand in hand. Now take note, if something is not found inside of here, for example, let's remove that Z there, and we were to put Z here, and take note, it's find first of now, then we'll get a massive number. And this massive number just basically means out of bounds. It doesn't exist. So yeah, you can probably like just put an if statement here, which we haven't really covered, but you can put some logic here that says, hey, is the amount higher than, let's say, 1 billion? Then you're going to be, okay, there's probably not 1 billion letters in this string. So then it's probably not that. Now let's say we want to erase everything after Steve. We don't want them to see the rest. So what can we do? Well, we can say str.erase. And now here we can just find out where that ends. Select all of those. It's 23. 23 minus 1 is 22. So it's going to delete everything from here on out. I might have to say 23 though, because it might delete E as well. But we'll see. We'll see if we're lucky enough for it not to delete E. So let's see here, and it did delete E, but it did delete everything after. So there should be 23 then. I was wondering if it's going to include that, but it does include. So now it will delete 20, the rest after, from here and outwards, because this is at index 23 that. So this will be deleted from the string or erased from the string. Now let's say we want to replace my name here from Steve to something else. So I'm going to say str dot, and before I forget, we cannot do this in here because it's going to actually change it instead of returning something. And here we can say dot replace, and it starts with the start index. So in this case, it should be at S. If we go like this, then it's 19. Okay, so the start index is 19. And then how many it should go, so the count. And as you can see, this is a total of 5 characters. So we can say 5. And then we say what to replace it by. I'm going to say Jack. Now if we were to display string here, my name will no longer be Steve, but instead it will be Jack. As you can see there, actually it's sjack, so this should be 18. My bad, my numbers are out of control today. And now as you can see, it's Jack. So that's pretty cool. So you can replace an item in a string. Useful thing to do here is you can say str.find, and we can say Steve. Now that will basically automatically do everything for us. As you can see there, my name is Jack because it found it by this one right there. And then we said how much. Now you could also insert something into this. So let's say we want to insert something to string, so we can just say insert. And let's see. Hello, my name is Steve. You call me by my last name, Thunder, and then you see Visthoi, but there's no Z. We want to add a Z here. So what can we do? Well, first we can find where that is. And of course we could replace it, but I want to show you an example here. And then we say where it should start. And this is going to start here, right? At this index right there, at W. But we want to be at this index up until I, because we want to put something after I. Okay, and that's 6. So actually it's +6, my bad. There we go. So +6. I'm going a little bit confusing here, but it's okay. And we just put a Z there. And that will insert a Z in there. We won't remove anything, it will just insert it in there. Westhuizen. Westhuizen. That's a little bit wrong. That should be a 7 then. Math. Very bad for me. Anyhow, now you'll see it's Westhuizen. Correctly spelled. Of course, it can be used to make something a bit more extreme. For example, let's say we want to add hello there instead of hello. Then what we can do is we can say we want to find the position of this comma. I'm going to go here and just paste that comma there. And now I'm going to add space there. Now if we were to run this, we'll see hello there. As you can see there, hello there. When should you let someone into a bar? If they're 7, no. Only if they are 18. You get my point here. If they are 18, allow them into the bar. I love using these bar examples when it comes to if statements because this kind of works. So let's actually set up a little user here. So I'm going to go std string name. And this we can just say is Jack. Now, if you haven't followed along, this is a variable. I do recommend you go watch my variables tutorial if you have not. It's going to be very important, especially for this tutorial. And I'm not going to cover everything a variable is again, but it is a container. So just keep something inside of it, basically referencing this right here. Anyhow, and then it's a string, so it's a piece of text. Then we have an int, and we're going to call this age. And we can say they are 18. Cool. Remember your semicolons, and also int is for numbers, in case you may have forgotten. Cool. So, what really is an if statement? Well, an if statement is something you can use to add logic to your code. For example, we can say, if the user is 18, then do something. If the user's name is this, then do something. For example, let's create a little bar program here, which I do like. Let's say here, if age is equal to 18, and take note, here are 2 equal symbols. This one here means assign, so it's going to make something. For example, this age is going to become this 18. When there are 2 next to each other, it's asking, is this that? So this assigns and this asks. So 2 equal signs asks, 1 assigns. So if they are 18, then, and the syntax is important, it should be if with these brackets and these brackets. Although you can just use without brackets if you're just doing one thing. I'll give you an example, but I'd never recommend you really do this. And we can say cout, you may enter. Cool. And now here, if I save this and I run, so g++ main.c++-o output, and run that output, then you'll see the program doesn't really change from what it would have initially done. It says you may enter. I'm going to also show you that you can use it without this, but it is recommended that you do use this because it just increases readability. And if you don't want to use these brackets, you can just go to Python or Nim or Lua. Then you don't have to use these brackets. Anyhow, so I would recommend using these brackets at all times. Okay, now let's say we want to check, or let's actually change this. Let's change this to 17 now. So now age is no longer 18. And because this is an if statement, what it's going to do is it's going to skip that part. As you can see there, it compiled and ran without anything. We can even go here and say cout, thank you for visiting. So we can see when it skips, because that will be at the end of the program. And because age is not equal to 18, it's going to skip what is ever inside of this if statement. So it's just going to say thank you for visiting. So yeah. Now what if we wanted to check if they're 18 or older? Because sometimes you don't want just people of the age 18 into your bar or into your whatever location. You want people of 18 and older or 18 and up. Then you can say a bigger than symbol, that one right there, and an equal sign next to it. That means is it bigger or equal to 18, which means I can say 21 here and this will work perfectly fine. If I were to run this, it will say you may enter. There you go. Same with if I were to say 17 here, now it's no longer going to let me enter because 17 is not bigger than or equal to 18, as you can see right there. Of course, you can flip this and make it less than or equal to 18. So now 17 will be allowed because we're saying is age less than 18 or is it equal to 18? And it's saying it's less than 18, so they may enter. So yeah, take note because we're saying it's equal to, I made it a bigger sign again, just take note of that. Because we're saying bigger than or equal to here, if we were to make 18 here, it will still accept it because they are 18, so you may enter. That means from 18, 19, 20 to 100, they may enter. Or actually even past 100, this is just an example. But as soon as we remove that equal symbol, now it asks, is age higher than 18? Is age more than 18? Is age bigger than 18? It doesn't say, is age bigger than or equal to anymore. It's just bigger than, meaning our code will no longer run as we want to because now it looks for ages higher than 18. If we were to change this to 17, so this excludes 17 now, it will allow it because the age is 18 and that is 17. And you see there, thank you for visiting and you may enter. But as soon as we change this back or down to 17, since age is now no longer larger than 17, it's not going to accept it. As you can see there, it skipped it. And of course you can flip this to make it smaller than. So if age is less than 17, so if we go here and we make it 16, take note this is less than and not less than or equal to. It's just less than. Now if we were to run this, then as you can see, you may enter because there's 16. But if we were to make this 26, then it will not run that. As you can see. Now, what if you wanted to exclude a specific age? For example, what if you wanted to say, as long as they are not equal to, so this is not equal to, if it has an exclamation mark and then an equal symbol next to it, it's not equal to. So we can say, as long as they are not equal to 17, they may enter. So we go like this. This is the same as saying equal to, but this is just the opposite. So it will accept everything but. Unlike with equal, that will just accept that. For example, if we said this here, it will only accept 17 and nothing else. If we said this here, it will accept anything else but 17. As you can see, you may enter from 26. If we were to make this 17 here, then you'll see it doesn't say you may enter because it's not equal to 17. As you can see there, not equal. So yeah, those are the most basic operators. We're going to go into a bit more complex thing here. So let's say we want to compare two things here. So let's say as long as they are bigger, older than, or equal to the age of 18, and so this is two ampersand symbols, and they are, let's say, and their name is not equal to Jack. Whoa. Like that. Then it says, okay, as long as they're older or equal to 18 and their name isn't Jack, execute this below. And take note, you can have as many things inside of an if statement as you want. You're not limited really. So yeah, if we run this, then thank you for visiting, because neither of these two are allowed. So if we were to make this 19, age would be allowed. So if we were to run this, then we'll get thank you for visiting, because name is still not accepted. This and symbol here means this should be true and this should be true. Both of them should return true. They should basically be, yeah, it's not. So if I were to make this Jack with an exclamation mark, these two are no longer the same, because name here is Jack with an exclamation mark, while Jack here is just Jack. So let's run this. As you can see, you may enter a bunch of times. So yeah, now take note, this whole thing works on true and false. So if I were to say true here, this if statement will execute, because if true, then execute. So you see, you may enter. If I were to make this false, so no, because true is yes and false is no, then we'll get thank you for visiting. If I were to say not, or let's say I were to say true is not equal to false, this will work because true isn't false. If I were to run this, then it will work, as you can see there. And of course you can put it inside of a variable as well. So I can say, let's say bool and birthday. So let's say if it's their birthday and we say true, right? So we say it's their birthday. So then we can say if birthday, so it's saying if true, because birthday is true, then execute what's inside of it, as you can see there. But if we were to say birthday is equal to true, this would mean the same thing as what we just said, because that with an extra equal sign there, because we just said if birthday, right? That's all we said, just if birthday. But if we say birthday equal true, it's the same thing, because when something is true, that's when this runs. So if we just pass in a boolean in here, it will accept it. So if we do that, then it will accept it. As you can see here, it did. If we were to make this false, however, this if statement won't run, because an if statement only runs on true, and this isn't true. A nice thing that you can do here is, because this is a boolean, a true or false value, you can say not in front of it. This means if not the value in here. So if not false, what is something if it's not false? It's true. So we're going to get you may enter, because not false is true, as you can see there. But if we were to make this true, true, then because there's a not symbol in here, we are going to not get this. Because if something is not true, it is false because it's not true. What we can also do here is, we can check if birthday is equal to false. This is a valid checking. We're checking if this here is false, because this will return true or false depending on what this is. Birthday in this case is true, so it's going to return false on the end of the day, and it's not going to execute this. But if we were to say birthday is equal to false, like that, now if we were to run this, it will accept it, as you can see there, because birthday is false now, because we're checking it. So yeah, now we can continue. So let's say if it is their birthday, right? Or if their age is older than 17. Take note, I'm saying older and not older than or equal to. So if they're 18 or older, then they will be allowed in. But not if they're 17 or younger. And this here means or. That means or. That's this or that. Take note, it's two pipe symbols. It's this symbol right there. That's a pipe. So yeah, for in case you didn't know, that's a pipe. You can find it usually right next to the backspace if you press shift on that backward slash, if you're on a US QWERTY keyboard. Anyhow, now if we were to run this, what do you think will the output be? You may enter. Because age here is 19 and age is more than 17. And this means or, which means if it's their birthday or if their age is older than 17. We're asking or. Unlike with and, not both of these has to be true. Only one has to be true of these. Meaning if I were to make this true, it would still work perfectly fine because at least one of them are true. As you can see right now, yes. And now if I were to make age equal to 1, they will still be allowed to enter because it's their birthday. As you can see there. But as soon as I make this false as well, let's actually say not true. This is valid. This means it's not true because that's a not symbol. So now it's going to say it's not true. It's going to be false and it will not work. The same here, if I were to just make this false, then if we go here and run it, it will not work because neither birthday is true or age is older than 17. So they're not allowed to enter. Cool. So that's all of the basic comparison operators here. So yeah, just for in case that's all there is. Now we're going to continue with the if statement. It's a pretty big topic, so yeah, but we're getting closer to the end. Now let's say we want to display something if this if statement failed, because currently if this if statement fails or passes, it's going to say thank you for visiting. But what if they couldn't enter? What if we wanted to tell them you may not enter? The problem is if we do it here and let's just copy this and we go here and say you may not enter, and we make their age equal to 18, which is more than 17 here, then it's going to say you may enter, but then you may not enter. We don't want that. If they may enter, they should just be allowed to enter. We shouldn't say this to them. What we can do then is we can say else. And else basically means else if this if statement didn't execute, if this didn't execute here, then execute else, meaning we can move that there. Now if we were to run this again, we will not get you may not enter. We'll only get you may enter, as you can see there. But if we were to make this 1 again, then we will not see you may enter. We will see you may not enter. And that's the nice thing about else. It allows you to give a different statement. If this statement didn't execute, then execute this statement. And yet again, you can have as many things in here as you want. So let's say you only want people in your bar if their age is older than 17. And if their age is not older than 17, meaning like 18 or up, then you want to only allow them into the bar if it's their birthday. For example, let's say here if age is more or equal to, whoa, I can't type, to 18, right? Then it says you may enter. And here we can say for 30 minutes. Now I'm going to just add a bracket there, and I'm going to say else if. I'm going to add some brackets here, and instead of this else if, I'm going to say if their birthday. Then what we want to do is we want to say cout you may enter for, and in this case we're going to say 10 men. So they may enter for 10 minutes if it's their birthday. And I can actually remove that. And that's pretty neat. So if their age is older or equal to 18, then they may enter for 30 minutes and it will skip this. If it's their birthday, however, and they are not older or equal to 18, then this will execute and these two will skip. However, if both of these did not execute, then else will execute. For example, let's run this. Currently we'll get you may not enter because none of these are true. If I were to make this 18, however, and we were to compile and run this, then we get you may enter for 30 minutes. If we were to make this birthday true, sorry about that, I had to go in for a call. I was about out for like 20 minutes or so, where were we? Okay, I can't remember where we were, so I'm going to assume we were here. Now, you may enter for 30 minutes. That's there. Okay, so this didn't execute because this right here, this executed, meaning this won't execute. It goes from the top. If the first one executes, then the rest will be skipped. If the second one executes, then the rest will be skipped. If the third one can execute, because you can have as many here as you want, you can have as many if-else statements as you want, just not in such a terrible way that I did it, but there. You can have as many as you want. It's possible to have a ton of them. Cool. But if we were to make the age 17, because then it's not bigger than or equal to 18, so this will be skipped. This is going to check that the birthday is true, and then we're going to get you may enter for 10 minutes, as you can see there. So you can check if something is this. If it's not this, then check if it's this. If it's not either of these two, or 3 or 4 or 15, however many you want here, then execute this. Okay, now that we have that underway, we are very close to the end, so do not worry too much. Do not fret. Okay, so I'm going to remove this part right here because this is going to be as an example. Now what we can do as well is we can check inside of this if statement, if birthday. And here we can check, or here we can then say cout happy birthday. So now we have an if statement within an if statement, basically saying, also you can do this, you can either have them like next to each other like this, or you can have the brackets like this. It's optional, it's up to you. I do prefer my brackets like this because it just, to me, it makes more sense, but a lot of people do this. Anyhow, so now what's going to happen is if this if statement executes, then it's going to check if it can execute this if statement. So it's just like a normal if statement, but in a different if statement. So if I go here, make that 19, it will execute both. It will say happy birthday, as you can see there. Now what we can do is, if I were to make the birthday here to not true, remember that makes not, so not equal to, it's going to be false now. So as you can see, it says you may enter for 30 minutes, but it doesn't say happy birthday because birthday is not true. Cool. Now let's actually mix and match a bit here. We can here now go and say if birthday and name is equal to Jack, and take note, you can do this is equal to true, and you can also put these inside of brackets because you just can. So like that. That is allowed. You can also have more here, for example, or as an example, but this can also be an and if you wanted to. So, or let's say age is equal to 25, for example. And then what we can do is we can wrap these inside of brackets and say, execute this. If this returns true, or if this returns true, then execute this. But anyways, yeah, let's keep that there just as an example. And now here we can say, happy birthday, Jack. Let's say Jack is a very important customer. He goes to the bar every day, which you should not do, but he goes to the bar every day. So then you say that. And just ignore this or here because it doesn't really fit with the story. But anyways, now let's say if this is not the case, then we can say else if birthday. So then just if it's their birthday, because let's say this returns false because it's their birthday, but their name isn't Jack, so this will return false. Then this whole thing may return false. Anyhow, if this wasn't here, if we were remove that, I'm gonna remove. No, let's keep it because I want to do an example of it. Anyhow, then we can do this, and we can say happy birthday, but not to Jack, just happy birthday. Else we can just skip it and say cout it's not Or actually, to show you don't need it else. Else is optional. Same with else if. They are optional. So this is perfectly fine as well. If we were to execute this, then we'll get, you may enter for 30 minutes. But because birthday is false, it didn't execute this. But what we can also do is we can say age is equal to 25. This will make this execute. As you can see there, happy birthday Jack. Even though birthday is not true and the name isn't Jack, because we have an or statement here, and take note this is inside of brackets for a reason now, because this should compare first. So it's going to check if birthday is equal to true, and then it's going to check if name is equal to Jack. If both of these return true, then this whole thing will be true. If one of these two return false, then this whole thing will be false. And then it's going to throw this or in here. Or and, if you wanted and in here as well. So yeah, that is that. I'm going to remove that because it doesn't fit with the story. And then we can also remove a pair of brackets here. Cool, and these brackets are also optional. I just put them in here to make it a bit simpler because I find it easier to read if there's brackets, but you can do that. That's perfectly fine. Anyhow, so now we can check if it's their birthday and their name is Jack. So if we go here and make their name Jack, then, or actually let's keep their name Jack with an exclamation mark and make their birthday true, right? And if we can compile this, then we'll get happy birthday, because it is their birthday, but their name isn't Jack, so this will not execute. If we were to make their name Jack by removing that exclamation mark, then we'll get happy birthday Jack. As you can see there, happy birthday Jack. So yeah, that's the basics of this if statement. You can have if statements within if statements. You can have if else. You can have else. You can have a ton of comparison operators here. So, you know, equal to, which is two equal symbols, bigger than or equal to, less than or equal to, bigger than, less than, not equal to, and there may be one more, but I might be forgetting it. But I think that's all. So yeah. Now there's one more thing I want to show you. Then we are finally done and you can continue with your life, because this is a very long tutorial. What I'm going to talk to you about now is called ternary operators. Damn, that's a difficult thing to say. So this basically is like a one-liner if statement. It's amazing. So if I were to show you something like this, let's say value here. And I'm just going to print the value here. I'm not going to use an if statement. It's not really necessary. So value. Then what we can do here, take note, it's still a Boolean here because I'm just going to compare a few things. And let's say here int cool age is equal to 25 as well. Now if we were to go age equal cool age, then this will return true, right? So it's just a normal if statement, but we store it inside of a Boolean value. So it returns 1, which is the same as true, because true is 1. If we were to say not equal here, then we'll get a negative value, if I'm not mistaken. No, we'll get 0. 0 means false, and any other value than 0 means true. For example, if I were to go here, I were to say if, and I were to say 0, or didn't say anything, but okay. Then I can just say cout anything here. If I were to say 0 here with this if statement, it will not execute this because 0 means false. But any other value, if you were to say negative 999 here, for example, it will execute because it's a truthy value. Anything other than 0 is true. So yeah, that is why we got a number here. But yeah, this is just a normal if statement or a normal Boolean value stored inside of this. So it's the same as if you were to put a value in here, for example, age is equal to cool age. For example, if we were to make this equal to there, these two are exactly the same. But in this case, we can just throw value in here because they're exactly the same. Anyhow, that's not what we're discussing, but it's just cool to note. So let's say here, for example, we have a little string here. Now let's say, let's call this value as well. Let's say if they are the cool age, if their age is the cool age, then this should contain they are the cool age. Now one way you can go about this is we can say if age is equal to cool age, right? Then we can say value is equal to they are the cool age, else value is equal to they are not the cool age. This will work perfectly fine. So if we were to do this and execute it, then they are the cool age. But if we were to make their age 21 instead of 25, then it will say they are not the cool age, as you can see there. Now, what have I told you? We can condense this into one line, into one simple single line. By doing this, if age is equal to cool age, then, so this question mark means then, and we can just paste this in there, and that should be one equal, not two equals. So if their age is equal to cool age, then they are the cool age, and we just copy this. Else, so else, that's a colon, we can say that. So I'm going to just delete that. So we're saying if their age is the cool age, then they are the cool age, then this value will become this. That's what's being said here, then this. Otherwise, they are not the cool age. If we save this, then we'll get they are not the cool age. But if we were to make age here equal to 25, then it will say they are the cool age. And of course, you can break this into multiple lines, for example that, and then we can split this into the next line, and then we can split this into the next line, and that's perfectly fine because C++ works with semicolons, so you can split things into multiple lines like this. So yeah, that's the basics of it. You can of course also use this as you don't have to necessarily store something in here. For example, if we said this age is equal to cool age, and then we did this cout, and that should have std in front of it, and then we were to go here to the end and just say std and val, then this will work perfectly fine as well, because we're not storing it inside of anything. We're just saying if this, then this. Take note, this is just an if and else statement, this. So if this executes, then that. So if this executes, then this. Otherwise, go for the next one. So in the previous video, we covered if statements. For example, if we had a number, let's say int day of week, for example, and we made this something like 2, then if we were to say if day of week is, let's say, equal to 1, then it would give us Monday, for example. Then let's say it says return Monday or something. And then of course, if we then said else if day of week is equal to 2, then it would be the same process, but this time instead of Monday it would be Tuesday. I'm just going to do letters like that, make it simpler. So then it would be Tuesday, and then it goes on and on like that until we, and that should have to be a semicolon before I forget, and that it will just continue like this on and on until we have reached the 7th day. So dot 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 dot, and then we can say else if day of week is equal to 7, then it should return Sunday. like that. And then after that we can do something like else, and it's a return invalid day of week, something like that. So that would be the basics of the if statement version. So what I am going to do is I'm going to create a string here. So I'm going to say std string, I'm going to call this day. So day of week would be the number and day would be the actual day. And I'm just going to do that. I'm not going to assign it to anything just yet. So the idea is that we create this if statement in a way that is either similar or easier to read, faster in terms of performance, and just faster to type. Now, this method I'm going to show you isn't that much faster in performance. Some people will say it's so much faster, but to be honest, most of the time you won't really get that big of a difference with this next method, so it's mostly up to personal preference. It's not just because someone says it's faster does not mean it necessarily is in all scenarios. Anyhow, so it's called a switch statement. It starts with switch, and then in here you specify the variable you want to check. So this variable, we want to check this variable, so that day of week. So I'm going to specify day of week. Now once we have that, we can just do this, and this is the start of the switch statement. Now we're going to say case, and in this case we can specify one case to do. We can check on one case. And take note, I believe in C++ at least, switch statements only support at integers and maybe floats. I'm not really too sure about that. I will test that in a second, but I'm pretty sure it only supports integers. So if you want to work with something else that is not an integer, it's recommended to then just go for an if statement. Anyhow, so let's say 1 for example here. Now this will check for the case of 1. This right here, this part here, is exactly the same as saying this. It's exactly the same. And now here we can say colon. Take note, the syntax here changes to a colon and no longer brackets. So it's colon. And here we can say return, or not return, I'm going to say day will then become Monday. And then we can say break. Now this is also just my personal preference in terms of how I format it. I like to do that because that makes me see that, okay, so this is the end of it and this should have a semicolon. And this is the end of this case. But some people also like to do this and others also like to do this. I just personally find it most enjoyable this way. Okay, so this right here is exactly the same as this if statement right here. They're basically the same thing. The difference is here we just set day equal to Monday. So if we were to replace this return here with that, it would be exactly the same thing. Day would become Monday if this was 1. And then of course we can then make this to do something more. So now here we can say, 2. So now that will be 2, and here we can say 2, and I'm going to go with 3 letters again, like that. Let's actually do it for the whole week. So 2, 3, 4, 5, 6, 7. So here we have a 3, we have a 4, we have a 5, we have a 6, and we have a 7. And now here we can say day is equal to Wednesday, so wed, and here it would be equal to Thursday, Friday, Saturday, and Sunday. Now this break here, this is there for a reason, because if this case statement, that's also why people like doing this, but if this case statement executes, then we want to break out of this switch. That's why that break exists. If it wasn't here, once it does this case, it will look through all of the other cases as well. But here, once it finds this case, it's going to break out of it. That's why there's a break here. See out, and I'm going to see out the day here. Now if we were to run this, we'll get Tuesday, because day of week was 2, and we checked the day of week against 2. That's what we did. if we were to make this, let's say 6, then now it would be Saturday. But the thing is, what if it's 8? Because there are no 8 days in a week. We'd get nothing. Because here it only covers up until 7. So if none of these actually hits anything, it's just going to skip it. So that's what's happening here. It is not going to do anything. And take note, you can also put more things in here before we continue. For example, you can put another if statement in here, and with some sort of condition, and then you can like see out. It isn't just limited to something like this. You know, you can do more of it than that. Whoops, more of it than just do one thing. So you can do multiple things in here. I'm just doing one thing to keep it simple. It's just like an if statement. You can even have multiple case statements within a case statement, and you can have whatnot. Although it's not very common to see a case statement within another case statement. Kind of weird. Anyhow, now with an if-else statement, we have an else. And that else gets executed if the if statement doesn't execute. For example, if the if, and then we have our else if, and if that doesn't execute, then we have our else. And then the else will execute. So if this executes, these will be skipped. If this executes, these will be skipped. Or that one will be skipped. If neither of these two execute, then this one will be executed. So yeah, that's what we have with an if statement. Well, with in case statement, we have the same thing. We have a default. And this is what it will default to if this is what it will default to if none of these up here, if they execute. So we can just say day is equal to invalid day entered. Now if we were to run this, and of course if we were to have a semicolon there, if we were to run this, then we'd get invalid day entered. And here with the default, the break is also optional. You don't necessarily need to add the break because this is what it will default to. And since it's at the bottom, it's not going to necessarily need to do anything else. So that break doesn't need to be there since it will automatically break out since it's at the end of this right here. And it's because it's the default value. It's what will execute if none of these above executes. So yeah, that break is optional. So that's the case statement. It's as simple as that. It's basically an if statement, but it's a little bit different in terms of how it functions. You know, instead of having to say if day of week is equal to 1, then do something. Then else if day of week and is equal to 2. Else if day of week is equal to 3. Instead of having to do that constantly over and over and over again, we just have day of week. Is it 1? Is it 2? Is it 3? Is it 4? And that's why I also love this, because it just decreases the amount of typing you have to do. Because you don't have to say day of week constantly over and over. You just say what you want to change and you say break. And that's it. After that, you don't really have to worry. Now let's check it, because I'm pretty sure it only works with integers and maybe floats, but I'm pretty sure just integers. So here I'm going to make that equal to nothing, and here I'm going to make this equal to Monday. And here we can see if it works, because I myself am not sure. So I'm going to switch this to day because we want to check day. Let's see here. Yeah, this constant expression has type int instead of, okay, never mind. And here we can of course say Monday. And does this go away? This constant expression has type char pointer instead of required std string. Okay, that means we can just say std string. But we could have said char pointer as well. We haven't really covered it, but doesn't really matter too much. And now here we have expression must have a constant value. Whoa, okay. Let's say const. Wonder if that will work. Nope. Okay. So I'm not quite sure if a string can be used, but I'm pretty sure a const char pointer should. So let's say a const char pointer. And I know we haven't covered this, but just bear with me for a second here. And let's see. And it works. So it does work. And then here we can of course make this day of week. Control C and then Control, and we can just change all of these to day of week. And yeah, boom, day of week. And then here we can just take all of these and we can just replace them. And here, if it's by default, it's just going to be 0, then we're not going to care about it. So if we return 0, it means there wasn't a valid week. And in here, of course, we can then say something like a day of week instead of day. Whoops, DC, and then we just paste it there. Okay. And here it switches day. And yes, here we go. Expression must have an integral or enum type, so it has to be a number. So with all of this effort, we still came out on the end of the day where we are not allowed to use chars or strings. Now, before I continue, I just want to explain this. Basically, it's a string. That's what it is. It's basically a string. It's just a constant, so it cannot be changed. That's what const means. It means once it has been declared, you cannot change it. Yeah, so that's the basics of a switch or case statement. And that's also a little bit of the basics of this. You can just think of it as a normal string. You know, it's like you have a bunch of characters mashed together, just like with a normal string. Just this time we call it a char pointer or a const char pointer instead of, and that's a pointer. We'll be getting to pointers far later in the tutorial, but right now it's not important. But yeah, it's a string. So yeah, this is a basic if statement, but it only works with enums, which we'll be getting into in the future videos, and integers. So in this tutorial, we'll be covering getting some basic user input, but from the file in the terminal. Now you might be wondering, wait, what do I mean? But I mean by passing in arguments. For example, let's see this dot output there. So we were to go like this. Now, this piece of code, that doesn't matter. Just imagine it's just that output. It's just that. And we were to run it and say, Jack 18, for example, we can actually get these arguments. So let's actually get started with that. So the reason I always tell people to include this, whether they're going to use it or not, because it's optional to include it. You don't have to include this. But it's because this right here allows us to work with this right here. That's what it does. So let's actually use the basics of this. So argc is the amount of arguments that's getting passed in. That's what this one right there is. It's an int argc. We can check it out by saying cout, and then instead of printing out a string, we can just say argc. Now if we were to run this, and let's just run it like that, we'll get 1. And I'll explain why we get 1 in a second. If we then say 99 and Jack or something like that, we get 3. Now the reason we get 3 here, even though we just passed in 2 things, is because it also takes the executable name. So the executable itself, it always passes that in as well. So this is number 1. That's why we got 1 there, because it took this into itself. Then this would be number 2 and this would be number 3. That's the basics of that. Now accessing them, you can do that with argv. It uses an array type syntax, which if you don't know what it is, don't worry, we'll cover arrays in the future. But by going argv, and in brackets we can say 0. 0 is the very first item in this packet right here. So it starts at 0, not 1. Take that as note. It always starts at 0, not 1. So if we run this, we'll get output, as you can see right there. If we want to get 99, then we can just say 1. And that will give us 99. If we want to get Jack, we can just specify 2 here. Then that will give us Jack. Note, if you want to specify something that does not exist, for example 4, because there are not 4 elements there, then it's just going to give us shall equal bin/bash. It will give us something different if we say 3. As you see, it will give us absolutely nothing. Now the reason it does things like this is because some other things are also being passed in and stuff like that. Usually you don't have to worry too much about it. But if you try to access something that's not there, it might try to access something that you don't necessarily want. As you can see here, it throws out a bunch of environment variables because those get passed in as well. But take note, if you were to add more here, so let's see, we need 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to add a 10th one because remember, it starts counting at 0. 1, 2, 3, 4, 5, 6, 7, 8. And now we're getting to 9. Because remember, this is 0. This is 1. So here I can just say big human or something. And then we get big human. So these variables right here, these environment variables, they'll get moved on further the more items we add. So you should just make sure that the item you add in here is never more than argc. Because if it's more than argc, then that means something's probably going to go wrong and you don't want that. Now before we get into the video, I have a new way of compiling my code. It is actually the same thing, but it's in alias. I'll explain what that is in a second. So usually if I compile my code, I'll say g++ main.cpp-o output and then run that output file. And then if I run it, then we get this. I found this to be too long, and because all of my files, especially when I do tutorials, is always main.cpp-o output/output, and even some very basic programs are this. I decided I'm going to create an alias so I don't have to do this anymore. So if I were to just open up my bash rc, then here we go. So if I go all the way down, as you can see, I have an alias called cpile, and that just means I can type cpile here and it will execute this code for me. I have a bunch of things here, for example, image for this piece of text that I always forget because sxiv, that's very difficult to remember, player because I always watch with 4 threads and that this aspect ratio, and then with Django I can just say python manage.py, or I can say dj and then I'm good to go. And in cpile is of course all of this, but now I don't have to type all of this, I can just say cpile. So that is what I did. I added that alias, so that's pretty neat. So I can just say cpile. Whoa, there we go. As you can see there, we get hello world. Cool, now let's get into the video. So what is a function? Well, you actually kind of already have seen a function and have been working with it for quite a while. This right here, this is called the main function. The main function of the program. It's the main part of this language. If you execute a piece of code, it's going to search for this main function. But what if I told you we can make our own functions to work with this main function? For example, and just bear with me, I'll explain all of this in a second. Void say hello. And now here we can just say cout hello. And now I'm just going to go here and say hello. If I were to compile and run this, you'll get hello. So we basically created a function. This right there, that's a function. It kind of behaves the same as this main function right here in a lot of similar ways. There are a few differences here and there. So what does this void mean before we get into a function itself? Void means it doesn't return anything. As you can see here, we have a return 0. And here we have an int, because this function right here returns an integer, as you can see right there. This is what it returns, and then with return you can return something. So if this was to be, let's say, an int, then I'll have to say return, and I'll have to like put a number in here for it to return. Void just means it doesn't return anything. It's basically just executing some code. Cool. So that's the basics of a function. You can later on then call that function. So this, let's say this function has a ton of lines. And instead of having to copy and paste all of these, let's see, 12 lines, is that 12 lines? Yes, all of these 12 lines, you can just, boom. And now it's 12, 24, 60, 36, 48, and I believe that's 60. So it's 60 lines of just hello. So yeah, that is what's very useful of functions. So you can call a function over and over and over again to basically give you the output you want. It's kind of a way to stop you from copying and pasting code. Like you could just create a function here and then use that function at multiple places instead of having to copy and paste the code every time. Cool. Now let's say we have a function that returns hello and then the user. For example, hello Jack. Now the thing is, how do we know the user's name is Jack? Well, we can actually set that by going here, these arguments. We can give our own arguments. I'm going to say std : string, and I'm going to call it name. This means we can enter a name here, and that name we can now do this with. So it's just like using a normal variable, but it's now inside of here. So now, as you can see, we have a little red line here because it's asking for this name variable right here. So if I were to pass in, let's say Luke. Now, if I were to run this, we'll get hello Luke. So we just made our code dynamic. By passing something in here, we can change the output every time. So let's paste this 3 times and say Mark, and now here we can say Jack. Now if we were to run this, we'll get hello Luke, hello Mark, and hello Jack. So you can insert a bunch of variables in here, a bunch of arguments. Cool. Now let's use a different example. Let's maybe use a function that will return the sum of something. For example, float sum. And in here we want to take in 2 numbers, a float num1 and float num2. And then we can say return num1 plus num2. Okay, now let's quickly explain this because to some this might still be like a foreign language. What did we just do? Well, we created a function called sum. This function will return a floating point value. This could also have been a double or an integer depending on what you prefer. Now we're also taking in floating point values, so 2 float numbers, so 0.12 or 5.37, and they were returning it. Of course, this could have been splitted into multiple lines. For example, we could have said float answer is equal to num1 plus num2, and then we could have returned answer. That would have been fine as well. I just made it 1 line because it was just as simple, because you could have just passed this in. You might want to say something like cout calculating dot dot dot, and then returning the number. So yeah, we can do that. And now if we go down here, we can say sum, and let's say 2.8 and 3.1415. Take note, it returns something, so we need to actually catch that return, otherwise it's not going to do anything for us. So we can say here, let's say float number is equal to sum, and then with those numbers passed in, and then we can cout number and number. This might look a bit confusing, but let's just run it so you can just see what we get. So first we get calculating. So what's happening here is when we run this sum, it's going to say calculating. It's going to get that value, that answer, and it's going to pass it in to return. Whatever is inside of return will be passed into this right here. And since this returns a float, this also has to be a float. You could have also, if you didn't want to put this inside of a variable, you could have just done this. That would have been perfectly fine as well, because this return we then just have replaced here. So now if we run it, we'll still get the same output. And we're actually getting number calculating, which is really interesting, because we're putting it here. So it's a number, and then we're actually printing out calculating while it's still printing out. So that's why we're getting that. So it's actually better if you were to then just do this, because then you would get the normal one. But yeah, let's do another example. Instead of using, let's say, a float, let's do maybe cubing. You of course don't have to do math with it. I'm just doing math because that's what I find the easiest to kind of do, to kind of show examples with, because it's so simple. So let's say int cube, and in here we can say that is equal, and in here we can just say int num. Of course, this doesn't necessarily have to be an integer. This could be a float as well, but then we don't have to convert it from an integer to a float because it returns an int. So then we can just say return num times num times num, like that. And in here we can just say cube, and let's say 5. So that's 5 times 5 times 5, which should be about 125. Yes, there we go. You can also give things default values. For example, let's go back to the function say hello, and let's make this time return something instead. String say hello. And here we can say std string name, and I'm going to say is equal to Jack. And in here we can say return hello, and then we can just pass in, Jack, like that. And then here we can say hello, and that should not be hello Jack, that should be name. Like that. And in here we should also just do that. Now if we were to run this, we'll get hello Jack. And that's the nice thing about this. We can give it a default value for in case someone doesn't enter a value. So it will be hello Jack. But if we were to change this from Jack to, let's say, Mike, then it won't say hello Jack, it will say hello Mike. So that's a nice thing. You can give these variables or these arguments, you can give them default values. So later on, you can use them without a problem. So you can either add a value in there, or if you don't necessarily want to add a value, you don't have to. So yeah. Now one last thing before we continue is, what if you want to have this main function on top? Because I know some people prefer having their main function at the top because it's their main function. That's the main thing you would want to look at. But the problem is, if we were to do this, it will cause a problem. Because of how C++ reads code, it reads from top to bottom. So by doing this, C++ does not know say hello exists, because it goes through and it's like, okay, let's run here. It doesn't see anything yet. It just goes, oh, say hello. But it doesn't know what say hello is because it hasn't read it yet. So now if we were to try and run it, we'll get a problem because say hello was not declared, even though we declared it down here. So a way to get around that is to just copy this right here, go up here, paste it, and just remove the defaults. This will tell C++ this function does exist, but we declared it somewhere else. So C++ will know this exists because we told it it exists, even though we first declared what it actually does down here. So if we were to run it now, we'll get hello Mike. So what if we wanted to, let's say, do this? Well, there's a problem. C++ doesn't know that there's a default value. So we can move that default value from down there and put it up there. My bad for actually removing it at the start, because it is actually kind of required if you want it. Then if you run it, you get hello Jack. Take note, you should not have your default argument here anymore. It should be here, not here. If it's here, you're going to get an error. If it's on both, you're going to get an error. So it should be here. So C++ knows that it has a default value. Otherwise, it's not going to know it has a default value. And when it gets here, it's going to be like, oh, that's kind of strange. So let's start with just creating a basic output. So I'm going to just cout, and I'm going to maybe say sum of 10 and 9. Now what I want to do is I want to create a function that returns an integer. I'm going to call it sum. It's going to take in an int 6, or int 6, int x, and int y. Then here we can just say return x plus y. Now this works like any normal function would work. As you see, it can add those two together. But now the problem is, what if we wanted to do a double in here? A floating point value. So let's say 10 point and then a very long number after it, like that. What if we wanted to do that? Because currently it will still work, but it's just going to return 19. Because to it, this just gets removed. It's not important because it takes in integers. So a way to get around this is by just copying this piece of code you have, and then to just take all of the types and double it. Now this is called function overloading. It is when you have the function with the same name, but different arguments. For example, here you can take in integers, and here you can take in doubles. Take note, I am using doubles here instead of floats, because integers and floats have a very interesting connection to each other in C++. So just use doubles to be safe so you don't get any problems. Anyways, so basically it's the same code, but now it will figure out which one we want. So here you can see it's 20.1549. And if we were to go here to remove that floating point value to just that, it will be able to tell the difference between, do we want an integer or do we want a double? Do we want to call this sum or do we want to call this sum? Based on what we pass in. We could even say convert it to an integer, return an integer. I don't know if this won't give an error, but yeah, see, it works perfectly fine. So as long as these change, you are able to overwrite a function in a sense, to overload it by giving it another meaning. And the same can be said with, let's say we have a function that says hello. So let's say void say hello. And this one takes in a string called name and just returns, or it actually just counts hello and then the name. Now if we were to go here and say hello Jack, this normal function as we learned in the previous video, and we're to add our semicolon, then we get hello Jack. Now we can actually take this and we can expand upon it. So now we can say, instead of just that, we can maybe add an int here, that's age. And then here we can pass in and then of course we have now two of these functions with the same way of executing, but now it's a little bit different. And now here we can say int age. And we can select something like 29. Both of these will work perfectly fine. And it knows which one to search for because of the parameters that it take in. This one could even return, let's say, an std string. And then instead of couting this, we could just return it. So the output can change. Everything can change. I'm not going to actually do that because that's going to be a lot of typing. But the output can change. And everything can change, but the name can stay the same. That is called function overloading. You could even, if you wanted to, remove the name. That is perfectly fine. And now we can just say, you are 8 years old. And in here we can of course remove that. And this will work perfectly fine. If we were to convert this into a void, again, because it shouldn't be returning anything. Here you see, you were 29 years old. If we were to remove that part there, it would look better, but you get the point. So you can basically have a function of the same name, but that takes different arguments and even returns something different if the time calls for it. Now, when should you do function overloading? Let's say, for example, the first one we had, where we had a sum. So if we go back to our first one we had here, so let's go back to sum. There we go. If we go back to this is a great way to have it, because now you can do sum, but you can have multiple types. So as you can see here, this is a great time to do this. Now, when shouldn't you do this? Basically, when the functions have nothing to do with each other anymore. If you say sum, but you take in, let's say, std string name, and now you just basically return the name, and this can also become an std string, like that. This function has nothing to do with the original sum function. So by doing this, you're basically just going to confuse yourself, because what does sum have to do with name? Unless you actually have a good reason for it. So do function overloading when you have two functions that do basically the same thing, but just change in types. But don't do function overloading when you just want to add another function, but you are too lazy to give it another name. In this case, you could just say return name, like that. Then you would know this is a completely different function, and it's not really going to do the sum of anything. So what is a recursive function? It is a function that calls itself. Now, I don't really know too many good examples with it, because usually if I use it, it's with pretty large programs, so I didn't really have very small examples of it. But there's one example I always find kind of useful to see. So you might know something like the factorial, where basically, if I were to just open up a live environment here, let's say we have 4, right? The factorial is basically like saying, if you know this symbol right there, the exclamation mark, it's basically like then saying, why did I do that? 1 times 2 times 3 times 4. If you entered 4. If you then entered 5, let's say, then you get 1 times 2 times 3 times 4, right, 4 and then times 5. Like that. It depends on what you enter, and then you'll get a specific number with it. For example, here it'll get 24. We're going to be creating that, and we're going to use recursive functions to create that. Now, there are more ways to do this than using a recursive function, of course, but I feel it's a pretty good example of what we can do with it. So let's create a function that returns an integer, and we can just call it fact for factorial. And in here we can also take in an integer. Whoa. Cool. Now what we need to do is we need to basically call this function as well. So let's actually go I almost said console.log, cout, and let's just cout number, just to show you what happens if you call a function on itself. And we can just say num. And then we can just say return fact. And then we just pass in num again. Yeah, let's go like that. But yeah, let's do that just to show you what happens. And in here, we can just say fact, and let's say 28. And let's just add a semicolon there. Now, let's compile and run this and see what we get. And we actually get an error because I forgot to add my semicolon there. And as you can see, it's just basically a while loop that just returns 28 the whole time, because it calls itself when it returns it. So basically it says return, and then it calls itself and passes in this number it got. So if we were to make this +1, then look what would happen now. The number increases with 1 with every iteration. So that is basically what's happening. We're just calling the function inside of itself, and we're just passing in the same arguments but maybe modified. Now let's try and do some factorial stuff here now that we know that. So First, we need to put an endpoint here because we don't want it to run forever and ever and ever. We want it to stop at some point. So I'm going to say if, and we can say num is equal to 1, because if the num is equal to 1, then we don't have to worry. Because, for example, let's go back here and we say 1 times 2 times 3 times 4, we say that, we get 24. But just like with normal math, if we were to remove that 1, we'd get 24. Because anything times 1 is itself. So 2 times 1, that's itself. 24 times 1, that's itself. That's very basic math rules, but some people may not know that, so just in case you didn't, then there's a good refresher or something you might want to know about. Then we can just return 1. And then here we can just say else, and then num, and we can just say return num times factorial fact, and we can just say num minus 1. And this will work perfectly fine. I'll explain what's happening here in a second. So let me just put the factorial of 4 here maybe, because as we know, that is 24. So let's go here and put it here and see if we actually get what we expect. And whoa, we do not get what we expect. And that's because this is 28. That should be 4, otherwise it's just so big it goes into the negatives. My bad. There we go, it's 24. Now what's actually happening here? Because some people might be a little confused on what's going on. How is this possible? So let's walk through it step by step. So first we create an integer, or we create a function. Then when we call that function, let's say we pass in 4, right? So we pass in 4. Then we go here and we check. Is 4 equal to 1? And no, it's not. So it's going to go to this else statement here. And then it's going to say 4 times fact 3. Because we're minusing that number by 1. So it's going to be 4 times 3. Cool. Now here we pass in 3. And then here we have 4 or 3. Is that equal to 1? No, it's not. So it goes here and say 3 times 2. And it just continues like that. And take note, it returns this. This is what's being returned. It might be a little confusing, but it's actually returning this to itself. That's interesting, right? So basically, if we go all the way to where it's 2 times fact 1, which we just return 1 on the end of the day, let's go here and just say 4 times fact 3, like that. So what it basically just does is it takes this and it times them together. So 2 times 1, that's 2. So this will give us 2. So let's just go 2. Now 3 times 2, that gives us 6. So this will give us 6. And then 4 times 3, that will give us 12. But this isn't times 3. This is times 6, because remember, this 3 times fact 2, that actually returned 6. So this here is 6. It's not 3, it is 6, because it returned a 6. This right there, that's what it returned, because it has a return statement here. So it's not that, it's actually 4 times 6, because that's what it returns. And if we count that up, it's 6, 12, 18, 24. Like that. And that's how it works. It might be a little confusing, but that's the thing with recursive functions. Oftentimes they can be confusing, so you should be careful with how you use them. Because if you use them in a way that can be confusing for others to read, it could just discourage them from working with the code. And maybe you come back in the future and now you have to kind of just draw out what's happening. Kind of like what we did now. But yeah, that is, all in all, a recursive function. It's just a function that calls itself. Oftentimes, there's not really too much of a use for them. But there would come that occasion where, oh, you know what? I could probably speed up my code. by using recursive functions. If you have heard anything about memoization, you would know that that probably uses recursive functions. It calls itself. If you don't know anything about memoization, you don't need to know anything about it, but if you want to boost your skill on this, then I do recommend you go learn up on memoization, because that could help you with recursive functions. So what is scopes? Well, scopes is basically kind of a way of saying, okay, this is restricted to this code block. You'll hear about things like global scope and local scope, and we'll cover both of them. For example, this would be called a global scope variable. So let's say int x is equal to 15. Now int x can be accessed anywhere inside of this file. So if I were to go here and just say x plus 9, then that would work because x is global scope. And you can have as many global scope variables as you want, so we can even make this y, and we can say x plus y. That would still work perfectly fine. Like that. And then even if I create a function, so let's say here int sum, and let's just say num1 and num2, and here we say return num1 plus num2, right? And we should just probably specify that these two are integers, so int, and in here I would just say sum x y. That would work perfectly fine, just as we can see. And if we were to replace this with x and y, not even use that right there, so we can literally just pass in random values here just to make sure it is what we expect, then we get 30, because these are global scope variables. They can be used from anywhere. If we say x, then it's going to look and it's going to find a global scope variable. It's usually not recommended, however, to use global scope variables. The main reason is just because they get in the way, and it's not good practice. Because let's say we have a global scope variable x and a local scope variable x. So let's say here we have int x is equal to 20. What's happening now? Now we have two x variables. If we save the code and we run it, we get 30. If we were going to pass in x and y in here, and we were to run this, what would we get? Would we get this x variable? Or will we get this x variable? Because this one will allow us to return 30, while this one will return 35. Well, let's see. So let's just turn these into nums. So num1 and num2. Otherwise we'll anyways just get 30. Like that. And now let's run it and see what we get. We get 35. And that's where it comes into play. Now I have a global scope variable x and a local scope variable x. And they're different numbers. But this one will always go for the local scope variable first, because it takes priority. It is part of this local scope. This x variable cannot be used inside of sum, because sum just isn't accessing this x here unless we pass it in here. If I were to comment out this x right there, sum would not know what x is if we did that. As you can see, we already get an error here. Identifier x is undefined because x doesn't exist in the global scope and x does not exist in the local scope here. So if we run this, we're going to get an error because what is x? And the same here. So let's say I were to go here and say int x is equal to num1. What now? Because now we have an x here and we have an x here. But this x is being redefined. So let's see what we get. We get 35. So that is kind of the difference between local and global scope, because a local scope variable is only accessible within its function or class, which we'll be getting into later. As you can see here, these x's can only be accessed within themselves, Well, this X right here can be accessed anywhere inside of this file because it is a global scope variable, whilst this is a local scope variable. But what if you did want to actually pass in the global scope variable in here? What do we do then? Well, then we can add 2 colons here. These 2 colons will basically tell C++, hey, this should be a global scope X and not a local scope. And that means if we were to run this, we'll not get 35, but we'll get 30, because now we're specifically saying use the global scope variable. So yeah, that's just the basics of it. It's always recommended to just use local scope variables, because 99% of the time you are able to just replace a global scope variable with something local by using classes or just declaring a local scope variable instead and maybe passing it into the function instead of trying to access it from outside. But yeah, for the most part, try to stick with local scope variables. But now you do know the difference between a local and a global scope variable. First off, let's get the user input. We can first go and create a cout and just give the user some information of what everything does. So here we can say plus, or actually we can maybe let the user figure that out themselves, but if you wanted to, you can maybe go and say that is plus, and you can maybe put your own things here. You don't necessarily need it to be a plus. You could put something like, let's say, a P for a plus, or I don't know, what else would look like a plus? A pipe, anything. This is just so the user knows what everything is. And then we can go /t, and this is just formatting. You don't need to do this, but I would like to. And actually just go one /t. So this will just add a tab to the string. And here we can say minus, and we can say minus, and then \n to say new line. Or if you wanted to, you can go and create another cout here. It's optional, \n here or another cout. Let's go with another cout. I like this method a bit more, just because it looks nicer. And in divide, we can say that is a /, but you could also go something like a D for divide or whatnot. And we can just say divide. And here we can say for times, we can maybe put an X there. And we can say times. And there we go. Now the user has 4 characters which they can use to times or divide or whatnot. Cool. Now we need to ask the user what do they want to do, because I would like to get what they want to do first. But this is just my personal preference. You don't have to do this in the same order. I just like doing it in this order. But you could first get the user input with numbers, and then you could get what they want to do. Or you could do number, what they want to do, number, whichever you like. In fact, let's actually just do that instead. Let's first get a number. So let's go here and say, please enter the first number. And this first number will not have an std end al, because remember, this adds an extra line at the end, and we want the input to be on the same line. This is personal preference, you don't have to do this. And then I'm going to just create 2 variables, double, and I'm going to do a double, because if the user may want to do something like 3.4 and not just 3, then putting it inside of a double will work perfectly fine. But if you wanted to, you can make it just integers. And then here we can just say double num1 and num2. This syntax basically means create 2 variables of the same type. So double num1 and double num2. Both of these are empty at the moment, but we will fill them soon enough. In fact, let's put all of these that we are not going to fill at the moment. We can put here at the top. So char, and then the the operator. I'm going to call this OP because I don't know how to spell operator. There we go. So a char is one character, for in case you might have forgotten, so that would be something like A, or 65, the number, or 4. If you haven't seen my video on data types, I do recommend you do, because this is in there. And here we can first get the user input. So I'm going to get the input, and I'm going to store it inside of num1, because we want to get num1 first. Then I'm going to ask the user to enter their operator. So cout, I'm going to say, what would you like to do? And let's actually put that here then, because now it makes sense to display what they can do. So we can do this, and in here we can say cout answer. And we can just remove that end out to get the answer on the same line. And now here we can say cin, and you can put it into OP for operator. Now take note of these directions. You might get an error if it's in the wrong direction. It's very important to keep them in the same direction. So this one will always go like this because you're taking input and storing it into something. This will always go this way because you are putting input into the console. That's how this goes. And this is just basically a \n. So you can just think of it like that. So you're adding a \n to the end of your line, and \n means new line. So like that. Now we're getting the operator. Now we can copy this, paste it here, and say, please enter the second number. And now here we can just say num2. We want to basically create a few if statements here, because if what they do is add a plus, then we want to add those together. If they do want to do a minus, we want to minus them. So I'm going to say if OP is equal to, and I'm going to say plus, and since it's a char, a character, we want to use single quotes because we're comparing a character to another character, not to a string, and strings have double quotes, whilst characters have single quotes. And then we want to do something. And we want to do this as well for everything else. So we can say else, and I'm going to copy this if statement. So CB. So it's plus, minus, divide, and times. But we don't need this extra else if. We just need an else. Because the last operator will basically be our default. Or you could put an else there to rather give them like an error message, like what you chose was not part of the allowed options. So here we can now start putting functions. Now these functions are very small and it's optional to add them. But I'm going to do these functions just so you can see that you can use functions. So you can actually get a real life example of these. So let's do 2 of them like this and then 2 of them without doing it like this, just so you can see the difference. So double sum, and here we can say double num1 and double num2. So this will be adding. We can actually just call this add instead of sum. And now here we can return num1 plus num2. Like that. We can add another one, and this one can maybe be for division. So I'm going to call this div for division. And it's just going to divide. Now, just to show you this works, we can then go cout to console output, and we want to say the answer, and then we can put the answer like this: sum, or not sum, add, and num1 with num2. Something like that. And we just need to remember to do that. Add that right there. And then we can do the same and for divide. And the last one would be divide, because this would be minus, and this would be times, or x. So this would be divide. So by default, it would divide if they don't put what they should in here. And in here, we can just say div. And that's neat. Now for the other two, it's pretty simple. All we have to do is we can just go here. We can actually copy this, paste it, and now we can modify it. So instead of saying something like div, and I'm still going to put it inside of these right here, these brackets. It's completely optional. I just want to do it. And in here, I'm going to put a minus symbol. And that was supposed to be times, but here we can put it times. There we go. So there's two ways to do it. So first, you can either use functions to do it. So they would be like up here. Or you can put it in just like this. This is mostly just because it's so small. But if you were to have much more bigger functions, or much more larger code that you go in here, then putting them inside of functions would be better. Because let's say you want to reuse this function somewhere. That would be pretty useful then, if the function was bigger, because currently it just returns one line, which is so insignificant, to be honest. Is it really worth it? But this is just as an example to give you an intro on this. So let's save this and run it and see if it actually works. And woo, I almost installed Legends of Runeterra. Interesting. I'm going to cpile this. So first we enter the first number. And let's say it's 7.9. So we are right here. Please enter the first number. Enter. What would you like to do? I would like to add. And then we can enter a second number. And let's go 9.1. The answer is 17. Because 9 plus 7 is 16. And then 0.9 plus 0.1, that's 1. And then 16 plus 1 is 17. So it's definitely correct. Let's do another one, just to make sure it works. One without a function. Let's go here and run it again. Now we can say, let's say 9. And we want to minus, and let's say 89. And then we get 80, or negative 80. And that's a basic calculator. This is something very, very simple, but it can be very useful if you're having some trouble understanding a few things. Because it covers the topics of if statements, it covers the topics of doubles, and it covers the topics of numbers, and functions, and variables. It's very, very useful, getting user input. So first, up here, I want to include cstdlib. Now cstdlib will allow us to use the random function. Alright, now let's use that function, see what we get. So just rand like that. Simple as that. We should probably go std : rand. And let's see if that works. And there we go, we get a random number. Now let's actually do it again. Okay, interesting. Interesting. Now you'll notice we get the same number every time we run this. Now this is the quirk I talked about, where we kind of have to tell it to give us a more random number. Now a way to do this is to give it a seed. Now a seed you can think of is kind of like telling it, okay, I give you this number, now do some cool math in the backend and give me a new number back. And I'll show you this in a second. So let's include another library here called ctime. And this is just so we can access some timing. And now here we can say std : srand. And srand is basically to give us this, or so we can specify a seed value. And then in here we can specify time at index 0. Now, actually, before we use time, let's just put a number in there first. Let's make that 1, right? Now we get this number. Run it again, we get the same number. Now let's change that to, let's say, 2. What do we get now? We get a different number. Okay, that's interesting. Let's make this 3. We get a different number. So whatever changes in here gives us a different number. Now let's actually see out what we get if we use time. If we run this, and this should most likely be std : time. Actually, no, I think it should just be time, but we should actually specify a number. My bad. Let's try this again. There we go. So we get an interesting number. Let's run it again. We get another interesting number. You'll notice this number increases constantly. So 818, 823, 827. What we're basically getting here is the time from like 1977 or something, not quite sure when, but the amount of seconds that has passed since then up until this point. So every second, this value will be a different number. And some of you will probably see where I'm getting at. So if we specify time here, with 0 in there, then we'll get a random seed, or we'll get a seed that is different every second. So once they run this application, the seed will change. So every time they run it, they'll get a different value, as long as they haven't tried to run it within the same second. So there we go, random number, random number, random number. And every second we'll get a random number because the seed changes. I'm not going to go too deep into the seed because there's a bunch of unnecessary things we have to cover. I'm just going to cover it from a high level. So basically, put number in here, seed changes. When seed different, random number changes. Good. Now, how can we get a random number, let's say between 0 and 9? Well, that's pretty simple. We just say modulo and 10. This will give us a random number between 0 and 9. Not 1 and 10, but 0 and 9. So if we were to run this, we'll get 9, 8, 8, 6, 1, 4. Now if you want to get between 0 or including 1 and 10, then what you can do is you can do that plus 1. Now it will give us a random number between 0 and 9, and then we just add 1 to it to give us 1 or 10. Now we get 9, 3, 2, 1, yeah. And that gives us a random number. Now the nice thing is we can copy and paste this as many times as we want. Now we will always get a random number. As you can see there, 4967993. But if we were to remove this, then we'll still get random numbers, different ones, but they will always be the same. So run it again, we still get the same order of random numbers. So yeah, that's the basics of getting a random number in C++. So it just has a little quirk where you need to specify the time, or a seed at least. It doesn't necessarily have to be time, but you gotta specify a seed, and then that seed will determine the random numbers. Now, what is a namespace, you might ask? Well, this right here, that is the std namespace. That's why you can say, using namespace std, and that allows you to remove the std namespace. Like that. Now the reason namespaces exist in C++ is because different libraries may include the same function, and we can kind of determine which function we're trying to access by specifying the namespace. Because we might have a library called compute, And compute might also have a cout option, a cout function. Now, how will we know, or how will C++ know to use the cout of IOStream or the cout of compute? Well, by giving the namespace. std means it's in the standard library. So let's create our own namespace. I feel like that will make things a lot simpler to understand. So creating your own namespace is pretty simple. So here it even autocompletes for us. I'm going to call this stuffs. So this namespace stuffs is basically like std. It's just a different word. So let's say we have a function in here and we call it sum. Sum will return an integer. And let's say it takes in the int x and the int y. Now here we can return x plus y. Simple as that. Very, very simple. If we want to use this sum right here, we have to go down here and we have to, let's say we want to do the sum here. We have to specify stuffs, colon, and as you can see it autocompletes sum. Because now we're accessing the sum variable inside of the stuffs namespace. So we can go 10 and 9 and this will work perfectly fine. If I were to run this, we get 19 because 10 plus 9 is 19. And we can do the same thing as what we would do with std, and we can say using namespace stuffs. And that means we don't have to specify stuffs here anymore. So we can do the same thing. If we run it, it will still work. So namespace is basically just to say, hey, this function is part of this namespace. So when we call this function, call it from this namespace right here. So this would be from the standard library, and this would be from stuffs. Let's do another example. Let's say we return an integer, and this function is called cout, so like console output. And now here we take in a string, and we can call it num for number. Now we just want to return the integer of that number. So, or that string. So we can say return, and it doesn't have to be such a small value, or such a small function. You can make it a pretty complex function. This is just to kind of give you an example. And we can say std colon string to int. So stoy or s2i is a function in the standard library that converts a string into a number, an integer. So we can pass in num. So now this function will return an integer because we told it to return an integer. Now here we can say stuffs colon cout, and here we can say 12. There we go. Now if we run this, it will work perfectly fine. But this is actually a number now, that 12 that gets returned. So we can say 12 plus 9. That will work perfectly fine because 12 is in fact a number right now. This is also good to show you that you can still use the standard library inside of your own. You can still use other libraries within your own namespace. So this std namespace can be used inside of here. So yeah, that's the basics of creating your own namespace. This also kind of explains what namespaces are, because now there are two couts. If we were to say using namespace, namespace std, and I don't know if this will work, stuffs, I might have to split this up into two. Yeah, I might have to split it up into two. Okay. And stuffs, if you were to do this and then remove these, now we're getting a problem because C++ isn't sure which cout to use. So here it says, hey, cout is ambiguous. And here we say it's ambiguous because there is a cout right there. Whilst in the context that this seems pretty simple, like hey, this cout, not only does it have brackets instead of these things right here, you can actually plus with it. But to C++, that doesn't make sense. So that is why we always say don't say using namespace with anything. Unless it's a really long namespace that you really don't want to type and you're going to use a lot of those functions inside of it, don't do this. So rather do that. Or instead say using and then std cout. So this means if we specify a cout, this guy see it like that, then we specify this cout. So std cout. Meaning this would be an invalid form of it because cout cannot be represented like this. That forces us to say stuffs : cout, because that means we should specify which cout to use. That's why if you want to remove yourself from having to type out a namespace, specify specifically what you don't want to do. So maybe you don't want to do endal either, so endal. That means you can now do that, and it's perfectly fine. But this cout should still have this, because you can't really say, okay, using, and let's go stuffs. If we do that, and we go back to this, it's going to be the same problem all over again. But this time, it's going to take this cout. If we hover over this, it's going to take the second cout. Not the first, but the second. So some of you might be wondering, what exactly is an enum? Well, the most basic way I can explain this is it's integers. It's just numbers. That's all it is. So let's actually create an enum. It's as simple as just saying enum and then whatever we want to give it. For example, let's say you're writing an application that can get errors, which I love as an example. So let's say if someone clicks a button and that button doesn't work yet, it should report error 902 has occurred, whatnot. And here we can just say error, and here we can just say num. Now here we can create our enums, or we can insert our enums. For example, we can have A, B. It's usually good practice, C, and let's put there, okay. It's usually good practice, let's put one more E, to make all of your enums capital case. I don't know why, but it is considered good practice to do so. Or at least the first letter to be capital. Anyhow, so now if we were to just try and print one of these out, for example, here we can say error num, and take note, I'm not saying int or anything like that, I'm saying error num. And here we can say error for error is equal to, and now we can do something like C. We're saying C because we defined C inside of this enum right here. So now we can say, let's actually put some cool here, error no, and here we can just pass in C, like that. Now if we were to run this, and that should not be C, that should be ERR, my bad. There we go. Because we're trying to display this error right here. If I were to run this, and remember cpile is just my way of compiling, you will still have to use your normal way of compiling. And we get error number 2. If we were to make this E, then we'll get error number 4. If we were to make this A, then we'll get error number 0. Now we do get these values because enums, they're just integers. They start at 0, and the more enums you add, the more they will increase. So if we go like this, then now it won't go up until 4 anymore, because 0, 1, 2, 3, 4. It will now go up to 5, 6. Because that's just how enums work. They're just numbers. This is just 0 in disguise of the letter A. This is just 1 in disguise of the letter B. C is just 2 disguised in the letter C. So it's as easy as that. You can also give them a number. For example, here you can say 99. Now, any value from here, so this will be 1, 2, 3, right? Now, if you do this, this will be 99. And any value underneath D will now go along with this. So this will be 100, not 5, because 3, 4, this should be 0, not 1. 0, 1, 2. Okay, so not 4 because 3 and then 4, but this will be now 100 now because we set this to a higher number, meaning once we set the value here to a specific number, it's going to increase all of the other numbers. And you can see here, if I were to hover over something, you can see the number, the value inside of them. So let's actually now make, okay, so let's still use A and see if we still get 0, which we should still get. Yes, so error number is 0. Now let's turn this into D. And now we run this, we get 99 because that's what we set it to here. Now if we were to make this G, then we'll get 102 because E is 100 because D is 99. And then F would be 101 and then G would be 102. This is just numbers. These are all here are just numbers. For example, we can actually, let's move this inside. I don't know why I made it outside. Let's move this inside like that. And then here we can maybe go and actually give us a better example. So let's say, for example, user input error, like that. And in here we can say something like a sync error. We don't even have to say error. We can just do this because we know it's an error. It would still be good though to say error, just to specify. And in here we can say process error or whatnot. And now we can do this. Now we know what the user error is. The user will just see 0, but we know the user error is actually 0. Now let's do another type of example. Let's maybe do element. So this is a type of element you can have because you get your water, or let's go water. It doesn't matter if it has capital case or not actually. So water, fire, earth, and air. Now, if you live in Avatar, if you have seen the anime, yeah, it can be an anime, I guess. But if you've seen Avatar, you know that the Fire Nation has basically taken everyone over. But you can be one of 4 elements. You can be born under one of those. You can be born a water bender, a fire bender, an earth bender, or an air bender. And that's just kind of cool. So let's say we get here and say element. I don't know if element's actually spelled correctly there, but element, and I'm just going to call it me because that's the element I am. And here you can do something such as element colon colon and let's say earth. Now you'll notice I'm using this as a namespace. Whilst we can just say earth, and this should work without a problem, you might be able to guess that this could cause errors because let's say there is some other word that is already being used somewhere else. For example, a variable called me, or I could even call this earth. Now, if I were to call this earth, and then I were to remove this part here, it would just be very confusing because why is earth being assigned to itself? But when you do this, of course, it clarifies you're using element. So this is optional, but it is recommended to do this before I forget to tell you about it. Anyhow, so I'm going to call this me. Now, we want to say, maybe we print out what element I am born under. So we can either use an if statement, or we can use something cool, such as a switch statement. So switch, and here we can say me. So with me, do the following. And here we can do something like element colon colon, and let's say water. Now if it's this, then here we can just see out I am of the water tribe or whatnot. The water nation. That's, yeah, nation. There's I'm of the water nation. And then here we can just continue doing that. But then we can change it for every one of these. Cool. And then here we can boom. And in here with default we can just put some sort of cout, like say I wasn't born with a quirk, or what else? I was not born with a bending ability. Yes, that's what we can say. We can say benders. There we go. Benders. There we go. That's perfect. So I'm of the water benders, or I'm of the fire benders, or the earth benders, or the air benders, whichever power you have. In this case, I will be of earth. So if I go here, I am of earth benders. Let's make this maybe none, for example. Now I can go here and we can specify none. Now it's going to say, I do not have that bending ability. And then here, let's say I say fire. Now I'm going to be a firebender. So that's pretty neat. And the last thing is, if you wanted to, you could assign these something like 99, and then here you can go 88, and then here you can go 702, and here you could say 845. I don't know if it's a good idea to make that lower, so let's go 103 or something. And here with 9, it can just be whatever. So you can do this and give every enum its own little thing, but that will also kind of defeat the purpose when you can have an enum that just starts at 1 and it just works its way down. So this is also perfectly fine. And if you wanted to, you can just print out an enum as I showed you before, so cout. And here we can just say me. So this works perfectly fine as well. So as you can see, now I'm 103 because I'm of the Fire Nation. If I were to become an airbender, then I would be 845. If I were to lose my ability, so let's say none, then now I would be 846. So yeah, that's the basics of enums. They're just integers that are contained of one big integer, or just one word or one namespace containing a bunch of integers. That's all they basically are. Now sometimes when you have a program, it might throw an error. We can catch that error and we can stop the program from just stopping. For example, we can go here and just say console, not console, this isn't JavaScript. And here you can just say hello, throw to, and then world. Now this throw to is just my way of saying, hey, break the program here. Make as if an error has occurred here. So we're just saying throw an error. We're creating our own error because otherwise I would have to think of a way to actually get a real runtime error. If I were then to compile and run this, you'll see we have hello and then terminate called after throwing instance int, aborted. Basically, we got an error. You can assume this is some sort of error in your code while you're running it. You will notice we never got to world. This is a big problem because if you have a program, generally you want to stop any errors from just making your program stop executing. Especially, let's say, if you have a website and you coded it with C++ or something. You don't want that website to go down as soon as one little error happened. Like, let's say the user clicked on a button that wasn't fully implemented yet, and now the whole website is down just because you didn't make sure that button was correctly implemented. You can catch that error and make sure that the rest of the program still runs by doing error handling. So let's just do a few basic examples here. Let's go and say, we can actually keep the C out here. We can use try and catch, to get the error. Now this int here is just the type that is going to be thrown. So if an error is thrown, we can get an integer type here. So now we could see out some error. Oh no. And we can just show the error, err. There we go. And then here we could throw that too again. So it's the same program, but now we have a piece of code, then we're trying to execute a piece of code. So we're trying to run this. If an error happens, which it will because we're creating an artificial error here. If an error happens, catch that error and do something else. Now, if we run this, we get hello, some error, oh no, error, then 2, and then world. So the program continued because we caught the error that was thrown. And just like that, we made sure that the whole program executes and nothing just stops working. However, sometimes you don't know what type of error you're going to get. You might get an integer error, you might get a string error, a struct error, all of these different types of errors. If that is the case, you could use ... This means catch any error and then just we're done. In this case, we cannot display this error here because we just said ... just catch any error that pops up. So now if we run this, it catches that error. And here we change this error to be a string instead. Then now it will still catch that error, even though this is not an integer anymore. If we said int x and we ran this, we'll actually get another error from, because now we got a char const instead of an integer. We got a character string and not an integer. So by doing this, if we can get multiple types of errors, it will be sure to catch it. Now this won't catch everything. It will primarily catch what you throw. So if you throw some sort of error here, or if an error is being thrown by maybe a different program, this catch can catch that error and do something to maybe prevent it. And that is the basics of error handling in C++. It of course gets way more complex than this, but for our purpose, we don't need to go more complex than this. So let me first give you an example of what you can do with the size of. So let's create a C out here, and we can just say char is equal to, and here we can just print out the size of and char. Now, if I were to print this out by saying cpile, remember this is my custom compiling that I use. You will have to still use G++ or whatever you use. Anyhow, so then we get char is equal to 1. Char is basically 1 byte. It's 1 letter. It is very small. That is why it is 1. It's basically telling you the size of a character. So if you have a character data type, how much RAM will it take? And you'll see it only takes like 1. Then we also have int, and I'm just going to remove this part here because I'm not going to replace that 2 times. Now with int is a little bit bigger. It can take 4 because it's a bit bigger, so it needs to store more things inside of it. So it needs about 4 bytes. You can also do things like a long, which I do believe we have talked about, but if we haven't, it's basically a way to say store something bigger than an integer /float. And as you can see, it's basically double the size of an integer. It's 8. So an integer will use half the amount of RAM than a long would. But a long can store double the amount of data than what an integer can store. Cool. Then you have things like string. Now this should be std string. There we go. And this would be 32. It's pretty big because a string should be able to contain a lot of data inside of it without having to worry about running out of data. Then you have booleans, so bool, and a boolean would be like 1. Yes, because it's basically true or false. So it's 1 or 0. It's A or B. You know, it's very, very basic. So if it ever needs more than 1, then something's up. And then of course we have a float. And there we go. We have a float. That's the same size as an integer. Now, why did I teach you about this? Well, this will mostly become useful when we work with arrays. And in the next few videos, we're going to start diving into arrays. And it's good to know what the size of does, because it can help you a lot with some of your problems. And in this case, it gives you the size of something. So I believe you can actually even throw something like an actual number in there, and that should still give you the size of. Yes, because this is just an integer. So it will give you the size of. If you were to do something like that, would it give you that other 34 number? It gives 7. Because this right here, 1, 2, 3, 4, 5, 6, and I believe it's like a \0 at the end, which means like it's the end of the string. But basically, this right here, this is a total of 7 bytes. 6 letters and 1 like character to say, hey, this is the end of the string. Arrays are basically like a variable, but a variable that could store more than one value. For example, let's say we have an int x. Int x can store 10. However, we cannot store another number inside of this variable. It can only store one item. Same with if we went int y, that can keep x, but we cannot add another variable or another value to y. They can only store one item. So let's create our first array then, to show you what it does. I'm going to go here and say r, so int r for array. Then in here you say how many items you want to store. In this case, let's say 5. Now, here we can just say equal to, and then we have these little brackets here. These brackets basically say what we want to store inside of the array. For example, we can say 5, 7, 9, 0, 2. This is 5 items. This array is able to store more than one item. If we were to have another integer here, int x, and make that equal to 10, we can actually say x there. This is 100% valid. Because remember, this is just a container. Whether we say x here or not, it's just basically going to spit out 10. Anyhow, so this will allow us to store 5 items in the array. Let's see what happens if we want to print out the array. R. Now I'm going to compile this. And as you see, we get this weird value right here. This is basically like the location of the array in your RAM. Because we can't just get the entire array. We need to do a few things before we can actually work with the array. And we can actually go about displaying all the items in the array in a next tutorial. But right now we can work with displaying one item in the array. So arrays start at index 0. Like that. So in these brackets here, you can specify an index, basically which one you want. In this case, let me just do this. This would be index 0, 1, 2, 3, and 4. These are the indexes. It starts at 0, so 0 will give us 5, because that's what we stored at index 0. You can see we get 5. If we want, let's say 0, then we can use index 3. Do that, it works. And if we want to get something at index 5, which doesn't exist, what will happen? We'll get a value like this. You don't have to worry too much about it. Just know that if we're going to specify an item higher than what we have, it's going to throw out something you don't want. Now, you don't always want to specify the number in here for how long it will be, because let's say this is going to be 20, but you just see 20 items in a list of things you need to add, and you don't want to count all 20 of them. So what you can do is you can say this. This means make this array the size of the amount of items in here. So as you can see, currently it's still R5 because there's just 5 items in here. But now I can add more things in here. So 6 or 8, another 0, 12, 23. Now the array is 9 because there's now 9 items in here. So if we run this, it will still work perfectly, and 5 now contains the value 8. However, if we were to make that 2, then you'll notice my editor already sees that this isn't going to work out, because there's only supposed to be 2 items in here. So you don't have to worry about if you specify too low and you enter your stuff in here, it's just going to throw an error once you try to compile it. Now, what if you want to get the length of the amount of items in an array? And let's actually just say size of R. And let's make this 2 items only. And I actually also want to size off int. Let's see the size of both of them. You'll notice R is double the size of int. But you'll also notice if I add more items in here, you'll notice it's a much bigger than what it was. Because here it was 8, but now it's 24. Well, arrays work like this. For every item in the array, it's going to store that amount it needed for that specific data type. So in this case, an integer only needs 4 bytes. So 4, 8, 12, 16, 20, and 24. That's how we got here. So this stores a total of 24 bytes. So it will take 24 bytes from your RAM to store this array. Now let's say we want to get the length of this array, the amount of items inside of it. We currently know the amount of items is 6, but sometimes you need to access that amount inside of your code. And C++ does not have an inbuilt method, as far as I know, to do this. So what you have to do is say size of array divided by size of, and there's 2 things you can put in here. The first one is pointer A. You don't need to know what a pointer is, or point R, I mean. So pointer, and then this right here, the variable, the array itself. Now you don't need to know what a pointer is yet. A pointer to you is something you don't have to care about. And then you have your array. Now this right here, if we run this, it will give us 6. And yep, we have 6 items in here. Now if you don't want to work with pointers, which most beginners don't, and I'm not going to explain what a pointer is to you just yet because it's too early, you can also use the first element in the array. This will also give you the same output. And you can add as many things in here as you like, you'll get the same output. And I should actually add my comments and stuff as it should be added. There we go. Now if we run this, we'll get our new size, which is 11. Now arrays can become way more complex than this. For example, one thing I like to do when creating, let's say, is it tic-tac-toe? Is that what the game is called? But basically where you have your X, and then you have your 0, and then you have your X, and then someone might have put a 0 there, and then you have your X, and then you have another 0, and then on the next line you might have a 0, and a 0, and then an X. And in this guy, the X would win this game. I think that's called tic-tac-toe. Don't really know. But one thing you can do with an array to do this is you can create a multi-dimensional array. This is what I love to use when working or when creating that game. So here we can say int tick, and this is for tic-tac-toe basically. Of course, you can specify your sizes here. For example, 3 and then 3. Then that is equal to an array. And the thing is, this array needs to have 3 arrays inside of it. So now we can have another array in here, and let's say 1, 2, 0. Let's go like this, copy this. And in here we can say 1, 2, maybe here 0 as well. And then maybe 2, 1, and then there's another 2 there. So this is an example of what you can do. Now this is basically an array within an array. So first you specify the amount of items in this array. And in this case you'll notice there's 3 items. Then you specify how many items are in those arrays, like this. So in this case, if we were to think of tic-tac-toe, 1 could be X, 2 could be the circle, and 0 could be an empty space. And X1 because there's an X like that. Now let's actually try to display some items from this array. So cout. Now if we're just going to print out tick, let's see what we get. We get a memory space. That's understandable. But let's say you want to print out the item from this item in the array. So that will be 1, because remember, arrays start at index 0. This is index 0. This is index 1. This is index 2. We're getting index 1. What do we get? Or another memory location. Now, we can do something like 1. And in this case, this means go to the first index, 0, 1. And inside of that, go to its first index. So 0, then 1. In this case, let's actually make it 2 and then 1, because then we'll get 2. So now it's 0, 1, and then 2. That's what we're saying here. And then 1. So then 0 and then 1. Now if we were to print this out, we will get 2. If we were to make this 2, we'll get 1, because this 1 is at the end. If we were to make this 0, then we'll get 2, because 2 is at index 0. You can also make this different sizes if you want. So in this case, you can make it 2 as well. And then you can just do this. Now, there's 3 items in this array, but every item in the array can only have 2 items. You can do the same as what you do with a normal array, where you can do this and specify not a value. But this inner array needs to have a value specified. Because you don't want one array with this and then another array with more than that. You don't want that. You want them all to be the same. You can get around this, and in the future I will tell you how to get around this. But right now you don't need to know how to. And yeah, that is the basics of arrays. We'll be working a bit more with arrays, so if you're still not quite sure what arrays are or how they work, you don't have to worry too much about it, because we will be working a bit with them in the future. Just note that an array is basically a data type that can store other data types, but more than one. So with int x, you can only store one item in it. With string x, you can only store one string in it. With bool x, you can only store one boolean in it. But with an array, it's so much better. For example, we can say bool, yeah. And we can say 20. Oh, not 20, just let's get 2. Now here we can be like true, true, and false. So now we have a boolean array that can store more than one boolean. And my bad, I'm used to using brackets for that. There we go. Squiggly brackets. And you can even increase this. So now let's say it's 4. Now I can go false, false. So yeah, that is the power of arrays. They allow you to store multiple stuff inside of an array. When do you want to use an array though, above an actual variable? Well, let's say you have a situation where you need to declare a bunch of variables. So int x is equal to 20, or yeah, 20. Int y is equal to 50. Int z is equal to 32. And this will happen more often than you'd think. Then what you can do, instead of having to create a variable every time you need it, because sometimes you'll need lots of variables, like, I'm not kidding you. Then instead of doing that, you can just create one array to store all of those values for you. Because then you won't have 20 variables, you'll have one array with 20 items inside of it. And you can access those items with these brackets. That's when you should try and use it. Loops are basically just something you use to rerun code multiple times, but with different values, or just to rerun it multiple times. Almost like a function. However, it's a little bit different. Let's start with the for loop. And I'm going to let C++ complete this for me. Now here we can just change that to int, we can keep that the same, we can make this 5, keep that the same, and here we go. So, this right here is a for loop. It's one of the two loops we will be talking about today. A for loop is very simple in the fact that everything is right here. So, let's actually do this. Cout, and we can just cout I. And then I'll explain all of this in a second. Now if I were to run this, then we get 0 to 4. Now let's explain this. Let's actually break it up into steps. First we're saying int I is equal to 0. That's what we're saying. Then basically we're saying while I is less than this. So we are kind of in a sense saying if this. Then we're saying I++. Now that means we can go I++. And for those who don't know, I++ is short for I plus equal 1. And for those who don't know, I plus equal 1 is short for I is equal to I plus 1. So that is what we're saying here. This is this entire line. However, C++ will basically run everything multiple times in here until this is true. So currently it's false because I is 0 and 0 is less than 5. As you can see on the first loop it's 0, then here on the end it will do something such as I++. So this I++ is at the end. So yeah, now you can do another cool thing, so let's just put some text here. I am cool. And this will print 5 times that I am cool, as you can see there. So this just runs a set amount of times. It's as simple as that. Now of course it can also be used for more than just that. For example, let's say I want to loop through this array here. Now usually if I want to display something inside of that array, I will have to do that, and that displays everything. However, what if we were able to bring this to one line? Well, that would be simple. So we already know how to get the size of this. So we can go int r size is equal to friends, or size of friends divided by size friends at index 0. Now we know from the previous tutorial that this right here will calculate the length of this right here. So let's just quickly comment everything out again, and just to see if we do get the right length, which is 5. So cout r size. Now if we run this, we get 5, so it is correct. Now of course you could have done this inside of that, but we are going to put it inside of this variable here just to keep things simple. Now what we can do is we can remove these right here because we won't need them anymore. Actually, we'll keep one just because then we don't have to type as much. Okay, then we can delete the rest. Now here we can just say, well, it is less than r size. Not less or equal to, but less than r size. Because arrays start at index 0, as we know from the previous tutorial. And since this array is 5 items long, it will start at index 0 right here and end at index 4. So we don't say less or equal to, because if we made this less or equal to, it will go up until 5. But as we know, this right here doesn't end at index 5, it ends at index 4. If you don't quite understand what I am talking about, then I do recommend you go watch my previous tutorial on arrays. Now here, we can just indent that a little bit, and now instead of saying 0 here, we can say I, because I is just a number, and we were passing in numbers before. Now if we run this, now that's pretty neat. Now I said that I want this to be in one line, so everything except this array should be here. Now just to show you how cool this is, I can make this one line. In fact, I can probably do this. And then here, I can remove that, put that there. And right now, I've done all of this in one line. As you can see, it still works. So that is just how cool a for loop is. So instead of having to write out 5, 10, 100 lines just to display everything in an array, you can do it all in one line. You can of course do more than what I showed you. For example, you could add more things here. So let's go cout begin, and then as well cout end. Now with every loop, it will say begin and end. We can even, before we start the loop, we can say loop, and then after we finish the loop, we can say /loop to say the loop has ended. And now you'll get this. So we first get loop, then we get begin, the name, end. Begin, the name, end. So this will all now be repeated by this for loop. So everything inside of these brackets will get repeated. You may have noticed before I did remove these brackets when I made it one line. You could do that, and it works, but I do not recommend you ever remove these brackets, because usually it's just easier to avoid bugs. But if you do want to remove them, you can have about one item inside of the for loop before it starts breaking apart. So if you only have one thing you want to do, then you can remove these brackets, then it doesn't matter. But I also recommend just moving it here to the side so you know it's a one-liner. Anyhow, so that's a few things about the for loop. Cool. I hope you all got that. If you don't, I do recommend you play around with for loops because they're really, really simple and they just work in a really easy way. Nice. Now, let's talk about while loops. Currently, we know how a for loop works, but we do not know how a while loop works. For example, we can say while true, and then console.log, not console.log, this is in JavaScript, cout hello world. But what will happen now is that forever while this program runs, it will print out hello world. So this is an infinite loop. An infinite loop is a loop that never ever breaks. What you can do, however, is you can go here and say int count is equal to 0. And in here you can say count plus equal, just count plus plus, that works as well. And then here you can also say cout friends at index count. This will work perfectly fine. However, you'll notice if you're a quick learner that this right here, this will cause a little bit of a problem. Because if this loops forever and never stops, then this right here will always increment. So even once we run out of items in the array, it will still try and get more items. So if you run it, as you can see, we get a random mess of spaces at this point. So what we can now then do is say, either at the top or at the bottom, both of them will work. If, and here we can say count is more than R size. So if count is more than R size, let's make it, yeah, that's probably fine. Then break. This will break out of the loop. Break basically means skip the loop. Don't continue with the rest of the loop. And if you want to, you can do the same as what I showed you earlier with this if statement. However, I never recommend this. I always recommend using your brackets when you can. However, you may notice this will actually cause a little bit of a problem. So we should actually go if count is more or equal to our size minus 1. Because this says basically once we reach 4, we should break out of this loop. The reason for this is we don't want to go to 5. So if we say less or equal to our size, it will go up until 5, or more or equal, not less or equal. So it will go up until 5. Remember, we have 5 things in here, but it starts at 0. So just take note of this if statement break here. If we run it, you'll notice it stops after a while. And actually, I was wrong. It does not have to be minus 1. We just go like that, and now we'll get Luna. Some of you might be thinking, okay, that's cool and all, but why? And I totally agree. You could make this a lot easier if you just did that, because this takes in a true or false value. So while count, and this time you say is less than our size, do this. Now let's see what happens. It works perfectly fine. The reason we say less than is because if we said more or equal to, count isn't currently more or equal to our size, it's 0. So once it goes here, it's going to say false and skip the loop. Another cool thing you can do is you can say if count is equal to, let's say, 2. Continue. And what this means is if count is the number 2, skip the rest of this loop and go to the next iteration. However, this will cause a little bit of a problem since count is there. So you'll notice, that's why nothing happened. We have to change that back to less than. So you'll notice once I run it, we just get that and then it just sticks there forever. It doesn't do anything. So you'll have to be careful of this because as you can see, the count is right there. So what you'll have to do is maybe move count till here. And since this right here is a little bit of a problem, since if count is 1, then this will cause problems. Since now we'll start at 1 instead of 0, you can just make this -1. So your logic has to change depending on where you put all of this. But if you run it, as you can see, it works perfectly fine. However, we did get a segmentation fault. And that is because this still ran one more time. So we can just do that. And now it won't cause that fault. You'll also notice item at index 3. So right here, Jack, Nick, item, so index 3 or 0, 1, 2, so it's going to be index 2 as well. But Mike is no longer here as well because continue skipped everything after it. So you can use continue to skip the rest of the loop and go to the next part of the loop. So it starts the loop over. That's what you can do. This also works with for loops. The same with break also works with for loops. So this is anything that works in a loop. Now you'll notice, let's say 5. So while count is less than 5. If we were to make count 5 itself, count will not, or this while loop will not be able to run unless it's at least 4 or lower. Then it will run at least once. But sometimes you have scenarios where you want the loop to run no matter if this right here is true or not. You want it to run at least once. In that scenario, you can do a do while loop right here. And now I can put this right here. And this means execute the code, then check if it's true. So this will run at least once, while the while loop, just normal while loop, will just skip it if it's false. This one will run it once at least, and if it's false, it will skip it. Now if we go like that, it will run, but also if we make this 5, then it will still run at least once, even though this right here says this. That is because do tells us that we want it to run at least once. So it's the same as a while loop, but this time it at least runs once. And then finally, there's one more type of loop I would like to show you all. This is the for in loop. Let's say we have an array. And take note, what I'm showing you now can also be done with for loops and with while loops. I'm just using a for in loop because that's the awesome example. And this array contains 2, 4, 5, 6, 7, 8. So this array contains these values. We can say for int I colon, which means n. the array. So for int I in this array, cout, now if you run this, we get 2, 4, 6, 7, 8. We get all the values inside of the array. And this is very awesome, because that means we can easily loop through an entire array without having to put too much effort into it. This is the standard library arrays, also known as the STL arrays. These arrays are similar to both arrays and vectors. For those of you who don't know what a vector is yet, you don't have to worry about it. But it is like an array, but this time it knows its size. So let's start off with that. First we need to include arrays. So hashtag include and then array. So unlike with normal built-in arrays, where you can just start using them, this one you have to include first if you want to use it. Then we can say std : array. And then here you can just specify in these bracket things right here, bigger than and smaller than symbols. The type, in this case we want to store an integer, and then how many. Let's say 4, yeah, 4 will work. And then you give it its name. And here we can maybe go ages, that should be perfectly fine. And that is then equal to, and then our array. So 55, 22, or 12, and then 34, and 56. Now, it will work like a normal array. You can try and cout it, and then we can go ages. If you try and do that, you will get this right here. Because you cannot just display it like that. I think we all agree with that by now. But you can specify a specific index, just like with an array, and that will give you that item in that index. So index 0 would be 55. And of course, if you go over what you can, so there's only 0, 1, 2, 3. So if you go to index 4, which is not there, you'll get this. So just like with arrays, it's basically the same thing. And of course, if we were to go 3 to get the item in the third index, it will be 56. So very much just like normal arrays. But now there's another thing that can be kind of cool. You can say .size. And this will return the size of the array, which is 4. So no longer do you have to say size of and then divided by the size of the first index in the array. You can just say .size. And that is the beauty of STL arrays. Also, this is also known as an std array, for in case you might have wondered, but some people also call it an STL array. You can also access the very first and last elements in the array by using .front for the first element, and then .back for the last element. Now if you run this, you'll get 55 and 56 because they're the first and last elements inside of the array. If you were to create another std array here, and let's give it different values, so let's say 10, 20, 30, 40, and you can call this tens, then a cool thing you can do is you can say ages.swap tens. Now if you were to print out ages and tens, of course not like that, you'll have to for through them to see what's inside of them. So let's go and create a for loop. So for auto, and here you could just say auto because this for loop is a special type of for loop. And in here you can just say I and then colon, then the array, so ages. So this is basically a for in loop. It will loop through everything inside of this array. You can also specify a type, so int, where auto would just automatically guess what the type is. Then here we can just cout. So this is like a normal for loop where we would use the length, but this time we just specify this. And then we can say I instead of having to do the whole other for loop thing. But if you wanted to use the other for loop, you can. So for int I becomes 0, and while I is less than tens dot size, and in here we can display I as well. And now we can display them. So first we get 10, 20, 30, 40, and then we get 0, 1, 2, and 3. And the reason we get 0, 1, 2, and 3 is because this should be tens at index I. There we go. This one doesn't need to be that because we're actually getting the item at that index and not the index itself. Now if we run it, we get 10, 20, 30, 40, 55, 22, 34, 56. So we have swapped the two arrays. So now tens contains all of the items inside of ages, and ages contains all of the items inside of tens. So that's a pretty cool function if you want to use it. Now, whilst you can do something like this, cout ages and then let's say 2, this works perfectly fine. You can also say .at and then 2. If we run that, we'll get the same item back. However, the nice thing about this is if we give a number that is not in here, so if index 5 and this only has up until index 3 because 0, 1, 2, 3. So if we pass in index 5, then instead of just giving us a random number back, it will actually yell at us because, hey, that doesn't exist. You can also, if you were to do this, go ages.fill, let's say 10. And this will fill the ages array with tens. This will make every index in the array equal to 10. So if we for through it again, and then we run this, as you can see, we get a bunch of tens back. That's because we filled it, so it only contains the number tens. Now sometimes you will specify that it can have up until 4 items inside of it, but you'll only use a few of them. Now, we know we can use a cout and then go ages.size, and this will give us the size of it, in this case 4. So what is a vector? A vector is just an array. However, unlike an array, but similar to an STL array, a vector knows its length. But also, unlike STL and normal arrays, vectors do not have a set size that it has to be. Vectors can be about any size you want to put it. And this makes them incredibly powerful and helpful. So let's create our first vector. Now first we need to import vector, and now we can use it. So first is std vector, and then the type you want to store inside of this. In this scenario, I want to store an integer. And then data, because we're going to store some data, and in 1, 4, 5, 6. Yeah, that will work perfectly fine. Now we have created our very first vector. As you can see, it's just like an array. So let's for through this vector and see what we have. So here we go. We created a for in loop, which I talked about in a previous video, if I'm not mistaken. And we're passing in I. Now if we run this, we get 1, 4, 5, 6. So everything inside of this vector. Now we have cool functions such as getting the size of this vector. So cout data.size. Now if you run this, we'll get 4 because it is 4 items in length. However, now we can do something pretty cool. We can go here and say data.pushback, and let's say 69. Nice. Now this right here will add 69 to the end of this vector, the end of this array. If we were to run this, first you'll notice the size went up to 5, and here at the end we have a 69. because pushback adds it to the end of the vector, and we can have as many of these as we want. We'll do the same and run this. There we go. And just like with an STL array, we can go here and say capacity. Now if we run this, then we get 4. So it's the same as size. And of course we can also go max size. If we run that, then that will give the maximum size this vector can be. Cool. We can also do something such as data.resize and then specify its new size. Now if we were to run this, then now you'll notice that it says 9 here, and it fills the rest of the open spaces with zeros. So when we resize, we add some default dummy data in here. So this is the way you can give it like a size it has to be from the start. But what if we have more than what we resize it to? So if I say resize 2, what will happen? Because we have 4 items here. If I say resize 2, then it will do what? It will still resize it. It will just remove the rest because we resized it. So anything that is after that size can be just discarded. You can also get if a vector is empty or not by going here and saying empty. So just like in the previous video where we did this, but with STL arrays, you can do the same here. So it will be false. In this scenario, that would be 0. But if we resized this to 0 and then ran it, then it will be 1 because it's true. Cool. You can also get specific items in it. For example, you could say index 0. If we run that, we'll get item at index 0, which is 1. If we were to specify an index that does not exist, then we'll just get 0. You can also use .at, and this can also be the same. So .at is the same as using an index. However, this time if it's out of bounds, it will throw an error to tell you, hey, that does not exist. So it depends on if you want an error to be thrown, if you are trying to get data that does not exist, or if you don't want to. And in here, of course, if you say 2, then you will get the item at index 2, which is 5. Then you can go .front to get the first item in the array. And you can also go .back to get the last item in the array, or should I rather say the vector. Run that and we get 1 and 6. Cool. You can also go data.assign, and let's go 2 and 10. If we were to run this, and if we add our semicolon, and then run this, then we'll get 10 and 10. So it will replace all of the items inside of this vector with just 2 10s. So if we were to make this 610, then it will give us 6 10s. So this will replace everything in here. So just be careful with this assign. So let's quickly display data.size again. Another cool feature you can use is clear. So if you go .clear and then run it, then we'll get 0 items inside of this array, this vector, because clear empties or clears the vector. Cool. And then one last thing is if you want to create a vector with a vector inside of it, because some people might want to do that, is you do this, and then inside of here you go std vector, and then you specify the data type, which can be a string or an int or whatnot. In this scenario, I'm going to say int. And this will contain a vector within a vector. So now we can go here, and you can go 1, 6, 8, 2, 3, 99, 32, 12, 8. Just like that. And in here we can go for std vector int in data, and it should of course be v or whatever you want to call it. And then here you can move this up for I and V. And just like that, we can now display all of the items inside of this vector. There we go. That's cool. You could even go here and say cout and add some dashes underneath each one, and maybe even remove this end-al part here, and maybe add a space. Now if you run this, you'll get this. Of course, it didn't quite work out as what I hoped, so let's just add a backslash in, and now it'll work out as I hoped. There we go. So as you can see. So this one will loop through this vector, so this one right here, if we were to do that. So it will loop through this. And in this for loop, we'll loop through each one of these. Yeah, we did cover this in the first array tutorial, I believe. And yeah, that is the basics on vectors inside of C++. They're great if you want a dynamically sized array, so one that does not require you to give it a specific size, that you can increase and decrease as you please. What is a set? A set is an unordered list of unique items, meaning it's a list that once you create it, or a vector or an array, whatever you want to call it, but once you create it, it is unordered. Meaning if you go and ask for the item at index 1 and you did something like this, for example, 876. Now index 1 would be 7, right? Because this is index 0, 1, 2. But if you were to ask for something at index 1 inside of a set, you will not necessarily get 7. You might get 6 or 8 as well, because it's unordered. The reason it is unordered is because it gives a performance bonus. Ordered arrays needs to basically keep data about what order the array is, which takes up extra RAM, extra memory. Whilst this right here basically says, hey, we don't really care, just give us the data. And it is also of unique elements, meaning I cannot have 2 6s or 2 7s or 9 8s. I can only have one of each. Now let's actually put this in practice. So let's include set, and then down here we can say std : set, and then what we want to store inside of the set. In this scenario, to keep things simple, I'll say char for character. Since we never actually work with them, I think this is a good time to actually get to do that. And you can go my set or alphabet, or alpha, that also works, is equal to, and then here we can say A, B, C, or V, that works as well. And let's put another A in there, and let's put another V in there, and let's go D. Cool, so here is our set. So let's try and display the data inside of the set. We can do that by going for auto, and I'll give you an example without auto as well. I is equal to, and we can maybe do alpha.begin, and this will give basically the begin of this alpha, so this first one here. It will basically return an iterator. And we can just say, while I is not equal to alpha.end, and it will give us an iterator to the end of this alphabet set. And we can say I++ to increase. We can then see out what is inside of I. If we compile and run this, and we need to make this a pointer, just ignore this for right now. Imagine it just has to be there. We will cover that in a later stage. But if we run this now, we'll get A, B, D, V. So A, B, D, V, and then A and V are ignored. So as you can see already, it's not always in order, because D is at the very end, but here it is before V. And as you can see, there's also no duplicates. So as you can see, V, A, V, and A, B, V, A. So 2 A's and 2 V's. If we look at here, then there's only 1 A and 1 V. So yeah. Now, this auto right here basically automatically gets this value for us. It's kind of like C++'s way of making things easier for us. Although it is bad practice to use auto, because then we are basically telling C++, you decide what this data type is. And whilst most of the time C++ could guess correctly, C++ is guessing, and that's where the problem comes in. So it's always better to not only just for C++, but for yourself and other developers as well, to rather specify the type. But sometimes the type is very long to type, or it's just a very complex type that you didn't really understand how to type. But in this scenario, we can't type it. So we can just say std : set, and then in brackets the type, so char, and then : iterator, because it's an iterator we're trying to go through here. This is the same as what that auto had set, but in this scenario we're specifying what it actually should be. If we save this, the code will run just as normal. Now let's go through a few of the functions we can use, such as alpha.insert. Let's insert maybe the letter J. And this will add this letter. We can even add more. Let's add 2 J's and 1 M. And this will add these letters to our set. So A, B, D, J, M, V. Cool. You can also remove a specific item from the set. So let's say we want to remove A. So then we can go erase and we specify A. If we do that, then A will no longer be part of the set. What if we try to erase something that doesn't exist, like O? O doesn't exist in this set. So if we try and run this, then nothing will really happen. So if it didn't exist from the start, then you don't have to worry about crashers or anything like that. Also, before I forget, some of you might have fallen for this. Characters start with 1 quotation mark, while strings start with double quotes. So you should just be careful with that. I kind of forgot to mention it, but a character does start with a single quote and not a double quote. You can also check if something is inside of a set or not by throwing an if statement. So if, and here we can say alpha.find. We can specify the character we want, for example, C, A, D, let's go B. And in here we can say is not equal to alpha.end. So if it is not equal to the alpha.end, that means we have found, because if it's equal to alpha.end, it basically means it doesn't exist in the set. So here we can just then cout item found. And of course we can use an else statement here if it wasn't. And just like that, we can check if an item exists. So item found, because V does exist. But if we were to try and put something in here that doesn't exist, like P, then we get item not found. So there's a lot more you can do with sets. However, a lot of these data structures, you'll notice, kind of have the same things you can do with them. So vectors and STL arrays and sets, you'll notice a lot of them have the same things you can use with them. Maybe just a little weird quirk here or something like that. But usually they're mainly the same. They just mainly store data in different ways. Before we get to what a tuple is, let's first import tuple, and then we can just remove this right here. Now you can think of a tuple as a smaller version of an array. One that can hold types of data you specifically want. So unlike an array, it won't just hold just integers or just strings, but it can hold integers and strings and booleans and chars, whatever you want in it. So let me give you an example. So let's go std and create a tuple. And this tuple will have, let's say, 2 elements inside of it. The first can be maybe std string, maybe like a name, and then int, because maybe like an age. So we're basically creating a person. And that's why I'm going to call this tuple person. Now, unlike with other types of data types you declare and stuff. Here you don't have an equal symbol to declare it, but you could if you want to. But in this scenario, we just have this, and I will declare the tuple for us. Then here we could specify like a name such as Jack, and then their age, like 19. And now we have a tuple with Jack and 19. Now this tuple is very simple to get around with. We can now create a cout, and let's display the content inside of this tuple. To do that, we can say std::get to get an item from a tuple. And then first we need to specify the index. We can maybe say we want to get the item at index 0, which would be the name. So we say 0. And then from what person. Cool. Now we can compile and run this, and we'll get Jack. So Jack is at index 0. And then the age would be at index 1. If you specified an index that does not exist inside of Jack, you'll get this error right here. You can use the same method as well to overwrite something inside of a tuple. So let's copy this get method right here. I'll paste it here, and I'll say is equal to, and let's go Mike instead this time. So now we have changed this right here to Mike by using this get right here. If we were to run this, we now get Mike instead of Jack. So let's look at another way to declare a tuple. Let's create a whole new tuple. And this tuple can just hold some random values, not necessarily anything special. Let's include some of the values we almost never use, like a double, and a char, and a boolean. Now, you could do it like this, and then say values underneath here if you don't want to do it on the same line, or if you just want to do it later. Is equal to std, and then you have to say make tuple. And this will create a tuple for us with the values we pass in. So here we could pass in something like 3.1415, and then let's say J, and let's go for false, like that. Now we have done the same thing as what if we were to do this, but it's now on multiple lines instead of one. We can do the same thing with getting the value, so cout, get at index, let's say, we get at index 0, why not? At index 0, values. If we run this, and this should be std get, my bad, we get 3.1415. Cool. If we were to remove this part right here, where we actually define what's inside of this tuple, what do you think we'll get if we say we want index 0? Because previously when we tried to get an index that does not exist, we got an error. However, in this scenario, this index does exist, it just doesn't have a value assigned to it. So if we run it, we'll get 0. If we were to do char, not char, I meant to say 1. If we do that, then we get nothing. And if we say the one at 2 where a boolean is, and I'm constantly getting this one wrong, then we also get 0. So if the values exist, or not the values exist, but if there should be values at that index, it will return a default value for us. However, if we try and access an index that does not exist, because this only has 3 indexes, so 0, 1, and 2, if we try and access number 3, which is not there, we'll get an error instead. Cool. Now this make tuple method can also be used on one line. So we can go like this and say, values is equal to make, if I will use std, make tuple. And now we can pass in the values here as well. So 3.1415, a and true. There we go. So you can use this on the same line as well. So it depends on how you prefer declaring your tuples. Do you like to use make tuple to make it a more normal syntax by making it equal? or do you prefer to have this syntax instead? Cool. Let's create a more easy tuple. So one that's not as complex, which is just an integer and an integer. Then here we could do something like 7 and 9. Let's create another tuple, also integer and integer, and this can be values too. And let's make it the normal syntax just so we have some variety. And let's go 55 and 98. Now, when two tuples have the same types and amount of or number of elements, then you can actually swap those tuples. So one variable can have another variable's tuples. Let's create a cout because that might have been a bit confusing. So std get, and now we can just say 0 in values. And let's copy this and make this 1. And then we can copy this 2 more times. And this can be 0, and this can be values 2 instead. And my bad, this should be in brackets. Now if we were to run this, we'll basically get what's expected. 7, and then 9, then 55, and then 98, as expected. But since they are of the same type and have the same number of elements, we could say values dot swap and then values 2. And this will swap the items in values and values 2. So now values will have the items that is inside of values 2, and values 2 will have the item inside of values. So now we can run it, and we get 55, 98, and then 7, 9, because they have been swapped. You can also get specific values from a tuple by going int, and let's say a is equal to, and of course you go std get. There's also a perfectly fine method, and then just say values, and then here you can say 0 and then specify your values, and this works perfectly fine. However, what if you want both of these, both of the items inside of this tuple? Well, then you'll have to create another one here. We can go to make this b, and we'll have to say 1. Now this is 2 lines we don't really need, because what if we had 10 things inside of this tuple? Now we need 10 lines doing this. Well, that's why tuples have a special method to use with this. We can say std tie, and now we can actually just declare these like that, and then we can remove all of this. And this right here will basically just declare 2 empty variables. So just a and b. There are variables, you could split them up into 2 lines if that is what you are into. But since both of them will just look like this if they're split into 2 lines, you could do this instead. Anyhow, now you can say std tie, and in the variables, so let's go a and b, is equal to values. And now this will store 7 and 9 into a and b from values. So a will get 7 and b will get 9. Now we can just use cout a and b. If we run this, we get 7 and 9 as expected. You can do the same in a sense with a tuple. So let's have this tuple, and let's create another tuple. This one will have a char and a bool, because why not? So then we can go and put a char in here, and then true. And then let's call this one x, just to make it less typing, and this one y. And let's create another tuple, and this tuple we want to store both of these tuples. So first we'll need to specify the types of the first tuple, and then we need to specify the types of the second tuple. And then we can give it a name, and then here we say std tuple cat for tuple concatenation. And here we specify x and y as the tuples we want to merge. Take note, the order you merge them here should be the order of the types here. So int, char bool. If you were to swap these, then it would have to be char bool, then int. Cool. And now we can use cout to display all the items inside of this tuple. And this is called as a good variable instead of x because that's confusing. So we'll make that z. Cool. Now let's get what's inside of them. And it's 7, 9, n, 1. 1 which is true in C++. We just use a word because it's easier to remember than 1 and 0. And yeah, that is tuples in C++. They're not very complex, but they can be useful in the right situations. Now a map is just a key and value pair. For example, let's say name, and then we add a name like Nick, or age, and then we add an age like 5. So let me give you an example. First, we need to include map. Then here we can go std map, and we just specify first the key type and then the value type. So in this scenario, I'm going to go and make a string key type and then give it a value type of, let's say, int. So now we have a key of a string and a value of an int. We can now use these brackets here and define our key value pairs. So if we go here, we can then say, and let's go age, and let's go 9. So as you can see, the age is of a string value, and that should be a comma, not a whatever that was. And then this right here is of an int value. So this defines what type this will be, and this defines what type this will be. And in here we can go legs, and we can say 2, and I don't know, cars. We can say 9 is one rich 9-year-old. But this is basically a key value pair. And that's the basics of a map. Now if we want to get the item in a map, we can just, let's say, cout this. And we forgot to give this map a name. I should go and just say person or something. Now person, we can just go person. To get an item in person, we use this square bracket and then we pass in the key. So let's say we want to get the amount of cars this user has. Let's make it 19 just to make it a bit different compared to age. But if we say cars, then we should be getting back 19. And this should be in double quotes, not single quotes, because we're using a string. If we were to compile and run this, we get 19 because there's 19 cars. We can then do something like legs, and we can get 2 legs. We can also give things values. For example, let's go here and say person, and friends is equal to 12. So they have 12 friends. And in here we can reference it since it now exists on type person. Do that, we get 12. If we try to get something that doesn't exist and remove that, then we get 0 as default. So we get a default value, so it won't just throw an error out of nowhere. Now, this is the easy way to insert a value into a map, but there is another method if you don't like this one. By going person.insert, then we need to specify the pair, so std pair, and then the types. So that would be this string and int here. So it's these two as pair types, and then what we want to insert. So we can go friends, and let's go 21. And this is another way to do it. I personally like just assigning it, but this is also if you don't want to assign it, if you want it to be cooler, I think, then you can do that as well. And now I get 21. You can also remove something from a map fairly easily by going from insert all the way to erase. And then here we can maybe erase cars. Now if we do that, we will no longer have cars in our map anymore. So we'll get 0. So that's cool. To get the size of a map, you can just say .size, and this will give us the size of a map. Simple as that. Now we know it's free because 1, 2, 3. We can then empty a map, so completely clear everything inside of a map by going person.clear. And this will clear the map and remove everything inside of it. So now nothing here exists anymore. And as you can see, the size is actually 0, so it checked that for us. We can also check if it's empty, and we can go empty. So if it's empty, it will return true, which is 1. If it is not empty, so if you remove this .clear, so it's not empty, it will return 0. So this is to check if a map is empty, if it has something in it. To find an item in a map is fairly simple. We can just go here and say person.find age, and if that is equal to person.end. Now if this right here is true, that means that there is no age inside of person, because end means basically the end of the map, and the end of the map means nothing is there. So if we go like this, we get 0 because this isn't true. There is an age inside of this map. If we were to make it something random, then there we go. We get 1 because it is the end. There's nothing there. Now while we're here, I would like to show you how to do an if statement in one line. So we already know how an if statement works. If we go here and we say if, pass in the if statement, do something, and then else, and then do something. Now let's say we pass in this right here, and then here we just see out item found, and here we see out item found. This one up here should be not found, not, because if it's equal to end, it has not been found, and this one will be item found because it is found. This is a basic if statement. If we run it, we get item not found. If we change it to something that does exist, like age, then it will say item found, or it should be saying item found. And my bad, this age should be changed there, not at the bottom. Now if we run it, we'll get item found because age is found here. But you can do this right here. You can do it in one line. And I really like doing this because, as you can see, this right here takes up quite a lot of space, about 7 lines here. But we can make it take up 1. So right here where we say person age, we can then go and put a question mark here. So we're asking, is it this? If it is this, then say item not found. So this right here is the same as this right here. It's just one line, and you're using a good question mark. But this way of doing it always, and I mean always, requires a colon. So if we go here, we need to use a colon, and this means else. So if it's not true, do something else. Item found. This right here, this whole thing, that is equivalent to this if statement here. This is mainly to just do like one thing. It's not meant to do massive amounts of equations or checking if this and then setting a bunch of things. This is just to check if something is something and then giving it a value back. That's all this is basically doing. It just gives us a value back of checking it. It's a shorter version of this, where this right here is exactly this right here. But this time we don't need to specify brackets, and we don't need to specify that this should be what's being printed out because we already have a cout. So we're doing it inside the cout. If you don't quite understand this, it's not super important. It's just so you know you can use one-liner if statement, where it's basically if this is true, then execute this. If it's not true, then execute this. So we're asking if it's true.
If it is true, it will do this one. If it's not true, it will do this. Now we can remove this and we can run it. We get item found. If we change this to something that doesn't exist, then we'll get item not found. That's just something that you might be interested in knowing, because I didn't think I have ever actually gone through the process of teaching this. Cool. And now one last thing is, if you want to loop through a map, we can just go for, and you're going to say auto I is equal to person.begin, and then while I is not equal to person.end, because that would be the end or nothing left, then I++. Now once we have this, we can then say cout, and let's first try to see out what will happen if we try and just put I here. So if we run this, we actually get an error because there's not a typed name like that. So we can't really do this because this iterator is special. So we can go first like this. This right here is what you can use to access this first item here. If we were to now display this, we'll get age, cars, legs. So this will return the first item in this map. The second will be the same, but this time just second, like that. So we use a dash and then this greater than symbol, and that will allow us to get the values, the first and the second value in here, where this would be the first and this would be the second, and then this would be the first and this would be the second. Cool. Now if you're like me and you want to know what this auto actually is, then you can just say std map and then the type. So in this scenario it would be std string as well as int, and then you say : iterator, and that is just what the auto filled in for us, so we don't have to type that. Run it, we'll get the same output. And that is how you can loop through a map. So I'm going to show you with a vector, but you could of course apply this to more than one type of data structure. So let's create a vector, and we need to import that. So let's go here and say vector, and let's just make it of numbers to keep everything as easy as possible. And here we can just call it numbers, and numbers will just have a random amount of numbers or a random like values. So let's say 6, 8, 1, 2, -4, 6, or let's choose just different numbers, 7 and 3. There we go. So this is kind of all over the place. 1 should be at the front, 6 shouldn't be at the front, 8 should be at the back because that's the highest value. Actually, -4 should be at the front because that's lowered. And this should be an int, not I. Int. There we go. Now if we were to just kind of use a for loop to for through it. So for int I, or we don't even need to say int I. So for int num in numbers, we can just cout and num. There we go. So this will display some basic numbers for us. Holy moly, what is that? That's disgusting. And let's just add a semicolon there. And here we go. Now we have a for loop, and it will just show us the data in the for loop. We already know this. It just loops through in type of data structure, whether it be a vector or an array. And here we go. We get 6, 8, 1, 2, 4, 7, 3. Now we want to order this or sort it in a way that it will sort from lowest to biggest. Now vectors of course has an inbuilt function for this, so std, or not necessarily just vectors, but you know, sort. And this sort is actually from a package include called algorithm. Now this package allows us to use this sort to our advantage to sort two things in a data structure. So we can just say numbers, and we specify the beginning, so numbers.begin, and then numbers.end to specify the end of this. Once we have done that, it will now be sorted. So instead of throwing us this jumbled mess, we'll have this sorted mess, where -4 is at the top because it's the lowest value, and then 8 is at the bottom since it's the highest value. Now this is one way to sort it. You can also specify how to sort it. For example, let's say we want to flip the sort. Now I'm pretty sure we could just go end and begin. Let's actually see if we can. If we do that, then nope, we get a segmentation fault. Makes sense. Anyhow, so let's say we want to flip the sort. So instead of sorting from smallest to largest, we want to sort from largest to smallest. Well, we can just go here and we can create a function that returns a boolean, and we can call it sort for us or something. Now if we have this, we want to take in two values, two integers, int a and int b. Now in this, we just want to return whether int a is larger than int b. And once we do that, we can take this sort for us and we can pass it in here. So then we just go sort for us. And I'm pretty sure it will automatically pass in those two integers for us. Let's see if I'm lucky. It does. And now we get 8 all the way down to -4 because this sorts it depending if A, so this value, is bigger than B. If 6 is bigger than B, then return true. If it's true, it will keep it as is. If 6 is not bigger than 8 here, then they will flip the two. So 6 will now be at position 8 here. So to give an example, we can actually go here, tab in. So first it would be 6, and then we'll check 8. Since this will not be true, it will go 8 and then 6, because 8, which it was B, is bigger than A, and A was not bigger than B, and that's what we're checking here. A should be bigger than B. And now we'll go to the second one, and the second one is 6. So we have our 8 and 6 here, and now A will become the second value, so index 1 of this vector. And we'll check, is 6 bigger than 1? And it is, so it will keep it. Then we'll go to this one, so this will now be A and this will be B. We'll check, is 1 bigger than 2? No, it is not, so it will be 2, 1. Then here it will go, because now it will be here. That will be where A is now. It's the last one it's sorted. And we'll check, okay, is -4 bigger than 1? No, it is not. So we can add -4. And then it's going to check, is -4 larger than 7? No, it is not. So it will swap the two, 7, and we'll keep continuing with -4. Is -4 larger than 3? No, it is not. So 3 will be here and -4 is at the end. Now it will go through the whole vector again. And we'll go, okay, so we have 8. 8 is bigger than 6, we're good to go. 6 is bigger than 2, we're good to go. 2 is bigger than 1, we're good to go. 1 is smaller than 7, so they will swap, and this will become 7, and this one 1. And it will continue with this, or in this scenario, it will just swap these two as well, 3 and then 1, and then boom, we have sorted it. Almost. Wait, 2 is not larger than 7. Oh wait, but it will just go through the loop again. And again, until the whole thing is sorted. And that is how to sort a vector, or basically any type of data structure, where you can use these types of things to make him just loop through until all of these are in the correct order. So now once it completes this loop here, it's going to start at the start and go 8. Okay, so this is true, so it's fine. This is true, oops, this is true, so it's fine. This is not true, and it will swap the two. And it will swap them again until 2 is at the right location. I'm thinking you can probably figure the rest out for yourself from there. Now, let me bring in a new topic, because whilst this video is about sorting, I like to kind of spice up my tutorials by bringing in a topic not related to what we are currently doing, but can be used with it. And I would like to bring in lambda functions. Now we know what a function is. This is a function. Very easy. We just plop it in there and it works. But just like in the previous video where I talked about one-liner if statements, we also have one-liner functions. And this is a lambda function. So here where we say sort us, let's convert this into a lambda function. First, we need to specify an array. And we don't need to go too deep into this or why we need to specify an array, but we can just specify an array right now. Then here we pass in the arguments we need. So int a and int b, right here. We don't need to specify the sort for us because this lambda function is also known as an anonymous function, meaning it's there to only be used once. It will never be used again after this right here. It's anonymous. So it doesn't have a name. And in here, we can open up our brackets and we can just say return a larger than b. And now we don't need the sort for us anymore because we created a lambda that will do that sorting for us. And we run that, we get the same output because this right here is the same as this right here. However, we didn't give it a name. There's no name, there's no sort for us. But it takes in the same things, the same variables as you can see here, and it returns the same thing. So it's the same exactly, but it returns a boolean and it doesn't have a name. It's anonymous. So let's start with the easiest one, which would probably be reading a file. Reading a file in C++ is pretty simple. So let's get started. First, we need to include fstream. This is for file stream because we're going to work with files. So we're using fstream for file streams. So I'm just going to delete all of this right here. Now, first, we need to declare a line because we're probably going to be storing the text inside of this file in a line. And for those of you wondering, this is the file. Just says, hello there. On the next line, my name is Steve. And on the line after that, I am 19 years old. Cool. So first we can just declare a string, which we can just say is line. Then we can say if stream for input file stream because we want to get input from a file. And then we can create a file variable. You can call this whatever you want. I am going to call it my file. And this should be std, of course. Now my file, and you can just pass in the name of your file. In this scenario, it is file.txt, like that. Now, after we work with a file, this is something that you have to get used to if you work in C++, is you have to close the file. You don't have to close the file, but if you don't, it could cause errors in the long run. Closing a file means that you stop using a file. And when you stop using that file can finally close itself, remove itself from the memory, and just allow itself to be there. But if you're going to keep that file open, then if you want to write to that file or if you want to read from the file again, it could cause a lot of errors because the file is still open, which means we are still busy trying to read the file. So if we now want to write to the file or read from it again, we're going to have a little bit of an issue. So we always have to say at the end, my file.close to specify that we should close the file. Nice. Now we can just say while. Or actually, before we do a while, let's see out. And I want to show you what we can do here. So up here we can say get line. And we specify the file, so my file, and then the string we want to save it in, line. Then in here, we can just say print out line. We can save this. Now if we were to run this, then we get hello there. And hello there comes from here, where this is hello there. If we were to do this 2 times, then now we'll get my name is Steve. My name is Steve. You might already be catching on that for every get line, we are reading the next line. So let's go back to that example I wanted to do. While. We can use a while loop to read an entire file. We can then pass in this get line, but into the while loop. Because while it can get a line, do the following. And here we could just delete that, move that up, and here we go. Now this will read the entire file. So here we go. Hello there, my name is Steve, a white space because the third line is just an empty line. And then I am 19 years old. And reading from a file is really as simple as that. All you do is you just open the file, read it, and then close it. And this opens up the door to many things, like let's say you have saved files and you're a game developer. Now you can read that save file. Now next up, let's learn how to write to a file. So we no longer need this line there. And here we no longer need ifstream for input file stream. We now want ofstream for output file stream because we want to output into a file. We also don't need to specify that anymore. We can specify it on a different line. Now when we write to a file, we specifically need to open the file before we can write to the file. myfile.open. And you can also use this method to create a new file. So if the file does not already exist, it will create the file. However, if the file already exists, it will overwrite the file. So let's create a new file, lol.txt. Cool. And then yet again, we do need to remember to close the file, because if we're busy writing to the file and we want to read from the file, then it has to close first before we can just start reading it or writing to it again. So you need to make sure that you close this file in case you maybe somewhere else in the program want to use this file again, but it's still being read by a different process. So remember to always close your file. And in here, we can just say my file. And just like with cout, we pass in the text. And here we can just say, hello world. And then \n, an escape character to go to the next line. I am cool. Now if we were to save and run this, then now we have a file called lol.txt. Inside of it, we have hello world. And then on the next line, we have I am cool. Thanks to this \n. So this right here, that just sent the data into this file. And just as I said, this will overwrite the data inside of the file. So here I can do this, for example, and now the data will be overwritten. So it looks like this. So make sure that if you write to a file with this, that there are no important stuff that might be removed when you write to the file. Now, this open, it is optional. You could also put it here like with reading a file. So you could do this and it will also open a file just like normal. And yeah. Now, sometimes you want to make sure the file you are trying to write to is actually open. Because if it isn't open, that could cause a bunch of errors if you try to write to the file. For example, let's try to write to this file. But this file, lol.txt, if I go look here, there it is. Now you don't need to know what any of this really means that much. I'm just going to explain something here. If I say alice-l, and I go here, then you can see this lol.txt right here. Then there's these permissions here. This means read, this means write. This means read and this means read, meaning the owner can read and write and these two can read. You don't need to worry about the other two. But if I were to say chmod, so change the user or the owner of this file, and like change the permissions. And here I can just say 000, meaning no one is allowed to read, no one's allowed to write. If I do that, and this is Linux only, so just in case you were wondering, and I say lol.txt, if I were to long list this again, you'll see we have no permissions over this file. We are not allowed to read it, we are not allowed to write it, and we are not allowed to execute it. Now that we have that, if I go here and I try to compile and run this, and we go to lol.txt, we actually don't get any errors. So let's try and add something here and then try and run it again. We go here, as you can see, we didn't write to the file. Even though we now have this here, we didn't write to the file. Because we didn't have permission to write the file, so we couldn't really open the file. So this is where this check comes in very handy. We can go if my file dot is open. So if the file is open, only then do we want to write to the file. And we could put an else here, for example, else cout no write permissions. So now we don't have permission to write. Now if we were to run this, we'll get no write permission, because we don't have permission to write to this file. But if I were to just chmod plus read write that lol.txt again, and then if we ls-l, then you'll notice we now have everything back again as it was. Now if we were to try and run this, and as you notice, nothing changed here. But now if we try to run this, we don't get this output, but we do get this, so it did work. So this is something you could use, because you may not always have the permissions to open a file. This could also happen on Windows, where some files don't allow you to open them at that moment, because maybe a different process is busy opening that file and reading and writing to it, while yours is trying to do the same. Then it's going to block you and say, hey, you can't. So it's good to always check and make sure that you are allowed, or that it is open, before you try and write to it and lose the data you try to write. Now with this data here, or with this method here, it is fairly simple to append to the end of a string, or to an end of this. You have to read the file, then you have to take what you have written, put it inside of a variable, and then write that with this into this. But it's a kind of a long and unnecessary process. So I actually have a different process we could use. So instead of using, or we are still using this open here, but we can actually do a different way now. So I'm going to just close that there, and I'm going to use open, just because why not? Then here we could say myfile.open, and now we're going to, as you may know, open this file. But let's say we want to add text to the end of this file. Well, then we can go here and say ios::app. This means append. So append to the end of the file. And it should of course be std ios. So this will allow us to append to the file automatically. You have more options than just append. For example, ate for go to the end of the file when we open it. And then you have binary to open the file in and read it as binary. So open it in binary mode. in to open the file in read-only mode. Out to open a file in write-only mode. And trunc to delete the file content if it already exists. So basically what we just did without this iOS. So this would kind of be like the default. Anyhow, now this append here will allow us to now append to the end of the file. So here we could go and say \n to go to a new line. I was appended. Now if we were to look here, and if we were to run the file or run the program, then I was appended, because this allowed us to append it. Without this, it will overwrite it. You're also allowed to, of course, do more than one. For example, we could go here and say std ios and then out. And now we are only be able to append to the file, and it's only going to be open in write mode. So now if you were to run it, it will still work like that, but now it's only in write mode. We cannot read the file anymore because we didn't allow read mode. So first let's do the fun one, which I think is define, because you can make some funny code jokes with this at least. Or you could make your code just a bit less insufferable to write at times. For example, we can say hashtag define, and now we can specify something to be defined as something else. For example, number, and here we can just say int. Now number here will be the same as int. It's like an alias. So we can say number and num is equal to 20. This is completely valid. This right here, it's an integer, as you can see here. But we are saying number. Define allows us to, in a sense, just create an alias for a different keyword. So now we can use number or int. It doesn't matter. This here can be very useful, especially if you might have like a really long piece of sentence code you have to type. Then you can, instead of typing that entire long thing, you could just make it one word. Or if you want to change a word of something to this to something else instead, then this could also work. But yeah, that's about it. There's not much more to define at this point in our C++ course. But just for now, you can know that it does this. I can even make int Steve. Now whenever you say Steve, you're saying int, but you can say Steve num or Steve sexy, because I know I am. Anyhow, so that is define. Cool. Now this one is a little bit more complicated. It's a bit more complex in the back end, but I think this is about the best time to tell you about it. Now sometimes when you compile your code, you have code that runs at compile time. So when the code gets compiled, we can use this code that while it's compiling to run and maybe hide or show different pieces of code. For example, let's say if something is true, then at the end when we have compiled our program, there should be something available. But if something is false, there shouldn't. So to give an example, we can say hashtag if, not a normal if, this one is a hashtag if. And we can just specify one, that's good enough. And then hashtag end if. Then in here, we can specify code that should be part of the program during compile, once the program has compiled. So cout, I am cool. And this is a very basic example, but this can open up many doors for you in the future. Now if we do this, the code will be part of the program once we compile it. And if we make it 0, the code won't, because 0 is false. Now this is a very basic example of what we have. Usually you'd have a special variable or something to determine whether this right here is executing or not. Because you maybe get some, let's say if this variable that also exists at compile time, if this variable is true during compile time, then include this code. Or if something is passed in, then make sure that that something determines if something is available in compile time. It's a very complex topic, especially for how early it is in our C++ stages, but this could be very helpful once you get to know more about C++. But just take note, this if statement here, once we compile the program, this line here, or however many lines you put here, this will not be in the executable. This will basically be removed from the executable. You can think of it as like that, because during compile time, it will check this hashtag if, and if it's false, it's not going to include this. And you could have put, of course, put a dynamic value here, but you get my point. And if it's true, then it will put that code in the executable. As you can see here, now it's lighted up. You may have heard people say that C++ is the object-oriented version of C. And that is what we'll be talking about today. OOP, or Object-Oriented Programming. Now, let's start off with what is object-oriented programming? Now, it is when you think of things in your program like objects. For example, here we might have a car. Just excuse my terrible drawing skills. Now, when we think of objects in programming, then this right here, that would be an object. We can imagine this car into our program, so into our pieces of code. And that's the basics. That's literally what we do. We are just imagining this object into our program. And what attributes it has, such as wheels. Cars has wheels. Let's say 4 of them. Car has windows. Or even better, what about a book? A book has a lot of details about it. Now, what object-oriented programming allows us to do is take this book and extract the data from it. For example, how many pages does this book have? Let's say 44. How big is this book? Let's say in terms of height. That could be 150 centimeters. That's pretty big. Who is the author? Zach. Zach's the author. This is what object-oriented programming basically brings to the table for us. We can take this object right here and we can get or store, in a sense, structured data about that object. A lot of people overcomplicate what an object is in C++. But it is in fact incredibly simple. It's literally in the name. It's an object. If you can think of it, if you can touch it, it's an object. So let's create our first object. Now to create an object, you need to start with the class keyword to create a class. A class is basically just an object, but it's a special name for it. Let's create a book, because why not? And there you go. You have created your first object. However, this object, it doesn't have any properties. So we need to specify properties. And these properties should be available to everyone. It should be public. So we need to specify public. Now, when we specify public, we're basically saying that anything outside of this book itself can use it. You also have private. And basically, when something is private, it means that nothing else inside or nothing else outside of this book can access it. So if I specify here in the public string std, string title, so like the book title, I can access this title outside of this book, and we'll get to that actually. But if I go here and I say int pages, then I cannot access these pages outside of this book. So let's go here and say book, and this is to user object. And then let's call it my book, because I didn't have any book names in my head at the moment. Now we have just created a my book object. And let's just add a semicolon there. Now we can access this title property inside of the book. It doesn't have a title yet, but we can access it by going my book dot title, and as you can see, it even autocompletes for me. But if I try to go pages, it will not even try to autocomplete it, because pages is private. Pages is only available inside of this book class. It is limited to inside of this. We cannot access anything in private outside of this book. Unlike this title, which we can reference it, like right here, but we can't do that with pages. And in the future, you'll see the benefit of this. But for right now, let's just do what we have here. Now with this, we can also set it and say speed of the dark. It's a pretty good book. I do recommend it. Now we have that. We can now also print out mybook.title. Now when we do this, we'll get speed of the dark because we can access the title outside of this book. If we were to do pages, not that this is allowed because it's a string, but even if I change this to 1, you'll notice it won't even let us run this program because there's an error. It is inaccessible because it's in private. But yeah, that is the basics of public and private, and we'll probably get back to that at some point. Cool. Let's build off of what we have. Let's also maybe add in author, because that is also something a book has. A book also has a number of pages we might want to know about. And there we go. Now here we can set all of that data if we wanted to. So you can just get the author and the pages. I think the author of this book was Alex Shearer. Like that. I don't know. I can't remember if that's actually him. And in the pages we can say 90. It definitely has more than 90, but you get the point. Now we are able to access any of this data inside of this book. We can now go here and say mybook.author, mybook.pages, and what oh, my bad, let me just, there. Then we run this, we'll get speed of the dark, Alex Shearer, and 90. Cool. Next up, let's discuss, before we continue, or we are continuing, but next up, let's discuss the constructor. Now the constructor gets called whenever you create an object. So whenever you do this, then it calls a special function that runs, but only when you create the object. For example, book, and it's wise to call it the same as the class name because it's the constructor. Now the constructor will just run whenever you create the object. So whatever you put in here will be executed whenever you create the project. For example, creating book. If we were to run this, we'll get creating book. And the more books we add here, so 2 and then 3 and then 4, you'll notice it gets called every time. So creating book, creating book, creating book, creating book. So every time we create a book, it calls this constructor. Cool. You also have something called a destructor. Let's actually keep all of these. And a destructure is the same as an constructor. However, a destructor only executes after the object has been destroyed. So here we can go tilde and then the name of the class. And here we can say destroyed book. So whenever this object gets destroyed or relieved from the memory or whatnot, this destructor will be called. And if we were to run this, you'll see we get at the end destroyed book, because at the end of the main program, we are destroying this class or the objects that use that class before we completely terminate the program, because that's automatically implemented. And then it will destroy the object and it will call this. You can use both of these to your advantage, such as when you create an object, you can make it take in a value and set those values for you. Same with if you use this right here. You can make it maybe relieve values or change states or something like that before you close or before this object gets destroyed. So to build on top of what I'm saying here is we could do something like this and say string title, it should be std, and then here we can go std string author and then int pages. So now we can take in these values and we can set them once we call this constructor instead of setting them like this. Wouldn't that be so much better if we could just do them here instead of here? So now we can go title but we now have a problem because we have two titles. Now you have two things you can do, and I'll show you both of them. First is you can call this one maybe something like underscore title, because it is not the main title. And you can say title is equal to underscore title. And this works perfectly fine. However, more often than not, you'll not really see this method used right here. Some people do, and there's nothing wrong with it. But a lot of times you'll see this, and then author is equal to author. Now this right here is the same as saying this, but because these two have the same name, we can specify this to say this object we are in. That author is the one we want. And in this one is the closest one to us, because it will always default to the closest one to us. So if we were to say this, it's going to default to this closest one. It won't necessarily change this one. It might just change this one to itself. But if you do this, then you're saying, okay, no, I don't want this author. I want this author. This one right there. The one that's in this object. That is what we're saying. So these are exactly the same. However, this one uses an underscore in the name to differentiate between this title and this title, whilst this right here uses a this and then an arrow to specify the one we want. So these can be the same name. It's up to you which you prefer doing. A lot of people just do this. But if you are kind of confused with this and you can't quite get your head wrapped around it, then it's perfectly fine to just do this method because it's the same. They just have different names then. And with this one, you specify specifically you want to access this object's author. And of course here you can say this, and then pages is equal to pages. That's passed in. Cool. Now here with book, we can do this and we can specify our items. So speed of the dark, and I hope I spelled this guy's name right. And we paste that there, and then we have 90 pages. Just like that. And now we no longer have to do this. And that is because this book here gets called when we create this object. So it makes sense that if we want to create the object and do a bunch of things, we can just as well set the variables then and there by passing them in. Now if we save this, we can still access all of the items or all of the details inside of it, as you can see here. But now it's in a much more convenient way to put it. You can of course have multiple constructors. If you remember the function overloading section of our course. By doing this, and let's say we remove this one right here. And now we can say title is equal to no title, and then author is equal to no author. And in pages we can just say 0. Now I can give it default values. So if we don't specify these here, then we'll just get these default values. And this is here are optional. The reason is because it's going to go for the nearest author, nearest title, and nearest page. And since we're not passing anything in here, these will be the nearest title, author, and page. But if you want to be safe, you could specify this, and that will be perfectly fine as well. But now you have two ways to define a book. You can either define it like this, and if we run it, we'll get what we expect. Or you can define it without this there and then add it later. And if you do that, you should just remove that. Now if you run it, you no title, no author, and book destroyed. And here you can just say my book.author is equal to Jack. Now this will of course edit it, so now it says Jack, but it will still say no title and 0. And that is the power of the constructor and destructor in C++ and OOP. Now, let's first start with moving our object into its own file, because as you can see, this is a very small object. But once this object becomes like 100 or a few hundred lines of code, having it in the same file as this file, and then maybe adding more objects later as well, is going to become awful, because you'll have like one file with hundreds of thousands of lines in it, when you could have one file with maybe 1,000 lines in it instead, with just importing an object instead. So let's do that. Let's create a new file, and I'm going to call this book. And we need two types of file. First is the header file, and second is the object file itself. The header file is just to define the object, so how the object will look, whilst the file itself that holds the code is to actually implement it. So here we can say HPP or just H. H is more of a C style way of going, while HPP is C++. But a lot of people still go H, so if you still want to go H, it's perfectly fine. But now if you do that, we have our HPP. Then in here we have to define how our class will look. So first we can go if not defined. So if we have not yet defined, and let's say book underscore H. So if we haven't defined book underscore H, then we should define it. So we can just say end if. And you may have remembered a little bit about this in one of my previous tutorials, where I talked about #if and how that includes some code in your executable once you finally compile your code, depending on if it already exists. And this makes sure there are no two duplicate objects included inside your executable on the end of the day. It will only be defined once. But now we can say define to actually define that book H, and we can say book H. We don't have to give it a second value. We are just defining it. So if this already exists, then don't create this again. But if it doesn't already exist, feel free and create it. Now I can specify class and book, and then what is public and what is private. Now public, there's a lot of things that are public. For example, we have this constructor and destructor. So we can just go here and say book and tilde book. So for constructor and destructor. And in here, we also have a few attributes or properties, the title, the author, and the pages. We can just copy this and paste it here. Now this right here, it just defines how it will look. We don't implement anything. It just defines, okay, it will look like this. So it doesn't say what it will do. It will just say this exists inside of this object. And of course here we can go #include IO stream. So we can use this string here. Cool. Now we need to remember we have multiple constructors. We have a second constructor for in case we want to add some items to this book here. So we can just go here, paste it, and there we go. Now we have our second constructor. Cool. Now that we have defined how everything looks, let's create the file for our book where we actually say what it does. So book.cpp. Now first we need to include the header file because that contains how our object looks. So #include, and then the file you used here. So book.hpp. Book.hpp. Now we know how it looks, how the doc object looks. Now we need to implement everything in it. For example, book : and this : means it's part of this book function. Now here we can go book. Now we could just put a normal function here as well, but this specifies that this function here is part of this book here. So this is the function and this is the class. So this class right here, that's what we are saying here. It's part of this class. And this is the function book here. And that, of course, just does this. So we can copy that and you can paste it here. Cool. We have just implemented the first part. Now let's implement the second and the third and everything else. I'm just going to copy these because that's a lot of typing. And now here we can just say book : to specify it's part of the book. And there we go. Now, because we have done this, we can now go here and just delete this entire class. And here above, say #include, and then just yet again include the header file. There we go. And here we know this is a normal file because it doesn't have these squiggly brackets at the side. And it's engulfed in quotation marks. And then you think this is way cleaner because now we have a file that uses our object. We have a file that declares how the object looks and what's inside of the object. And then we have a file that actually works and designs the whole object. Like this makes the object work. Now my cpile code that I write here, it doesn't really allow me to compile more than one thing. So if I go echo, then okay, yeah, let's maybe go $. Okay, no, that doesn't exist. But it just contains this code right here. That's all that my cpile contains. But now we have more files that we should compile. So we can just say book.cpp. And now it will compile both the main CPP and the book CPP. You do not have to compile the header file. You only have to compile the C++ files. Now if we run this, we get our output. No title, Jack, 0, destroyed book because of what we did here. And just like that, we have split our files into multiple files, making everything so much cleaner to work with. So instead of having it all in one massive file, I think this is way better. Next up, let's talk about getters and setters. So sometimes you want to have specific getters and setters. These getters and setters do what they say they do. One gets data, the other one sets data. One is a getter, it gets the data. The other is a setter, it sets the data. The reason you want getters and setters is why you might want to use this constructor, because it can do some extra things for you when you use it. For example, let's say when we set the author, we should also set the pages when we set the author. Or we could automatically determine how the title is going to look if we set the author. For right now, we're just going to keep it very basic, but that'll kind of give you an idea. So let's create a few functions here as getters and setters. First, I want 3 getters and 3 setters. 3 to set these values and 3 to get them. So first, std string get title to say we want to get something. And this will return the title, of course, so return title. Or you could say this dot title, or not dot, but arrow title. And this will just specify that this title. But both works, it depends on what you want to do. I'm going to say this arrow, just because why not? We can then create another getter for the author and one for the pages. So get author, which will return the author, and then get pages. And just so we are clear, let's say these pages are just numbered by the amount of pages, like the amount of paper in the book. It's not the front and the back, it's just the paper, meaning we have to calculate the front and the back. So what we can do, now that we have this getter, is we can say pages times 2, because that will get the front and back. Whilst this pages here just get the amount of papers, just as an example. So this getter can get the data for us and structure it in the way we'd want it. Now we can actually use this, or actually this is inside of the header, we shouldn't be implementing it. But we can now copy this and we can paste it here and we'll get to it. So let's just go here and we can paste it, and we'll get back to that. Then here we can clean it, and there we go. The header has its getters defined. And now here we can go and we can say book : and then what we want. And this is what it returns. So what it returns, then the class, and then the function. And then this is what it does and how it returns it. Now that we have these getters, we can actually go here. Instead of saying title, we can say book.getTitle. And this is a special function now to actually get the title instead of having to access it. And now here we can say .get pages, or that one should be offer. And then the one below it can be get pages, like that. Now if we were to run it, we get no title, Jack 0, because we didn't actually put any pages. So we can go my book dot pages is equal to 35, and if I run it, we get 70, because this is only the pages, like the papers, whilst this is the front and back counted. Now we can also do setters, which will set the data for us. Go like this, and we can say setters. And take note, getters and setters are all optional. They're not required, just so we know, and we're clear on that. Now setters will usually not return anything unless you specifically ask it to. So here we could just say void, because it doesn't return anything, so void. And instead of get, it will be set. And now we can specify that it should set something. Now this will set the data for us. Then here in book.cpp, we can take these get methods and we can convert them into set methods. Or not convert them, but add new methods that are set methods. And let's just also close this. Now instead of get, we can say set. And then instead of the type it has, we can say void. Now these won't return anything, but we could now do extra things before we set the title, like cout setting the title. And then we can also do some other processing. Then of course here we can then say this dot, or not dot, but this title is equal to, and in the title we enter. So we also want to just copy this again, or we can actually go here and copy these. Then here we can just paste for the sets. There we go. So now this dot title is equal to title. And remember, this dot title or this title is basically the title of the class, not this one here, because this is for the closest one, this is for the class one. Just remember that. If you're still struggling, change this one to an underscore, and now you can just do underscore title and you can remove this there. So if you're still struggling, do this. But if you're not struggling with it, you can just do that. And then of course here we can go and bloop. And now I can just copy these and say is equal to that. And now we have setters to specifically set data. So now here, instead of saying author here, we can go and say mybook.setAuthor. And now we can just pass in Jack. So now we have a special function that we are managing when we want to set data. Same with pages and with the book title. So .set title and then .set pages. And here we can specify 23 and speed. And then here we have our getters. Now I can use them together and boom, there we go. Here we say setting the title. Why? Because we're currently setting the title, and we told our set title function to say that whenever we want to set the title. And then it set the title and whatnot, like that. And now that we have this getter and setters, we know we are not using these title author pages outside of this book. We know we're not using it because we're only using it, changing it, and getting it inside of this book object. Nowhere out here are we saying .book or .title or .pages or .author, right? We're just saying that in here. That means we can now create a private section that holds these for us. Now we cannot access these outside of this book here. So my book dot, and as you can see, we get functions, but we cannot actually access those specifically. If I want to access the title, I can't. It's not going to allow me to access the title. It says right here, declared is inaccessible. We cannot access it anymore. This is a way to keep your data safe from being mutated by something else that shouldn't be mutating it. So it's always recommended if you have some properties in your class, your object, that doesn't get used outside of this book. It only gets used, like set and getted from inside of this. Then just put it in private, because it's better to put it in private than having it being modified whilst not private. But you don't need to put it in private. If you want to, you can still keep it in public. It's personally up to you on the end of the day and your scenario. But in this case, we can move it to private because we're not using it anywhere outside of our class. It's only being used inside of our class. As you can see here, only inside of the class, nowhere outside. And now we can use functions to access them and set them. And that's the power of getters and setters. And then finally, we've almost already covered this, so it's not really necessary to cover it, but it's just so you know you can do more than just this. You can also create your own functions, so custom funcs for custom functions. For example, let's go std string, or let's go float. Let's make it double just because why not? Double calculate price to calculate the price. So it will figure out how much this book costs. You can of course like pass things in here. For example, let's go int popularity. Let's just go pop because I don't know how to spell popularity. There we go. We can now take this custom function and we can put it inside of our book class. So let's put it at the top just so we don't have to go to the bottom the whole time. There we go. Now we can say if popularity is more than 5, then do something else. If it's not more than 5, then we can do something else. So here we can say return this and then pages, so the amount of pages, times the popularity, and that will calculate the price. And with how expensive books are, this is almost accurate. Just kidding. And in here, if the popularity is not more than 5, then we can just say times it by 4 or 3. That will work so well. And now we have a method to calculate what the price of a book will be. Now here we can go and say, we don't need to get anything anymore. Cout calculate, or actually book.calculate, my book.calculate, my bad, calculate price, and the popularity is, let's say, 7. Now if we were to run this, the price would be $161. And if we were to set a popularity as 2, then it will not be nearly as much, 69. Nice. Of course, these functions can also be inside of private, but then these functions should only be used inside of this book, because then it won't be allowed to be used outside of the book like this. As you can see, I'm already getting an error. So if you put a function in here, remember it should only be used inside of this book class. And if you put it in public, then it can be used outside like this. Now, when we think of inheritance, we should think of it almost like you inheriting something from your parents, like inheriting your father's dark colored hair or inheriting your mother's height. That is basically what inheritance is. We can apply the same thing to classes, which, as I told you, is basically objects. You yourself, you are an object. So an object can inherit from another object, such as your parent. So let's create a class and call it car. This can be like any type of car. Currently, we can just give it one function, and we can just call it double calculate. It takes in an int amount of kilometers and then returns the amount of fuel that gets used. So let's say by default a car uses the amount of kilometers divided by 2 amount of fuel. Now when we go here and we create a car and we say my car, and then we just go cout my car dot calculate fuel, and we pass in 18. So if they went 18 kilometers, then I go back into my folder and I compile, then we get 9. So that's the basics. We just created a very basic class that has one function, and that's to calculate the amount of fuel a car uses. Now here we can create another class, and let's call this a truck. Now you can think of a truck as just another car, but it is bigger, so it will take more fuel, and it might have things like more wheels, and we might want to include the width and the length of this truck. But then we can just go here and say public and then car. Now this colon symbol right here allows us to inherit. So this means inherit from this class we pass in. That means everything inside of this class gets given to this truck. So now this truck is this car. So let's actually create a truck, and we can call this my truck. And now here we can do the same, but we can say my truck. You'll notice we use the same amount of fuel and everything works, even though this class has nothing inside of it. Because we inherit from car, we inherit all of its public functions and variables and whatnot. So this calculate fuel, that is now part of this truck as well. However, the difference is, now we can do something such as add another public variable. And because this is a truck, what else can a truck do? We can say calculate load. So this is how much load the truck can hold. And let's say to determine the amount of load a truck can hold, and this should of course be maybe like a double or something. Let's say to calculate the amount of load it can hold, we must pass in the truck width. I don't actually know any math like that, but you know. Now to calculate this load, we can just return basic function width times 2. So it can carry the amount of things in kilograms times its width. And we can just say double for width. Now here with my truck, we can do the calculate fuel, but now we can also say calculate load and pass in 18.8 for example. If we run this, we get 37.6. But now you should take note, my car does not have a calculate load function. The reason for this is because it is the base class, also known as the super class. It has a set amount of things inside of it. This class that inherits, also known as the subclass or a child class, has everything the car class has, and more. So it's kind of like also inheriting from your parents. Let's say you have everything your parents has, plus you have a computer skill, which they might not have. It's the same as that. So if I were to try and do the same here, but instead of my truck, we're to say my car, then I'll get an error because this calculate load only exists on my truck. And that is the power of inheritance. Now you can also overwrite something that the class above you have given you. For example, this calculate field, it is perfectly fine. However, I feel a truck would use a lot more field than a car would. So instead of saying divided by 2, we say times 2 this time. So now the calculate field would be a lot more than with a car. And these are going to basically be the same. So I'm just going to, instead of times 2, we can say times 1.5, just to keep these two separate. Now we can just go back here to my truck, run it, and we'll get 9, 27, 37. So these two has the same function, calculate fuel, but how they calculate the fuel is completely different. Even here we could do something like give a C out and say my func. Now if we were to run it, we'll get a C out with it. So this is the power of inheritance. You might not quite see the benefit of this yet, but basically you have a class and now you can extend that class or inherit from it, and basically meaning you can get everything inside of that class and you can add on top of it and overwrite what it already has. So let's say with calculate field, you just want to do integers. You don't want to return a double. Now here you could just say kilometers times 2 then, because then since both these are integers, it will return integer instead of a double. And this here is also known as polymorphism.
Polymorphism.
When you take a function that already exists and you overwrite it once you inherited it. So this right there, that's
polymorphism.
Now you'll notice when we do something such as, and let's actually go to the top here and say private. And what can we make private? Maybe the brand of the car. So let's say std string brand. So now we have a variable brand. Let's give it by default and make it Toyota, just to make things simple. Toyota. Now we can create a getter, std string get brand, and this get brand will contain a string, or not, it will contain a string, it will return a string, this brand. Now let's quickly go here where it says my truck and just change that to my car, and we can say get brand. Now when we run this, we get Toyota, which is understandable. Now when we say get brand, what do you think will we get? When we run this, we also get Toyota. Now when we go here to car, and let's say we create a function, or let's just keep it to this get brand, that's fine. Let's go here to this truck, and we create a function that basically sets the brand. So void set brand, std string brand, and in here we can just say this brand, and you'll already notice something. We are not getting autocomplete for this brand here, but let's say this brand is equal to brand. Now immediately we'll be getting an error because this brand is inaccessible. Whilst this getter works perfectly fine inside of this car, when we get to the truck, this here will no longer work with this brand. If we were to copy this and in a sense overwrite it, then you'll notice we also get that error. So even though we could use it here with this truck, once we try to implement it ourselves, we're getting a massive error because now we can't access brand. So you should be careful of this, because this brand here is private, and yes, it is set here inside of our car class, but we cannot access it inside of our truck class. And this is where the protected comes in handy. So protected is like private. However, it also gets inherited to the child. meaning you can still access it if it's inside of protected, unlike with private, where if it's in private, then once you inherit this class, you can no longer modify it or read it. Only the functions that are there by default still have the ability to read it, but even once you try to overwrite it, it's going to throw an error. With protected, it's different. So let's go here and say int wheels, and we can make that equal to 4 by default. Then we can create a get wheels, which returns this dot wheels. And here we can just go from string to int. And now we have a get wheels here. We can remove this set brand for now. Or actually, let's just keep it here for a second. And here with get car, we can say get wheels. And here with get truck, we can say get wheels to make sure we're getting the wheels. And there we go. We get 4 with both. However, now because this is in protected and no longer in private, we can take this wheels and we can go here, and instead of this set brand, we can say set wheels, and we can go int wheels. And now we can say this, and in our arrow, wheels, we can actually access wheels now, is equal to wheels. So this is the power of protected. It allows us to access what is ever in here, but should still be private outside of this class. So it's not as strict as private, but it's not as public as public. It can still be used and seen inside of your child class, aka your truck, but it cannot be seen or used outside of it here. So if I go my car dot wheels, you'll notice we don't get a wheels here. That is because it's still considered private outside of the class, except for those that inherit from it. Now, of course, here we can go and say my truck dot set wheels, and let's make it 10. Cool. Now, when we run it, we'll get 10 here. So we could set the wheels and we could get the wheels. Now, take note that inheriting once is just the basics. You can still inherit from truck and you can still inherit from car. For example, I could say here class, and let's say minivan. A minivan inherits from public, and we can just make that with capital M, and there we go. This is still possible. More than one thing can inherit from this car class. You can do 10, 20, 50. And the same can be said for this truck. So if we go here, we can say truck. Now minivan has everything truck has, and has everything car has, because truck has everything car has. So when we inherit from truck, we inherit from car as well, because truck has everything inside of car. And it will proceed the same way. You can create private and protected variables and functions here. You can overwrite functions from the truck class. It's the same process. Just this time this minivan will inherit everything from truck, while the truck will inherit everything from car. Now a constant is a variable that cannot be changed. For example, let's say I have a variable int x and I make it equal to 10. Now I go cout and I say give me x. Then I go down here and I say x is equal to 19. And if I say cout give me x, then you'll notice it changes. So just cplusplus 10 and 19. So sometimes you don't want this to be possible. Sometimes you just want the variable to store a value, but you don't ever want that value to be changed unless you specifically go and change that value in the code itself. To give an example of what I mean, we can say, here in front of this int, we can say const int. And this means make this x variable a constant.
you'll notice we immediately get an error because this x here is being changed. And here it says expression must be a modifiable value. And x cannot be modified anymore because it's a constant. So if I were to try and run this, I'll get an error because you cannot change x. It has already been set. So I now have to remove that because I cannot change it. Now if I run it, it works perfectly fine, but x cannot be changed. You can still kind of change it in the code here. For example, x plus 9. That's still something you can do. It's not going to stop you. The variable x itself, however, cannot be changed. Now, let's quickly talk about naming conventions as well. Usually, you'd have something such as int my variable. And let's say that's 10, right? When you have a constant, you can do this. There's no problem with it, but a lot of people like to go int my constant is equal to 10. So this is just for kind of you to know when you're accessing a constant and when you are accessing a variable. Because a variable will use camel case and it starts with a lowercase letter. And a constant will be all caps, and to separate words you'll use an underscore. So this is just kind of a naming convention. You don't have to follow it, but a lot of people do because it makes the code easier to understand. Because you'll know constants. If it's a constant, you just say const here. But anyhow, constants will be all caps, and normal variables that can be mutated will not be. Anyhow, that's just some naming conventions you might want to know of. Another way you can define, let's actually just remove this class here. Another way you can define a constant is up here by saying hashtag define, and you just give it a constant. For example, my name, and then what value you want to give it. In this case, let's say Steve. And then of course I can use it here, and I can just say my name. If I run this, it shouldn't give any errors. As you can see, Steve. Now let's get to the object-oriented side of things. Let's create a class and call it car. It can have a private variable, which maybe contains like the int x, or let's actually go map. Let's create a map. Int x, and then mutable int y. And I'll explain this in a second. And you can of course have public, which can be our functions, get position, which will, or actually let's make the set position to make things easier. Set position, and this will be void. And let's put a const here. So this is going to be a constant function. And I'll explain all of this in a second. Now this function here is a constant function. Basically, when you declare a constant function, it tells the class that it will not change any of the variables in the class. So if the class in this case has the variable x, we are not allowed to modify x. However, what we could do is we could use mutable, and this means it's allowed to be modified inside of a constant function. Let me implement this function to show you. So here, let's say we go cout, and we can print out x, and then also y, and we go y. So currently it just prints out the things, it doesn't do anything. Then here we can just say map my map, and then you can just say my map dot set positions. Now if we run this, we'll get our x and we'll get our y, which is just random values because they were never actually set. So let's actually give them default values just so they have something. Let's go 10, and here we can go 15. Now it'll be a bit more understandable. So x is 15 and then y is 10. Cool. Now when we try and modify x, because this is a constant function, it's not going to allow itself to modify anything that is not mutable. So basically everything here is by default then a constant to this function. It cannot be changed. So if I want to go this, and then x is equal to 10, it's going to give us an error because we are not allowed to change x because we're in a constant function. If we go x or this, and then y is equal to 100, it will do it without a problem because y has been set to mutable, so it's allowed to be mutated inside of a constant function. So if we try and run this, we'll get an error because x is not allowed, because it's not mutable. But if we were to comment this out and rerun it, we won't get any problems, and y would have been changed, as you can see in this output, because y is mutable. Nice. Now this brings me to another topic. Let's say we have const int y here instead. Remove that. And here we can also remove that. Oh, we can actually keep x. Yeah, like it is. So now we have a constant variable here, not a mutable variable, not a normal variable, but a full-blown constant variable, meaning it's not allowed to be edited anywhere inside of this class. It has to stay like this. Functions are not allowed to edit it. Constant functions are not allowed to edit it. It has to stay like this. Now, we have a problem. Let's say, let's just do this, and we can actually now call this get pos because this will just get the positions for us. Here you can say get pos. Now, when we create a constructor for this, let's say we create a void map, which will be the constructor. And it can just take an int x and int y to set x and y. And this should be constructor. Actually, this shouldn't have anything because it's a constructor. There we go. And then down here, we can just go map and then pass in 10 and 9. This can be your x and y position. Let's make this 9t. Now, we have a little problem here. We cannot go this, or we cannot go this and then y is equal to y. And we cannot go, or we can go this, x is equal to x. This is possible, but this is not possible. Because remember, y is a constant. So how are we going to set y if y is a constant? Well, C++ actually has a very special method for doing this if you ever want to do it. So let's remove that, and we can just go here and say colon, then the variable name, in this case x, and we can say x, that's been passed in. And then here we can say y, and then the y that's been passed in. Let's maybe just rename this to easier values so we don't struggle figuring out which one is which. So we can just say a and b. And this right here allows us to set the value of a constant variable. So in this case where we have to set the value, we can do this to set it instead. So now if we were to run this code, we'll get 10 and 90 because that's what we put in here. So this here allows us to mutate a constant variable if we need to. Because sometimes you only want to give it its value once you create it. You don't want to then change it later, but you want to give it the value once you create the object. You don't want to necessarily set the value as a constant when you have the class, like in the code. You might want to do it only once you call it. But yeah, that's the basics of constants in C++. There's a lot to go around, but for the most part, you just need to know constants are generally not immutable, meaning you cannot edit them. Once you've set them, that's what they're going to be until the end of time. And for the most part, if the class constants confuse you, then don't use them. Just go const here and then create your constant here. Or just go const here and just give it a default value if you don't want to use this here, or if you don't need to use this here. So first I would like to create two new files, birthday.hpp or just .h depending on what you prefer, and then also birthday.cpp. Now in here we can just go if not defined,
birthday underscore h, then define birthday, and then of course we can just go hashtag end if class birthday, and we only need two functions here that are in public. The first function is just the birthday, so this would be the constructor, where we have an int d for day, int m for month, and an int y for year. And then we need a function to actually just print the date. Print date. Cool. Then as for private, we can have int month, day, and year. And this will of course hold all of the variables for us that contains the month, day, and year. Then instead of the birthday.c++, we can just include iostream and also include birthday.hpp. Then you can just say birthday and then colon birthday, which takes in all. We can actually just copy this because that's quite a lot of typing that we really don't need to do. Just paste all of that in here. And all we need to do is we can just say day is equal to d, month is equal to m, and year is equal to y. Now, because we don't have different types of variable names here, so for example, this isn't day and day, we could just do this because we know that the top level would be this, in case you have forgotten. But you could still, if you want to, say this. That's perfectly fine as well. There's nothing wrong with saying this here. Just in this scenario, it's not really required to say this. Then here we could of course say void birthday, and then we can just print the date. And this will of course hold cout day, and we can add a slash, month, and another slash, and then finally year. And this will of course just print the date. It's very basic. We can then go into main.cpp just to make sure everything works, and say hashtag include birthday.hpp. Then here we could say birthday, and then I'm just going to say bday for birthday, and we can say 5/8/2002, and that would be my birthday. And of course we can just say bday.printDate, and that will of course print the birthday to us. Now if we were to run this, and my bad, I should go g++ and birthday.c++ output and output, and there we go. That's 5/8/2002. So if you have got until here, then everything works. Next up, let's create a person.hpp and a person.cpp. Then first, let's just copy everything from birthday and let's just modify it. So instead of birthday, we can say person, and here we can just hashtag include string. This just allows us to use a lot of string functions. Usually, if you just use normal iostream, then that usually also includes string. But if you don't necessarily care about that and you just want to be able to use a string, then you can also just include string, and then you don't have to include the whole iostream library. And we can of course change this to person. And in private, we'll have two variables. First, their name, so std string name, and then also the birthday object. So we want to give every person their own birthday, which is its own object. This is a very basic example, but it will also allow you to kind of imagine what you could do with this once you scale it up a bit. And we can just say birthday and then date of birth. Now we need to actually include birthday to use this. So we can just say hashtag include and then birthday.hpp. And this will allow us to use birthday here. Then in public, we only need two things. First, we of course need the person, and here we could of course say name, date of birth, where name is of course a string, and we can actually just use that here. And then date of birth, which is of course a birthday. And then we also want a function called toString. A lot of times classes will have a toString function. A toString function is a function that basically summarizes an object for you, and then it returns a string version of that object. So let's say you have a person that's a very big class, bigger than this one, and you call toString on it. Then it will display the person name, the person age, the person date of birth, or whatnot. And that's what toString will do. It will just convert your entire class into a string. I'll show you an example of this. We can just say void toString, and that's a function. Cool. The next up is person.cpp. Here, of course, we can include IOStream and also include person.hpp. There's of course person, which takes in, and we can just yet again copy what it takes in here. You don't have to type it out. And here, of course, we could put it here and say this is equal to this, or just name is equal to name, whatnot. But we could also use this method that I taught you all in a previous tutorial. Name, date of birth. And there you go. Now you can also assume that this will be assigning these variables to them. But mainly we're doing this because we have an object here. This object kind of forces us to do this specifically, because you can't quite do this, the date of birth, and then say date of birth. That's a little weird. So we need to do this instead. Alright. And then finally we can do toString. So void person toString. And here we can just see out was born on. And we can just say name. And then we can just say date of birth. Dot print date. You could also say this dot date of birth dot print date. That's also fine. And there we go. So of course, if your class was a lot bigger, you would have to, of course, scale this up and display more content. But we only have two variables, so we only have to really toString those two variables. So this toString just kind of summarizes the class, everything that we have in it. Or at least everything we have in it that we want people to see when they use the class. If there's some private variable there that you don't want people to see or touch or even know about, then it would be perfectly fine to not display it into a toString here. Alright. Now let's go to main.cpp and let's include person.hpp. Now because person.hpp includes this birthday.hpp, you could remove it. There's nothing wrong with it. However, it's recommended to still keep it there if you're going to be using birthday here, even if it's included in person.hpp. Because in the future, you might remove birthday from person.hpp and you're getting a bunch of errors everywhere because you didn't include that birthday here and it's no longer being included in person. So it's still recommended to include both, but the program can run currently without that birthday.hpp, since in person.hpp it's already there. Then of course, now we can go here and say person, Steve, which is me, Steve, and then just bday. And this will work. And then we can of course say steve.toString to stringify all of this. And now we can compile our program. Just include person.hpp here, or cpp I mean. And there we go. Steve was born on 5/8/2002. Now let's quickly just go back to person here. Now if we try to say this name is equal to name and this date of birth is equal to date of birth, and then just of course remove that, then once we hover over this, it says no default constructor exists for class birthday. And of course, I don't think this quick fix will really do anything. Yeah, but because we can't really do this, this isn't really allowed. Because you'll notice if we hover over this, it's birthday person date of birth. Whilst here, it's just birthday date of birth. And if we try and run this, it's going to error out on us because it's not allowed. So to use an object inside of another object, you will have to, unfortunately, use this constant method that we learned about. And yeah, that's how to use one object inside of another. Now, I think the best way to explain what a friend function is to just jump right into an example. So let's say we have a class, and we can just call this class my class, and my class will have one public item, and this can just be the constructor my class, and all we need to do is we just set the private variable, which we can go private, and we can have one private variable called int num. Now, of course, we could just give it a default value like 0 here, but I'm just going to put it here just for fun's sake, and we can just say num is equal to 10. Cool. And then, of course, we add a semicolon here. And then, of course, we create our class. So, my class CLS for class, of course, and boom. Cool. Now, let's make sure this runs. Okay, and it does. So if it runs, it compiles and runs, it's fine. Now, let's create a function that is not part of this class. So let's go void get num. And here we can actually pass in my class and then a CLS, for example, as the name. And we can make it a reference, and I'll get to this in a second as well. We can then go cout, and we can just print out cls.num. Now, you'll immediately notice we are not allowed to work with this. Num, as we all know, is private. And the only way we can access this num variable is if we make this function part of this class. Now, the way we can do this without actually making this function only available to this class, because we might want to just use this on other classes as well, not just my class, or just on other things in general, we can go void get num, and we can just pass in this right here. Now, as you also know, if we want to actually define this, or actually have this in this, we need to go like that. And then we can say cout and num, whatnot. But the thing is, in this scenario, this get num is kind of part of this class. You can only use this get num from within this class. So you have to go cls.get num, and then you have to pass in cls again if you wanted to do this. But the point is, we want to use this get num as its own function, but still as something a class is allowed to trust. Like you would trust your friend with a secret. And here, the secret would be this number here, which is private. Like you would trust your friend with some private information of yourself, a secret. So we have to make this function a friend to tell C++ that this function does not exist on this class. It is not part of the class. you do not have to first generate an object before you are allowed to use this function. So we can say friend. And this will tell C++ that this function is actually a friend of this class. Meaning we can use all of the things inside of this class like we would normally use. For example, here's num and whatnot, by just passing it in. But now the difference is it's not actually part of this class. So if we want to use this with any other class or any other location inside of our C++ program, we can. It's not just limited to this class. Now, of course, we can just say get num and pass in CLS. Now, if we run this, we get 10. So we are allowed to access this private variable even though this function is not part of this class. It's only a friend of the class. And of course, you can also change that number. So you can go cls.num is equal to 100. And then, of course, it will change it to 100. There we go. And that's a friend function. It's basically a function that is on its own, but it's a friend of a class, meaning it can access details inside of that class by passing it in. If it's not a friend of the class, then the class will not allow it to access things like private variables. Cool. And we'll get to references in a future tutorial. Just know that when you create a friend and you want to pass in a class, you have to use a and symbol to kind of reference it. But we'll get to that in a future tutorial. For right now, don't worry too much about it. Just know you need it there. Now you might have forgotten and might be wondering what exactly is an operator. Well, an example can be, let's say we want to add 5 plus 10. Now the operator here would be 5 because it operates what's going to be happening with this. Same with minus, that will be an operator, divide, times, all of that, that's operators. So let's actually use this class here, and we don't need to keep anything in private, we can just make everything public. Private just makes things extra complicated when we don't really need it. And then let's create another constructor that takes in an integer, and we can just call it num. And then we can just say this num is equal to num. And then by default we can just say num is 0 if they didn't pass in anything. And let's maybe change this from my class to my math, because it's kind of going to be working with math. So it can be kind of like our own mathematical types. Now, of course, this currently doesn't do anything, but we can now add numbers here. Or actually, let's give it a good name. Let's call it vector. Now, we already know one type of vector, and that's like an array. But there's also another type of vector, which is like an x and y value. For example, in game dev, you might have a vector that keeps the x and y of a player. Sometimes even a z, but usually the x and y. And here we could actually do that as well. And then here we could go int x and then int y. And we can just say this.num is x. Or we can even just go int x, y. And then we have our x. And we have our y. And here, of course, this can just set our x and y's to 0. So x is 0 and y is 0. So this will by default just give everything a 0 value. Cool. Now let's create a vector, and let's say this is the player position. And here, of course, we can just pass in like 10 and 20, and that will be the player positions. And then we can create another vector. And let's say this is the enemy position. and this can be 40 and 30. So this will be where the enemy is on the map, and this will be where the player is. And of course, if we try and see out any of these, we shouldn't get any errors. So let's just say enemy position.x, and if we don't get any errors, then we did everything correctly, and we get 40, just as we expect. Now let's say we want to subtract from the enemy position the player position, or even the other way around. But let's say we want to subtract these two positions from each other. Now one way we can do this is by going const int x is equal to enemy position dot x minus the player position dot x, and then the y can be y. And don't mind the const here, I'm just kind of so used to JavaScript I kind of forget that I sometimes add them. But yeah, just don't mind the consts. But this is one way to do it, and then we can just say x dist is then equal to x, and then y dist is equal to y. This is also one thing you can do. However, what if I told you there's possibly a better way to do this? A way we can actually create a new vector that can store these values for us. Well, with operator overloading, we can do that. So let's go here and we say vector operator, because it's going to return a vector, and we'll specify the minus symbol because we want to subtract, and then we say we want to pass in a vector. This will allow us to do operator overloading, and of course we just have to specify vec since we want to pass in a vector, and we will overload the minus symbol, the subtracting functionality. So let's go here and we say vector new vec for new vector, and then we say new vec dot x is equal to vector dot x, and this can be vector 1 because we will have to add multiple vectors together or subtract, and then vector vec 2, and we can just say minus vec 2 dot x. Okay, and let's do the same for y, and then let's return new vec, and actually we only need one, we don't need two. There we go. And in here we can just say x and y, but of course we can specify this, and these will be vec 1. Now I'll go through this in a second. Let's just see that it works. We can now go here, and instead of creating two new variables, we just go vector dist, and then say dist is equal to player pos, and let's first do enemy pos before player, just so we get the same values, minus. And now we can just specify dist here. Now if we run it, we get the same values, as you can see here. So what happened? Basically, we first start here. We tell C++, take the subtract operator we have, and then allow us to get one vector as input. Then create a new vector and set that new vector's x equal to the x we already have in this vector minus the x that has been passed in. Now this x here can basically be seen as this enemy pos, and in this vec1 can be seen as this. And here it says set the vector's y position equal to this y minus vector1 dot y, and it will return a new vector, and that's why we have this extra vector here, which we then use here. Now of course if we were to change these to plus, then the subtract symbol will now add, which will give us 50. Now this might be a little bit too complicated or too complex to quite understand. So let's actually make this a little bit more simple. So let's remove y, and we can still name it vector. It's not really going to be a vector anymore, but we can still call it vector. All right, and then we can just remove that. And now it is less complex. Now this will do exactly the same thing, but it's just less complex. It just does it with one item instead of multiple items at once. So now we'll get the same output. This time there just won't be a dist y. As you can see. And of course, if we were to now change this back to a minus, it will subtract instead of adding. And there we go. Now usually what people would do is they would go something like this, and it will go dist.x is equal to, and then we could say playerpos.x, or even just playerpos.add, and then enemy pos. Now usually people would do this, where you have your vector and then you create a function on top of that class that will add this x position to it. And whilst there's nothing wrong with this, you could instead create your own, where if you minus 2 together, then it will actually subtract from those. Because currently, if we didn't add this operator here, it won't know how to deal with vectors. It will ask, what the heck are you trying to do? You're trying to subtract two classes from each other. But if we add in this operator here, we can specify we want to take the x position and we want to subtract it. And it's a little bit cleaner than having to go and specify, okay, go here to its x position and make that equal to the player pos dot add and then pass in a different class. Because here it's just kind of weird. But you need to specify that if you want to specify y as well, you'll have to go here and say y and player pos dot sub for subtract, I guess. And you'll have to do this. Or we have to do it as we did it before, where we said dist x, or in this case there was no class, but you get my point, where player pos dot x minus enemy pos dot x, and then you have to go y here. Now why would you want to do that? Because let's say you're working in a game where you're going to have to be doing that multiple times throughout the whole game development. Then you'd rather want to overwrite the operator to do something else. In this case, add or subtract vectors from each other. You could even make that it doesn't necessarily return a vector, but an int. And then you could just say new vec.x here. And here you didn't even need another vector anymore. You could literally just move this here. Because if you do game development, something like this can be very useful. It is oftentimes recommended to just leave operators alone, unless you really need to kind of optimize your coding performance by not having to say class dot function parentheses class, and whatnot. But this is just a way you can modify this to do something else. For example, we could say even times here, and now minusing two numbers will times instead. Now this might have been a little bit confusing, but all we did was we just said whenever we use this class and we use a minus on two of these classes, we want to execute this code right here. In fact, we didn't even need this anymore. We can just return this at this point because we're just returning an integer now. And we want to execute this whenever we minus two of the same classes together. In this case, we want to times them together. And yeah, that is the basics of operator overloading in C++. You can of course do this with all other operators like modulo, times, divide, subtract, plus, and whatnot. You can even do it with the equal symbol if you really wanted to. Now, Makefiles is a rather complex topic, and there's a lot of things to it. Most of the time it's Googling to figure out what you really want to do. But I'll show you the basics of Makefiles, and then I'll show you almost a somewhat semi-real world example of a Makefile, one that I use in one of my projects. Now, when you think of Makefile, you can think of Java Gradle in a sense. Makefiles just basically do the compiling for you. So instead of you having to say C++ or G++ and then pass in all of the files you want to compile, and then you have to add flags to specify you want this library and this library and this library to be included as well, which can be a lot of flags that can be difficult to manage whilst you try to execute that. It's a massive pain in the butt. That's the point I'm trying to make. Because if you ever see me write some G++ stuff here, even just this part here, it's already a lot. Now imagine you have a file with a ton of things here, so x.cpp, y.cpp. So let's say you have about 10, and this is a small program, just 10 objects that you have to include here. And then after those 10 objects, you also have to include flags of some sort to specify where libraries are. For example, -i is I think a common one, and -l I also think is a common one, but I can't quite remember. But you have to add all of these tons of flags and things if you want to link libraries and things. It's very weird, and it's a lot of effort. So we use Makefiles to not only make this easier for the developer, but also easier for the next person who's going to come and try and compile all of this. Now you have to take note that Makefiles works slightly differently compared to Windows than on Mac and Linux. I'll be covering the Linux and Mac way, but if you're a Windows user, you can still follow along. You might just not be able to quite use everything I'm using in this video, but you will still be able to learn what a Makefile is and how it works. Cool. So let's move our vector class outside. Let's go here and create vector.hpp and vector.cpp. Then with our vector HPP, we can just copy this, paste it here, and of course do our hashtag if not define vector underscore h, define vector underscore h, and then hashtag endif. Cool. And then of course we can copy this and we can go to vector.cpp, and we can of course include vector.hpp, and then just append the vector everywhere here, and then we can just clean up here. Cool. So now we have our extra class, and we can now move this away and say hashtag include vector HPP. And I think we actually left this broken in the previous tutorial. Yes, we need to change that back to subtract, and here we change that back to subtract. Cool. And let's make sure this works by just compiling this. G++ main.cpp vector.cpp-o output, and then run that output. Okay, so if this compiled and run, then we're good to go. If you are on Linux, you can just go sudo apt install, of course without the equal symbol, CMake, or sudo pacman-s CMake, or whatever your distribution accepts. Point is, you have to install CMake. I think this is true for Mac and Windows. You have to install CMake, because that will kind of make everything for you. Cool. Now let's assume you have CMake installed. Next up, you can say Makefile and create a new file called Makefile. And Makefile will contain a bunch of code for us that we can use to tell it how to compile everything. Now first I'm going to start off really basic, and then I'm going to show you a more extreme example of a CMake file. So let's first start with output, and we can just say main.o and then vector.o, and here we could say main.o, and I'm going to explain all of this in a second, is main.cpp, and then g++-c main.cpp, and we of course have to go here and say g++ main.o utils.o -o output, and then here, and yet again I'll explain this, vector.o is equal to vector.cpp, and we can just do that, and then we can do clean, which is just an extra function we can add, rm anything with an output. Cool. This is a very basic make file. Okay, so on the first line, output main.o vector.o, we are saying that it should generate object files that will be later on compiled to the output file we want. Now, object files you can think of are as like compiled C++ files. In our case, we just always say output. But if we ever try and do our G++ thing we do, and we just change from output, or we didn't even add an output here. So if we were to remove this -o flag, then you'll notice we actually get an a.out. So it's the same thing in a sense. And then these C's here, they're telling us to generate this object files. So if we were to go here and say g++-c, and let's go here, you'll see we have a vector.o and a main.o, and we actually have to change this vector.cpp and vector.o to a capital case V. Anyhow, so these just generate these object files. Oh, I almost deleted everything. Now these object files are just compiled C++ files. However, they are in their own file. Meaning, if they have been compiled and you want to change one thing in one file, then at least, as long as you haven't changed anything in that file, it will stay compiled. For example, let's say we create object files and I have a main.o and a vector.o. If we change something in main.cpp, it will generate a new main.o file, but not a new vector.o. So only a new main.o file, because we only changed something in main. So there's nothing else to change in vector. And here we're saying we want to then compile these objects into our output we want. And what I've just explained might just sound very all over the place, but this allows us to never have to really recompile the entire program, because once your program gets really big, if you have to recompile the entire program every time you change a small thing in the program, it's going to be a massive pain in the butt. Because then you have to wait sometimes 30 minutes just for the program to finish compiling. And let's say you make one change in one file, and you have to wait 30 minutes to see that one change in that one file, just because you have to compile everything again. So instead, we tell CMake, create object files of every file we have. Then take those object files and compile them all into an output file. Then we can run that output file, that executable. But once we change something in main.cpp, then only generate an output file for main.cpp. Do not regenerate an output file for anything else, because there's no need to do that, because we only changed something in main.cpp. So then it only has to compile one file instead of all 30 files you might have in your program. And this could make compiling a lot easier and a lot faster. And then of course this clean just means remove all of the output files. On Windows you won't be able to use rm as well as G++, because these are things only available I think on Mac and Linux. Also, this clean here, that is optional. If you don't want to, you don't need to have that there. We only have it because it would clean everything for us if we use the clean command. Now, to compile our program, we can now just run, let me actually just resize this a bit. Blah, there we go. Now we can just say make. If you have installed CMake, you can do this. And here you can see what it does. And here we have utils.o, that should be vector.o, my bad. Now if we run it, there we go. And now we can just run output and we'll get the output. If we change one thing in main and we change this to the distance, so we change one thing in main.c++, we say make. As you can see, it only regenerates one file, only main.cpp, because that's the only file we modified. And then it just compiles the already compiled vector and main. And we didn't have to generate a new vector.o file. And we now have a new output that if we run, we get the dist. And of course, if we were to change something in vector.cpp, where we change from times to minus again, run it, and you'll see only vector.o is being regenerated. And then of course, if we try to run that, we get the dist and in a smaller value. That is the power of CMake, and this is a very basic example. But CMake can be used to specify C++ versions to compile with, specify libraries you want to include in your compile, and whatnot. Now the first thing I want to show you is where a CMake file would have been useful. This is only one file, but it could still be rather useful. If we go into this main.cpp of a database connection project I made, then here we have this whole linked output and stuff. If we had a CMake file here, we could make that it automatically detects your MariaDB or SQL database you're using, and then it could automatically link those databases you're using if we used a CMake file. Then instead of having to manually do this output here, where in the video where I created a tutorial on this said you have to figure out on your own where these are, but it should be similar to this. If I made a CMake file, then this could have been much easier. So this is where a CMake file would have been very useful. Even if it's just one file, that CMake file could have found where to link this from. And in here's where we'd use a real CMake file. So here there's so many things. So here's CMake lists.txt. It's very similar to a CMake file. You still use a CMake to do this, but you instead generate make files. For example, here I'm saying CMake minimum required version, and here I'm saying we need CMake version 3.0 at least before we can compile this. And in here we're setting the CMake build type to debug, so it will build to a debug mode. We could change this to production types. And in here we're setting what flags we want to add to our compile. This is a very basic example, but here we could add a lot of powerful flags to our CMake. And in here we're saying what the project would be called, and here we're saying what should be used to generate this executable. Now this isn't a makefile. However, it can be used to, in a sense, generate a makefile. If we were to go, then here you'll notice we have a build folder. And here is a makefile. Now, I believe if I can just go trash build, and just so you know, Nemo, that's what I meant to say. So as you can see, it just has a CMake lists.txt file, and it's the same CMake list that's here. It's the exact same one. However, if I now go in this folder where that CMake list is, and I say CMake, or actually I mean make. My bad. I meant to say, I think it's CMake. I haven't coded C++ in such a long time. There we go. Now it actually generated everything here. But as you can see, there is now a makefile where before there was no makefile. There's now a makefile. And if we were to open up or read that makefile, well, let's just open up in VS Code. Makefile. Here we go. And this is the makefile it generates. Because usually writing makefiles is pretty complicated and disgusting. But here is what it generates for us. So we don't have to write this makefile like we did here. We instead create a CMake lists.txt like this. And in the CMake lists.txt will generate that makefile for us, giving us all the flags and saying what we should compile and in what the outcome of that compile should be. Now CMake lists is also something that's on a different level or a different video, different topic. But in a sense, it's basically a makefile, but much easier to do. But usually you just kind of take guesses and Google what you want to put here. Usually I just copy paste this and modify it a little bit, and that usually works. But there are often times where something more complicated would be a bit better. For example, one of my friends, he made this libytdl application, which is basically a YouTube DLC, but made in C. You can think of it as like that. And here is his CMake file. You can see here we're saying we need at least this version of CMake installed. Here is defining how the project basically is, what it does, the version, the language is used, whatnot. And he's defining the CMake module path. And here's the compiler configs. Then there's a bunch of build options. And as you can see, it can get really complex and deep when you get down to it. But as you can see, you can also get if statements and a bunch of other things you can do in here. And this makes compiling your C++ program a lot easier. I'm not going to jump too deep into this because it's a pretty wide topic to cover. But yeah, that's the basics of makefiles and CMake lists and why you might want to use them. Because now in that compiled program we made with CMake dot, we can now just say make. And here it will build our program for us. It will compile everything, and if it changes one thing, it only has to recompile that one thing. And now my BGM player works. And yeah, that's the very basics of CMake and makefiles. And luckily for us, we actually already know what a struct is. Let's get started with something simple. I'm going to clean this up. And let's first create a class. Class enemy. And this class enemy just has a function called move. And this will just see out moved the enemy. There we go. Very basic, doesn't do much. Now, let's do the same. We copy this, we just paste it here. And we change from enemy to player. And change this to player. And change class to struct. You'll notice everything here still works. Now, first, let's go here and say enemy e and then player p. Okay. Let's go e.move and let's go p.move. Now, this code right here will throw an error. The reason it will throw an error is because in enemy, since it's a class, by default, everything is private. And with a struct is the same thing as a class. However, by default, everything is public. We could also make things private if you want. We can just say private colon. And I will make it private as well. But by default, in a struct, everything is public by default. You don't need to add a public colon or public colon there. In a class, everything by default is private to the class, unless specified otherwise with private. If we run this, it will work. If I just see pile here, move the enemy, move the player. But if I were to remove that public, it will throw an error because the player is now, or the enemy is now private, or the move function it is private. So you can think of a struct the same as a class, but if you have more things that by default should be public, then you could use a struct instead of a class. If you have more things that is private by default, you could possibly use a class. On the end of the day, it doesn't really matter. Both of them are basically the same thing.
Let's first see why would we need templates. Let's quickly try to build a basic calculator. So first we'll need to create a function. So float add float x float y, and this will just return x plus y. Pretty simple. But now we need to add an override to this function. So float add, or this should be an int because it will return integers. So int add, and then we want to get an int x, get an int y, and then return x plus y. Now, for such a basic example, you might not see it, but there are cases where you will need to do this multiple times before it actually works. Now, let's say we need to do this for subtract as well. Now we need to go here, we go subtract, and we need to go here, change this. And now we need to do it for division and multiplication too. You see, it becomes kind of a lot of work. So instead of doing this, having to do multiple functions overrides, just so we can have a basic calculator and do both floats and integers, we can go and create a template. So template and class, and a lot of people like to call these T, but you can also go my type or whatever you want, because this is basically going to be your own custom type. But let's make this T for now. Now here we can say T add TA TB, and in here we can say return A plus B. Now this custom type could be your own type, which could be an integer or a string or whatnot. But now this add can do multiple things at once. So now here we can say cout, and we can say add 10 and 9, 10.8 and 19.1, and let's try strings as well. Cool person. Let's see, we compile this, and this last one won't work because that will be characters and not strings. Here we go, 19 and 29. So this T here is now standing in for both integers and doubles. Of course, it's very similar to just saying auto. However, it's more specific to what you want your type to be. And of course, you could just do some type checking here to make sure that this is either a number or a float if you wanted to. But the nice part here is you only have one function, and that function only needs to be declared once. You don't need to redeclare it just because you need different types. Now this is called class templating. You could also do class, and let's keep it like this and just say type name is T. Now let's remove that, and now you can just use it with a function. So let's say void swap arrays, and this will swap arrays. We then have T array 1, and then T array 2, and then the int of the R size, so the array size. Now you can just say for int I becomes 0 while I is less than R size I++. We can then say a temp, t temp, So we're creating a new variable with our t type here. So ttemp is equal to array at index I. And then array at index I is equal to the array at index 2. This is just a at index, I mean at index I. So it's just basically swapping them. So we're storing it in a dummy value. And then this dummy value takes in this I, or this dummy value stays like that, but then array 1 gets array 2's value. You just maybe go like that. And then last but not least, we can say array at index 2 now gets that temporary value, array 2 at index I, temp. And now we have swapped arrays. It doesn't matter what type the array is, but the idea is that we swapped the array. So what we can do now is we can go here and we can say int x is equal, anything like that, is equal to 1, 2, 3, 4. And then int y is equal, and here we can maybe just add a 0 to each number. So one contains 1 to 4 and the other contains 10 to 40. And we can maybe display the array, so 4 and then int I equals 0 while it is less than 4. We can just go here and cout x at index I and then space y at index I. Because if we were to run this, we'll get 1, 10, 2, 20, 3, 30, 4, 40. Now let's say swap arrays, and here we pass in our x and our y, and we say 4 because that's the length. And now here we can say cout and just add in empty cout there to give us an empty line. And then yet again we can do this, copy paste. Now if you run this, my bad, we get 1, 10 to 20, 3, 30, 4, 40. Then we swap. Now it's 10, 1, 22, 33, and then 44. So this right here have saved us the trouble of having to get the values, the type of values inside of this array. So here it's 10, but we could make this a string, a double, a float, whatever you want can come here. Because t basically means whatever type is passed in is this type here. That is t. So let's get started with what exactly is a pointer. Well, a pointer is something that points, so imagine like someone pointing to an address in the memory. So here we have our RAM. So imagine this is literally our RAM stick that we put inside of our PC. And it has all of these little things here. Okay. Now, when you put something in the RAM, let's say the variable x. So you have the variable x which is equal to 10. The variable x then has a special address, something similar to the lines of, I don't know, let's say 3, 4, A, X, Z, P. I don't know. It is a similar address to this. This address is where X can be found inside of the memory. So let's say this address corresponds to right here in the RAM. It's the address. Now when we want to get X, what it usually does is it goes to this address and it says, hey, address, what do you store? And this address says, hey, I store 10. And it comes all the way back and it's like, hey, this address stores in X the value 10. That's usually what happens when we try and set a variable. So if we were to go here to our code and we were to say int x is equal to 10, and then we were to say cout x. That's basically what's happening here. We're saying, hey, this x variable should have this address and it should contain this value. Then we store it in here. Then we try and get it. It's like, hey, this x variable here, what does it store? So it goes to this address, it checks, and it brings back and it gives us that. Another way that people also like to do it, then we can actually discard this, to explain it, is to use houses, because houses has addresses. Just excuse my terrible drawing. Because every variable is housed in its own house. This is a variable. This could be variable x. This could be variable y. It has an address. So this could be 44AXF, I guess. And this could be 92AXF. Or E, whatever that is. And this is an address. When you think of a memory address, you should think of a house. It's an address. If someone asks you, hey, what's your address? That means, hey, where do you belong? It makes sense, right? So if I ask X, hey, X, what is your address? They return me this, and then I can go to the memory, and I could search for this address to find where X lives. So I can go to X's house and get the values that are inside of this house. Now that's the basic concept. A lot of people overcomplicate this. They think that a pointer is much more than this, but it's really that simple. That's something you have to kind of wrap your head around, because a lot of people struggle here because they don't really realize how simple the logic behind a pointer is. A pointer is just an address in memory. That's all a pointer is. With that knowledge, let's go here. So we have X here. If we print X by saying cpile, we get 10. If we print %X, and we compile and run that, we get its memory address, what we just talked about. So this is where X is in your RAM. This right here, that is where X is in your RAM. Every time you run this program, there's a chance that this will be different, because X is, every time you run the program, X is stored in a new location. It's being redeclared, so it's given a new address in memory. So doing this, we can get the address in which X resides. You could also declare pointers. For example, let's go here and say int p1 for pointer 1. And if we add an asterisk here, it means that this here is a pointer. Now, some people like to have the asterisk here, some like to have it here, and some like to have it here. Where you have the asterisk doesn't really matter, as long as it's after the type and before the variable name. But now we are declaring a pointer. This pointer doesn't have a value. However, we could give it a value by saying this pointer contains the value, or is pointing to, X's address. This might seem a bit confusing, but if we go here to cout, and we cout p1, so we cout this pointer 1, we get this. This is, strangely enough, the same that you'll get if you print out this. That is because this just stores this address now. This address here, that's all it does, it just stores it. So when we print it out, we get this address. We don't have to use an ampersand here to get the address, because it is already an address. We're saying here it's an address. It's pointing. So here it displays the address. To dereference a pointer, this means to get the value inside of a pointer, you could use your asterisk here. Now if we were to run it, we'll get the value that is stored inside of this pointer. So by using an asterisk, you can get past the location and just get what you want. Of course, this means if you were to do this, this is perfectly valid code, where we get the value inside of this reference, inside of this address. So X address, and then get the value inside of it. So this will give us 1010. So let's say you have a pointer and you want to store the value inside of that pointer inside of another variable. That means you can go int val, that will be equal to asterisk p1. And this will store the value inside of p1 like that. And just like that, we have worked with a lot of spaces inside of memory. I'm not going to go too deep into pointers just yet. I think we should take it step by step, because I think that would probably be the easiest way to understand what a pointer really is and how it works. So to get back from the start, let's just go through it one more time. A pointer points to the location of a variable in the memory, in the RAM. It gives you the address of a variable. And whatever is at that address is whatever is inside of the variable. Using an ampersand means point. So point to this variable address. So this ampersand here, this means give us the address of this variable. By using an asterisk when declaring a variable means that you want to store a pointer. You want to store the address. You don't necessarily want to store the value. And then also using an asterisk, you can dereference a pointer and get the original value inside of it. And you might not see the use for it yet, but sometimes you need to edit a variable specifically. You don't want to edit a new variable, like when you pass it into a function. You don't necessarily want to get a new reference of that variable, like a new version of it. You want to get that specific variable. Then at that point, using a pointer is a good idea. But yeah, that is for a future tutorial. So let's say we have an integer. We just call it a and make it equal to any value whatsoever. Now if we were to see out a, then I'm pretty sure by now we all know what we are going to get. So if we run here, we get 12 as expected. Now let's create another variable, int b, make b equal to a. Now if we print out b, we know that we are going to get b. So we have 12 and 12. Now when we go here and we say b is equal to 24, for example, and we see out b again, what do you think we're going to get? Well, by now, I think we all know we're going to get 12 and then 24, because b is actually its own variable. So when we look at a here and we do this, that means that b just gets the value inside of a, but a itself stays the same and b will change when we change b. So if we were to copy and paste this, and we would change this from b to a and just print out a. We don't even need to change a, we can just print out a. Then you'll notice a is still 12, even after we changed b, because they're two different variables, two different locations in the memory. However, we can create a reference to a variable, like int b, and we just do this, and we are saying that b is a reference. It is a variable, but it's referencing something else. So now when we run this, we get 12, 12, 24, 24, because a has been referenced by b. When we reference something, so when we say ampersand and then our variable is equal to whatever is here, so this should be a variable, then we are saying b becomes a. B is basically the same as a, but a different variable name. They have the same location in memory. So even if I were to change this b here to a, both will change because they point to the same location in memory. B is referencing a, and a is in a specific location in memory. So if I were to just bring up a drawing application here, then let's say this is our RAM. Big chunky boy. Right? And we say a is equal to 10. The location of a, we can say, is right here. So this is where a is housed. It's where its location in the memory is. So when we say b is equal to 10, then
or let's say b is equal to a here. So when we say b is equal to a, b goes to this location in the memory address. But b copies the value, so copies this right here and puts it here. So now b is also 10, so just copy the value that's in here. But when we say ampersand b is equal to a, we are saying this b here, it goes right there. A and b are the same thing now. However, b actually references a. So b isn't a, but it does point to the same location in memory as a. So you could see it as being the same as a. And references can be very powerful. And I'm going to show you a few basic examples. However, first I just want to show you something. So when we do this again, when we say this, and we print out the locations in the memory of these by just using an asterisk, or I mean an ampersand, then here you can see they're in two different locations in the memory. However, if we were to say ampersand b is equal to a, then b is referencing a, and they'll be in the same location as I said. But take note, this b here is not the same as this a here. This here will make b contain a pointer, so we need to do this. So now b here contains the pointer location for a, whilst this here makes b reference a. Very similar, but quite different. Let's do a little bit of practice. Let's create a function. Void change. Change is a function that will change a variable for us. Like we say int v, and here we can say v is equal to 10, and now that's change. If we go here, we say a is equal to 12, we see out a, and then we say change a, and then see out a. We expect that a would not change. Perfect. So a did not change. And that is because this right here, that's a new variable. We're generating a new variable, just copying the value that's stored inside of a. However, if we were to add an ampersand here, a will now be referenced when we take in a here. So now when we run this, a will be changed to 10. So this value a here will be manually taken and it will be changed. This is very powerful and in a lot of cases very useful. In languages such as JavaScript, this does not exist, but sometimes you do wish it does because it could make life a lot easier being able to reference a variable instead of having to change that variable with a return statement as an example. You can also do references with pointers. So instead of putting an and there, we could put an asterisk there. However, this will just need a little bit of extra effort by us needing to go ampersand a here, because we want to point in the location here. And then of course here we want to dereference this v and put that value there. So if you wanted to do it with pointers, it's 100% possible because they're very similar. By using an ampersand, it's basically just sugarcoating, having to do a bunch of effort to get this value and store it somewhere else. So now if we go here, we get 10, or we get 12 and 10 again. We will be diving deeper into this in the future because this is a very powerful topic in C++. It's a concept that if you get it right, you can make a lot of powerful applications with it as well. Now, first of all, since we want to work with smart pointers, we need to include, and this will allow us to work with smart pointers. So you might be wondering, what exactly is a smart pointer? What makes it smart? Well, these are pointers you don't have to delete yourself. They will delete themselves automatically. So generally when you create a pointer, you have to delete it yourself after you have created it. Currently we haven't really been doing that in these tutorials because we have been looking at the basics, but Usually if you create a pointer, you have to delete it later. For example, int I is equal to new int, and then you have to delete I. You have to do this once you're done with the pointer. Otherwise, that pointer is going to stay in memory. And as long as that pointer stays in memory, you cannot use anything else in that memory location. So if you have 1,000 pointers in memory, that means 1,000 places in memory. So let's say all of them were integers. That's like 4 bytes. 4 times 1,000, that's 4,000 bytes. So that all that space in your RAM can no longer be used until you reboot your system, because those pointers were created but never deleted. A smart pointer will delete itself. Generally, it is recommended to use a smart pointer before you try and use one of these pointers. Because of these pointers, they can be more difficult to manage. So let's talk about the two types of smart pointers we are going to be talking about. We have the unique pointer and the shared pointer. The unique pointer are just scoped pointers. So when it goes out of a scope, it gets deleted. You cannot copy a unique pointer, so take that as note. That is why it's called unique. So it's unique, and once it goes out of scope, like let's say you have a function, once that function call is over, it's deleting itself, because it's in that function scope. And then you have a shared pointer. This is a smart pointer that you can have multiple of. So it will automatically create itself, it will call the new keyword, and it will automatically delete itself. However, unlike with unique pointer, you can have multiple of these without any problems. So to create an example, let's create a class person. And this person class will have no private items. It will have a constructor, person, and this constructor will just create a cout, person was created. Then we can have a destructor that just sees out, person was destroyed. Because generally we know by now that when you create a constructor, it basically runs before the rest of the code runs in this class. It is what starts everything up. And a destructor is what ends everything in the end. And then let's create one extra function here, just so we can see an example. Void say hello. And this say hello function will just say, hello there. There we go. Oh, let's just remove these. Cool. Let's start off with a unique pointer. So just to create a little scope, you can either create a function or you can just do this. This will automatically create a scope in C++. So anything between these is a new scope, or is in this scope. So once it goes past this here, whatever is in here will be deleted if it's not part of global scope. Cool. So you have two ways to create a unique pointer. You have the first way, which is std : unique pointer, and you specify what you want to create a pointer of. So in this case, person. This is our object we want to create a pointer of. Person is equal to, or here you don't need an equal, you can just say person, and then new person, like this. You can use this. However, it is not really recommended to use this method, primarily because in general, smart pointers calls the new keyword for you. So when you do new person here, you're kind of missing a nice function that smart pointers gives you. So you don't have to use new. Instead, what is recommended is that you go std unique pointer person is equal to std make unique, and then you specify the type person, and then there you go. You have just made a unique pointer, where this is what you are pointing. This will automatically call new for you, and at the end call delete. This is also recommended because this way it's safer if an exception occurs. With the previous method, if an exception occurs, then you might sit with an empty pointer, so a pointer without a reference, which will generate a memory leak, which means that everything we have just explained, there's a place in memory that is now filled with a reference to something that doesn't exist, an empty pointer. And here we can just say person, say hello. Let's try this out. I'm going to compile this and run it. Person was created. Hello there. Person was destroyed. So it created a pointer to this person object, and then it destroyed it after this. Now let's say we created a pointer without this safety in it. So person is equal to new person. Okay, there we go. Now let's try and run it. We get person was created. Hello there. The program finished and we did not get a person was destroyed. So there is a little bit of a memory leak here, because now we have this object, this item in our memory, but it's not being used. To fix that, if we used normal pointers here, we had to go delete person and then run it again. But Smart Pointer kind of removed the need for that. So now we can remove this creation here and that delete, and we just do this. It will call new and it will delete it for us. Cool. Now let's take a look at shared pointers. Now, unlike the previous pointer, we should never actually do std shared pointer and then the type person and then person new person. This is still okay with a unique pointer, but with a shared pointer you should never ever do this. Instead, you should use the method we used previously, where we have std shared pointer person, and let's call this person 1 because we might want more since this can be shared, is equal to std make shared and then our person, and we are good to go. This is perfect. Now it will delete itself, it will create a new one. Now the nice thing about a shared pointer is it can be shared amongst other shared pointers, so multiple shared pointers can have the same thing. So let's say std shared pointer person, and then we can just say person2 is equal to person1. So this shared pointer here is sharing the first pointer. So it's just like having two pointers over a reference to an object that is basically referencing. So this is like perfectly copying a pointer. And the above will get deleted automatically once all of the shared pointers have been deleted. So if this shared pointer is deleted and this shared pointer is deleted, then it will delete itself automatically. So when all of the shares are deleted, they are not being used anymore, we are good to go. So to give you an example, let's go and create another scope here. Now inside of this scope, let's create another scope where this person exists. So this here can scope into this one right here. This is global to this. Just like with a function. These are basically what we use for functions, right? So it's the same concept. Now let's see what happens when we run this. Person was created, person was destroyed. So it didn't destroy the person 2 times, it only destroyed the person once. Even though this pointer was destroyed, we can still use this. The person 2, let's say hello, and person 1. Say hello, because 2 here is just referencing 1. But 1 will stay alive until the very end, until the end of its scope and all of its other items have been deleted, which would happen automatically. You don't have to worry about it. If you run this, you get what you expect. This is a little bit of a complex topic. You will use it a little bit, but for the most part, when you use pointers, try to use these because they can be very useful and save you a lot of trouble in the future. Let's start off with what exactly is a thread. Well,
your application can run with multiple threads. So when you have a threaded application, that means you can maybe execute two things, not quite at the same time, but it feels like it's at the same time with how fast generally your CPU is. For example, let's say you need to download content behind the scenes while the user does something on the app. For example, let's say your YouTube, and the user clicks the download button, but they want to watch a different video while that thing is downloading. Well, then while it downloads, that would be a thread. The download would be a thread. Then while they watch another stream, that would be also a thread. That will allow your user to do multiple things at once, or your application to be able to do multiple things at once, or that's how it looks. Generally, it's not quite at the same time, but it's usually such a fast switch that you don't notice the difference. So basically, whenever a thread is not being used, that will allow a different thread to start being used as well. So this allows your application to run much faster. Generally, we don't need to go too deep into threads, but that's just a general example. So let's create a basic function here that does not use any threads. And we can say void something. And this something will be just a normal function that loops and runs something. Let's create a global scope variable, boolean run, and we just make this true. Or let's make, yeah. There you can go, while run, and you can see out hello world. Now this will just create an infinite loop, and let's just see an example of this. Now if we do something, or when we do something, it will just start executing that. And we will never really get to this std cin, so getting user input dot get. So let's say we want to run that while loop until we get user input. Now when we do this, and we run this, you'll notice we just get a bunch of hello worlds. In fact, if I were to open up a little example here, go htop. So this right here is my CPUs. And let's view how the CPU usage looks, just for a fun fact, while we run this. And you'll notice the CPUs jumped incredibly high. And we can't do anything here either. Now where a thread comes in, it will make it easier for us to do something here, and generally it could maybe help with the CPU usage. So let's turn this into a threaded function, because we still can't get here where we can just get user input. So if I were to do this, you'll notice we get user input here, and if I press enter, it will cancel, or it will finish the function. Now what we want to do is we want to be able to get user input, and then once we get user input, it will stop running this do something here. So let's go here and say hashtag include thread, and this will enable threading for us. Then I'm just going to say using namespace, because this is a very long namespace and I'm not going to type it over and over again. So std literals chronoliterals. So this is just so we can sleep the thread for a second or so, just so we can get to where we need to. Now each thread has its own unique ID. So when you spawn a thread to run something, it will have its own unique ID, which you can later on modify if needed. So if you need to work with a specific thread, you can use this ID to work with it. So we can just maybe see out so we can get an example of it. Thread ID, and we can just say std this thread, so it will get the current thread, and then get ID, so we'll get the ID of this current thread. Then here, while we're running, we can do that, and we can just say std, and in this thread, so this is whenever we want to work with this current thread, sleep for, and let's just sleep for 1 second. So this will sleep for 1 second before it continues on this thread. This will give time for other threads to work as well. Then here we can say std thread
worker, and this is just a worker to do something for us. It's a thread, and we can just put this function here without parentheses, because parentheses will try and execute a function, and this will put this function on a thread it can run whenever it has times. So what will happen now is this thread will start spawning, and it will create a bunch of loops that will need to run. So this while loop will run. Then once we put an input here, because nothing after this will execute, because this thread will spawn and will execute this function, it will get here and will wait for our input while this thread is running in the background. Once we get our input, we want to stop this from running, so we can just go run and make that equal to false. So run is equal to false. And then when you say worker.join, and this will wait for the thread to finish executing before continuing to the rest of the program. Because if you just leave a thread open like that, it can cause a bunch of errors which we don't need to get into right now. And in here we can just say, so let's go over it again. So we create a thread, and this thread will run. It's very easy in C++. So we'll run this thread and we'll start executing this function, which will just continuously say hello world. Then here we are saying try and get a user input, and generally this blocks us. So if we were to just remove this thread here, and let's just remove everything that contains thread by going like this, because you don't have to do a bunch of things to compile yet. So when we do this, we can expect that we won't get the C out here, because it's going to try and get user input first. So I first need to do user input. When I press enter, it will say finished. So it will first wait for this, and that's generally how it goes. Same with a thread. We start a thread, and it will run this function, but it will never go past this until we actually do this cin.get. Now let's run this, and to run it you need to add a special flag. So g++ -lp thread, and in your file -o output, and then we can just run this output. Now it will every 1 second run this hello world for us, and here's the thread ID. So you can see it only spawned one thread because there's only one thread ID. And now every second it puts hello world here until I press enter. Once I press enter, this cin.get will stop executing because it got what I wanted. It got an input. It will set run to false, which will make this no longer execute. It will wait for this thread to finish doing whatever it was doing. Then it will print out finished, and it will stop the program. And working with threads is really this simple. It's just creating a worker thread, telling it to do something, and then that thing can be done in the background while you're doing something. Of course, you didn't have to put like wait 1 second here. That's an optional feature. But if we do this, and we get our hello world, but you can't really see anything happening until we press enter, and then it says finished. That's the basics of threads. We might go a little bit deeper into this in the future, but as you can see, working with threads are really simple. It allows you to do multiple things at the same time, not literally the same time. It has a little bit of a difference there, but it feels like the same time. And it is super easy, especially in C++ to use. Now, first of all, if you want the code, it will be here in weebnet2 YouTube projects. This link should be in the description. If it's not, just leave me a comment and I'll remember, hey, that should be in the description, and I'll add it into the description. You'll find it inside of this C++ folder here. Currently, there's only one thing in here, but I will add it after this tutorial has been filmed. You can just click on here then, and boom, you should be able to open up here, and you should be able to get the code if you need it. Otherwise, you can just follow along and we'll be good to go. This link will also be in the description. This is the library we'll use to run this C++, or to run Lua inside of C++. You'll have to go to this right here, this link, and you have to go to code, and you can either download a zip file, get it via SSH, GitHub CLI, or you can just use the regular HTTPS method. I like this method because it is very easy to clone. Okay, once you've chosen your method of downloading this, you want to go to your downloads folder or wherever you want this source code to be.
and you just want to say git clone. This is if you're doing the same method as me. Git is a version control system. It's very well integrated with GitHub, so we can use Git to get code from GitHub. If we do this, it will download the code onto our PC. Now, if you're not great with the terminal, all I did is I just downloaded the code. Here we go. All I did is I downloaded the code here in my downloads folder. See, Lua CPP, and here's the code. You should see the same. Next up, what you need to do is you need to go into this folder. So in my terminal, that would be cd for change directory, Lua CPP. And before we continue, this method we're going to use in this tutorial is primarily focused on Linux and Mac OS like operating systems. So if you're on Windows, you might have to do a few steps different, which I don't know which you should do different, but you could go to these people right here, just create an issue and ask how do you use this on Windows, if there's not already an issue on it. And they might tell you how to use this on Windows. However, there should be fairly the same process, just a few minor differences here and there. And I believe if you got C++ to work on Windows without any issues, you'll be smart enough to figure that out on your own. Alright, so here's my code, and here is my terminal. Now what we have to do is we have to create a build folder. So mkdir build. As you can see, there's now a build folder. And just go into that build folder, and now we need to make the things here. So we can say CMake. I assume you have this installed if you watched my CMake tutorial. And we can just say source. And this will make everything buildable in here. As you can see here, it has created everything we need here. If we were to ls here, you'll notice we have a bunch of CMake files. Now what we need to do is we need to say make-j, and then in these quotation marks, these are like backtick quotation marks, usually right next to the one on a US QWERTY keyboard. And then you can say in proc. Do that and it will build the entire project for you, and all you need to do is just wait. Now take note, you do need Lua installed for this to work, at least the development files, because you'll need to link the development files in the compiling process when you compile the program. We'll get to that, but just note you do need Lua, or at least its development libraries installed. I have Lua's development libraries of Lua 5.3 installed, so I'll be using that. However, this does support Lua 5.4, so if you have those libraries, then you're also good to go. While we wait for that, let's build our code, or let's code out what we need. Alright, so we'll clean up a little bit, just plop. Okay, so here's our basic program that we usually have. So first of all, we need to include the Lua C++ development libraries, which you will not have installed yet, but I actually already have this installed. So hashtag include Lua CPP right here. You might have to tell VS Code where to find this Lua CPP. So we can just go quick fix, and we can edit include path settings. And then right, I think here is where you need to change it. So for me, the Lua path, I believe, would be somewhere that's not completed yet, so I can't use that terminal. Let me just open up a terminal here then. It should be somewhere around here. So from my root directory, usr local include, and we should have Lua CPP if you have installed it. We have not yet completed the installation here, but once you have completed the installation, you should see something similar to this. If you see a lua.hpp, you're in the right folder. So we just need to go here, just need to copy that and then plop it in here. So boop. And now we should be good to go without any errors. And we might just want to say .hpp. And for some reason it did not save it. And it is not saving it still. And I think we have to go to this right here. And yes, now all we need to do is we add this. And there we go. Error is gone. And that worked. So all you need to do is you need to go here,
click on this one right here. You don't change it in here because it doesn't seem to work. Go here and you just edit your include path to include Lua CPP. And this is after this has finished installing, of course, or compiling and stuff. And then back in main.cpp, we can start our coding. So first of all, I want to just use a few namespaces here because there are quite a few and I don't really want to use all of them or constantly type them. So I'm just going to say using namespace Lua CPP, and I'm just going to copy this 2 times and then just go colon registry. Doesn't matter which order these are in, so don't worry. And then engine. I don't constantly want to use these namespaces when I type, so I'm just going to ignore them here by saying using namespace. Now let's start off with creating a simple piece of code just to run a line of Lua code. So first of all, if we want to print out in C++, we use cout, hello world. As simple as that. Now in Lua, when you call it from C++, it's a little bit different. First, we need to create a Lua context, so we're able to access Lua. So just say Lua context, and then just Lua. And then generally you don't have to do this, but it is recommended in case something fails to run. We can just say a try. Then there's our code. And in here we can just say std runtime error. Because it's Lua, when an error is thrown, it will be in runtime because it's not really compiled. And then just &e and then e.what. And then as simple as just saying lua.compile string and run, we can just put some Lua code in here. Print, and take note, if you put double quotes here, it will escape, so put single quotes in here. Easy peasy. And we can just specify Lua. There we go. Let me just close this here. Now let's quickly wait for this to finish compiling, and then we'll install it, and I'll show you how to run the code we have just written. Alright, so it's taking a little too long. Yesterday when I tested it, it was like a few seconds. So I don't know why it's currently taking as long as it is taking, so I canceled it. But in your case, you would not cancel it after it has done the installation. What you want to do is you want to say make install. If you're on Linux, you have to say sudo make install because it will need to install to sudo directories, if I'm not mistaken. We just say make install, and now your Lua CPP folder that we linked in our Visual Studio Code should be there. But in my case, I don't know why this compiling is taking so long when yesterday was literally a few seconds. So I'm just going to leave it here and you will be able to finish it on your own. You just have to, I guess, be patient. Next up, this is very important. Otherwise, we will not be able to compile our C++ project here. We need to export the path to the location of the SO file in here. So if I go ls and in .so, you'll see we have a lib.luacpp.so. This is a shared object. We need to create a path that says, hey, the shared object is in this directory. Now, because I didn't finish the build, I'm going to use a build that already exists. So I'm going to env lua cpp to ll and then just get my previous Lua file from the trash. Alright, now my Lua CPP will be the original. If we go to build, you should be able to see all of these files inside of build. As you can see all of here. Now this is what you'll have after it completed the build. Now we need to get the path to here. So I'm just going to say pwd, and this is the path we need. So home, netsu, downloads, Lua CPP, build. You might want to move this build folder into your directory here. This would actually make it easier if you were to move it here. So let's do that. Now I already have Nemo. So here in downloads, we can just go Lua CPP, and this build folder, I'm just going to drag it in here. And I'm just going to copy the folder, and there we go. Now this is our Lua CPP. I'm going to rename this to Lua CPP. And this will be able to then find that SO shared object. So now if we go here, we have our libluacpp.so. Very important. Now we need to export the path to here. Then now what we need to do is we need to say export ld library path. This will be the environment variable that we need to have in order to compile this, because it needs to link to any SO file we need. And we need to link it to this Lua CPP. Now, if you put it in this folder, you will have to get this PWD we use here, but just inside of this folder, which might be easier for you. But I'm just going to use it here because it will be easier for me. We just do this, and I will have it. If you echo $ld library path, you should see what you just exported in here. If you're on Windows, then the export key will not work. I think you need to use set. Now let's go to this location here. So I'm just going to go to cd documents tuts cpp. And if you wanted to get this Lua CPP folder, you can just say pwd Lua CPP. And I think you have to be in the Lua CPP folder for pwd to get it. And you'll just have to put that in there instead. It's up to you. I might even create a directory inside of my root folder that maybe contains files like this, so it's easy linking. Anyways, however you do it, it doesn't matter as long as you have the path to that SO files folder here. So inside of this build folder, there should be a .so file here. You need that path. Now, once you have that, you can start to compile. Now, compiling will take a few extra steps, so we have to say GCC instead of G++, but I think G++ will still work. And in main.cpp, because this is our main C++ file, -i to include /usr local include and then Lua CPP. This folder will exist if you make install that build folder we have. So if you say make install in that build folder, this should exist, this directory. If you want to see what is in there, we can just go ls/usr local include, and you'll notice there's a bunch of things here. In our case, just Lua CPP. If we say Lua CPP, you'll find all of this. Then again, we need to include the Lua development files. This time we can go ls/usr include, and you'll notice there's a bunch of stuff in this include. We just want the Lua, and depending on your version, you will have different Luas here. My development files are for Lua 5.3, so any Lua I write, any Lua code I write inside of the C++ program here can only execute Lua 5.3 code. Anyways, you should see either 5.3, 5.2, 5.4, whichever version of Lua development files you have. I have 5.3. Alright, now we know the path to this. Now we can go here, -i to include again. And now I can just include this. Paste that there. Then we can say -l, and -l means library. So lib and then Lua CPP. So -l Lua CPP is referring to this lib Lua CPP.so. The -l means lib and then Lua CPP, and it automatically knows you want .so. And you want -l for lib Lua 5.3, or whichever version of Lua you included. And then -l stdc++. I have no idea what this means. We just have to add it. -o output. And this will just give us an output file. Alright, great. So once you have this, compiling should take but a few seconds. So just do this, and it should be done. If you then run that output file, and here we're having an issue where it cannot find libluacpp.so. That is normal. Let's see what we exported. ld lib, and here we go. There we go. Just added a wrong letter there. It should be library path, not library. Okay.
Anyhow, once you do that, now if we compile it again, and this time just run it immediately afterwards. And here we go. Hello world, C++, easy peasy Lua. So this here just ran. All you need to do is you need to export this right here, and then you need to include all of these linking details. All right. Once you have that, it should be able to run Lua. Now let's get a little bit more complex and run a Lua file. New file, Lua dot, now let's go main.lua. Here we go. And let's say print please subscribe and like. Okay. Once you have this, you should be good to go. Just runs Lua, so there's not much to put here anyways. If we were to then go to main.cpp, then instead of compile string and run, we want to say compile file and run. So this will compile a file for us to run. And here we can just pass in the file name, main.lua. As you can see, it's in the same folder as this main.cpp. Now, if we were to run this, as you can see, please subscribe and like. You might be wondering what will happen if this output file is not in the same folder as the main.lua. Now let's make a directory, and let's move the output file into X, and let's go into X and then run this output file. As you can see, it cannot run this code. So you need to include this Lua file whenever you distribute this code, because otherwise the file will not be found. So make sure that you include this code with your source code. And finally, let's actually get a good example of what we want to do. Generally, when you work with Lua and C++, you want to include, or you want to be able to like pass variables between Lua and C++ and all of the jazz. Let's do that. I'm going to remove this stdc out here, and I'm going to keep this here, and then right above the try and below the context, we can create a shared pointer. std shared pointer engine Lua t string. This is the type you want to save inside of this variable. In our case, we want to save string data inside of this variable. Generally, in Lua, it doesn't matter what type you put anywhere. You know, you can change it whenever you want. In C++, however, because of how types work, we need to specify we want a string to be stored in here. And later, you should not be changing this to a number or anything like that. There's a lot of things you can store. Lua t string is the same as saying std string. But you can also have Lua t number, which is just for numbers. This is usually a double in C++. So we'll represent a double while this represents a std string. You have t Lua boolean, which is of course just the normal boolean, yes, no, true, false. Lua t nil, which is a nil undefined null value. You have Lua t table, which in C++ is represented as an array or map, usually in std map. And you also have Lua t user data. This is a special type that allows the implementation of user-friendly or user-defined types. And this is very powerful. And then you want to say what the variable name should be in your C++ code. This can be whatever you want. I'm going to say hello world is equal to std make shared, and then engine Lua t string. And in here, you would just want to put the value you want to store in here. In this case, I can just say hello world. This value will now be stored inside of this hello world variable. Now we can pass this hello world variable into a Lua variable. So we can say Lua, and I'm just going to rename this Lua to ctx because it is context. So I'm just going to say ctx dot add global variable. Add global variable will, add a global scope variable. And then you can give the variable name. This is what it will be in Lua. So in our case, we can just say world. So this variable will be called world in Lua. And we can link the hello world variable. Now, what this linking does means that if we change the value inside of hello world here in our C++ code, it will represent it inside of this Lua code. If we change the variable data inside of our Lua code, it will represent it as well inside of our C++ code. So these two are exactly the same. They share the same value. They are shared pointers. If one value changes, it will change all of the other values as well. They're pointing to the same location in memory. One is just available to use in C++, while the other is available to use in Lua. I will test this out a little bit later as well. Then we can go ctx.compile_string. And here, this is almost like creating a function call. Whatever you put in here, you can later on call as if it was a function. And let's just say something. And then after that, you can just put some Lua code here. So you can say print saying, and let's append that variable we created, world. Because this world variable is available to use in Lua. So we can use it here. And if you want to add another line, you can either go \n. I don't know if this will cause any errors, but you could also go like this. So these are two separate strings. If I were to just do this, as you can see, they're two separate strings, but they will be interpreted as two different lines. So what we can do now is we can also change the world variable to say something else. This is now Lua code, as you can see here. So this say something and in quotation marks function is basically going to print out what's inside of world and then change it to this value. Then we can just say ctx, and instead of run compile file and run, we can just say run because it's like a function. And when you say run, we can just pass in say something and it will run this say something code. Let's compile and run this and see what we get. Saying hello world. So we're saying and in this value inside of world. Now we want to see the new value inside of world because here we set the new value. To do that, we can just go here and say cout. And then to get the value from C++, we can just say hello world. So the variable we created, get value, as will get the value for us. We can also change the value from inside C++. So hello world set value, and here we can say I am cool, and then we can of course run it in Lua. So ctx.compile_string and run, and you can just say print world, so printing that world variable. Now let's try and run this, and you'll see we get saying hello world. Then this is now Lua code. So first we say hello world, then we print it out by just appending saying and then adding world variable here after we attach them. Then we change the world variable to say this is now Lua code. After we run this compile string function, it will try and get the value, and when we get the value, it says this is now Lua code. So we change the value of this variable inside of our Lua code. Then we change it inside of our C++ code and print it out inside of Lua. And as you can see, it also reflected that. So this is how you can pass data between Lua and C++. Create a variable and you can change it from both Lua and C++ and get the value whenever you want. So all of the source code that we're going to talk about today can be found here. Link is in the description. So weebnetsu, YouTube projects. Go to C++, you'll notice you're free here. You just say MySQL connection, click on there, and here's the source code. Cool, now let's get that out of the way. Now take note, most of what I'm going to be talking about today will be focused on Linux and macOS like operating systems. This will work on Windows as well, but you'll need to do a little bit of extra tweaking in order to get this to work. In the source code, I left a little note for Windows users that someone left a comment on a video, on a previous video I made about this, saying how you could get this to run on Windows. However, I don't use Windows, so I have no idea how that works. Cool. Now let's clean up here, and here we go. Nice clean slate. So first of all, Let's start off with first getting our database to be running. So in our case, we'll be using MariaDB. MariaDB is basically MySQL. That's all you need to know. It's the same as MySQL. So after you have installed it, if you're on Linux, you need to make sure you have started up this process. So just sudo systemctl start MariaDB. If you have MySQL, you of course have to say MySQL here. And then it will ask you for a password. And just like that, it should have been started up. If you go systemctl status MariaDB, and this is Linux only. If you're on Mac, you don't have to worry about this. Then you should see this active is active. Cool. Then of course to get into it, you can just say MariaDB and then your user and whatnot. Okay. Now I already have a bunch of databases and stuff in here, so I'm just going to say drop tbl users. And there we go. So now I don't have any more data here. Now let's get started. First off, we want to create a users table. And here we go. I just created it. It created a table. So just create table. We're just saying tbl users, give it an ID, name, surname, email, password. This is just a dummy database. You can find all of this code in the source code. And you can just paste it here. So depending on your operating system, you might have to install the MySQL or MariaDB development files. I believe all I had to do was just install MariaDB, and that installed the development files for me as well. But to find out where, if you have it, if you're on Linux, you can just go ls/usr/includes, and here you should have either a MariaDB or a MySQL. So let's see, do you have a MariaDB? No. Do you have a MySQL? Yes, I have a MySQL. Okay, then in here you'll find a bunch of things you can use, like mysql.h. This is what I'm looking for. That's mysql.h. You need this header file for everything here to work. So make sure you have the SQL development files with this header file here. If you're on Windows or Mac, I think you should probably also get it. I don't know how the Mac file system works, but it might also be in /usr include MySQL. Anyhow, so if you have that, then you're basically good to go. Now let's get started. We need to build out a few things. First, let's just include a few things here. So include tuple. This will allow us to use tuples. And then we also need to include the SQL header. So hashtag include MySQL. And then I need to say mysql.h. You might have something different here. I know in some, especially Debian-based operating systems or distros, you might have to say MariaDB/MySQL or MySQL/MariaDB. It depends all on this here. So mine is MySQL. That's this first part here, MySQL. And then that mysql.h we'll take a look at. And then we also need to include one more. This is an optional header, but mysqld error. It's so we can handle errors. Once we have that, we have all we need to be included. Next up, we can create a struct. And this can hold all of our SQL connection information. So SQL connection. And here we can just have information, std string, such as the server we're connecting to, the user, the password, and the database we're trying to connect to. And for those of you that know, a struct is just a class, but I think by default everything is public instead of private in C++. And then you can create a constructor, so SQL connection, std string, and we can say server, and we're gonna have to do this quite a lot, so I'm just gonna copy this server, user, password, database. And then we can of course just do the regular this, and then server becomes the server we passed in. And we can do that for everything we passed in. Cool, now this is basically our
connection. It's as simple as that. This will help us connect by just keeping all of this information stored for us. Now we need to do some SQL connection setup. So this will try and connect our database, or us to our database. To do that, we can create a function that will return a tuple, a boolean, and then a MySQL object pointer. So std tuple, and then it will return a boolean and a MySQL, all caps, and an asterisk to say it's a pointer, and an SQL connection setup. And we can take in a struct SQL connection MySQL details. Here we go. Now while we're here, let me also teach you about code documentation for those of you who have not yet jumped into that. Whenever you write in a code base, it's always a good idea to leave a lot of comments, but we already know the basics of comments. It's a good idea to hold comments everywhere, anywhere where you can, where it might be confusing, whatnot. In this case, what we are trying to do is we are trying to do code documentation. Luckily for me, VS Code already auto-completes a lot of this for me. So if I go /*, and this will auto-complete a lot of the code documentation for me. Add brief is like the description you're trying to give this function. For example, we'll try to connect to SQL. Return a tuple. First value will be true if connection was a success. And now anyone who reads this will understand immediately what this function does. And in here we could just leave a comment saying what this pair means. So details to connect to SQL DB. This is code documentation. Whenever I now hover over this function, it will show me this documentation. This is very useful, and I recommend everyone try and use this as much as possible in your code, because a lot of people will find this very, very helpful. Great, now that we also know how to do code documentation, let's continue with the rest of this course. So we can create a connection, MySQL is equal, or MySQL, and then a pointer connection is equal to MySQL init for initialize, and we can just specify null. And this will just create a MySQL instance for us. We can also create a boolean success in case there was an issue. This will then be false. You can then return std make tuple, and this will create a tuple for us with success and then the connection. Now let's put everything in the middle here that will try and connect to this database. We can then say if not MySQL real connect. So it's going to try and connect to MySQL with connection, so the connection we have, and we want to provide all of the details. So MySQL details. So that's what's being put in right here, and this looks exactly the same as this here. So now we can just specify we want the server and in .c string, because here we cannot use an std string. However, we might want to do that. We need to use a C style string, which is a constant pointer. So we need to convert our std string to a C str. And we need to do this for not just the server, but the user, the password, and then the database. So Control C, VVV, database, password, and then we just need to pass in the port. If you don't have a specific port, then you can just say 0. And then the socket, I'm just going to say null because I do not have a socket. And then the client flag, I have no idea what this is, so I'm just going to put 0 there. And there we go. This is our SQL connection here. So it will try and connect this connection right here
with these details we passed in. So the server, the user, the password, and the database. And then if it fails, because here we say if not, so if the connection is not going through, then we want to say success is equal to false. And we can maybe also just std.cout, and we can just cout connection error. And here we can say MySQL underscore error, and we can just pass in the connection, because then we'll be able to read the error from that connection. And we can say std endl. Now you could exit the program here if you want, but in general usage, you do not want to ever exit a program just randomly. So you don't want to go exit and like 1. This here I did use in my previous tutorial, and you should never actually use that. So in this case, we're just going to return a failed success result in case it fails to connect. Okay, great. Now let's go here and try and do that connection. So bool success, and then we can just say MySQL con for connection, and then MySQL row, and this will be the rows we receive once we actually do the request. We can then create our struct SQL connection, SQL details, and we can say localhost, this is our host, and then our user, in my case I am Steve. Our password, I made it password because I don't need any really powerful password. Generally, you also don't want your password to just be in the code. You might want to instead have an environment variable file which you read this password from, and then you don't commit this to any like GitHub or anything like that. Because if someone else can go to that GitHub, if it's a public repository, and they can find out where your host is and what your password is, you're basically screwed. So generally don't put your password in here directly, rather have a file that you read this password from or something like that. In this case, it's just an example, so it doesn't matter. And then our database. Now we can try and get the connection. So std tie, and this will try and create a tuple from a result. So success and then con. So this is the variables we created here. Make that equal to SQL connection setup, SQL details, and there we go. Now if we was not a success, so the connection just failed, we can just return. But in your case, what you have to do is you have to manage this. If something happens, you don't just return. You might want to display some extra messages or try to connect again, or maybe try different details or something like that. But because this here will just quit the program. In our case, it's just a basic example, we can just quit the program. Okay, now this is just the connection. Let's make sure everything works as expected. So there are two ways that you might have to go about to compile this. So let's go G++, and we just say main.cpp -o, and we just say output. So this will just create an output file, and you want to dash out to link USR include, and then if yours here, if you had to say MariaDB here, then you have to specify MariaDB. So I'll just make this a little bit longer. You just go here. Then you'd have to say MariaDB. If it's like me and you have to say MySQL, you can just say MySQL instead. And you just specify MySQL. This here is that this .h file. So if this MySQL.h is MariaDB.h, then you have to make sure this is MariaDB. You don't have to specify .h. Okay. Once this is there, you can just say -l. And this link is also two things that can happen. First is you can have MariaDB client. This might be one you'll have to use, but in my case, I just have to use MariaDB. I don't know really why it is like this. I just know it is like this. In the previous distro I tested this on, you needed to say MariaDB client. On this distro, aka Arch Linux, you have to say MariaDB. Don't know why. but that's what you have to do. Let's try and compile this. And here we're getting an error. Maybe you should just say, instead of normal return, we can just return 1, which I think means error. Compile this, it compiled. If we try and run this, it connected successfully. How would we know if it didn't connect successfully? We can just say that. There is no sieve user. So if I were to compile and run this, then here we get connection error. So right here, connection error. Access denied for user sieve at localhost using password yes. So the connection failed. That's basically what we got here. Okay, now that we have the connection underway, let us start with the SQL execution itself. So we can say auto here. I generally don't like using auto, but unless we want to write a ton of code here, auto is truly the best way to go. So I'm going to say auto here because I don't want to write a ton of code just to get this simple example out here. exec for execute SQL query. We can then take in a MySQL connection and then an std string, which will be a query. And yet again, you could add, if you want to, some documentation here. I'm going to skip that for now because we still have to go through the whole tutorial here, but you might want to do that. Okay, in our case, here is one way you can do it. You could return a tuple, which returns a success and then the connection. This is perfectly fine. However, some people would instead want to return an object, a struct, that says if it's a success and then it also returns the result. This is up to you which you prefer. I'm showing you both methods just so you can get an idea of what you can do here to make your life easier in the future. So here we can have struct and then result. So this is the result we want to return. Bool success. So if it was a success, to connect, MySQL underscore res, which means result, and then res. There we go. This is what we'll be returning. Now let's create a variable, success, which will be by default true. And in here we can just say return result, success, and then MySQL use result. So once an SQL query has given a result, we can just pass in our connection here because that will give us the result from the connection. And in here we can actually try and execute SQL queries. So we'll return this result here, which will return if it was a success and also the result of our query. We can then say if MySQL query connection query.cstring, because we need to convert it to a C type string. So this will try and execute this query. If this returns true, that means an error has occurred. So if this MySQL query function returns a true value, an error has occurred. However, if it returns a false value, then no error has occurred. So this will actually execute the SQL query for us. If an error has occurred, we can just say cout MySQL query error colon, and we can just specify MySQL error, and we can specify connection, and then we can just say success equal false, and in here we return the result if there is one, and then if it's a success. Now let's try and execute some SQL queries. So here I'm yet again going to use auto because I don't want to type out everything every time. Result is equal to exec SQL query. We can specify, or we can pass in the connection, and then what we want to do. In this case, select star from TBL users, and we add our semicolon, and there we go. So we pass in the connection, and then the string we want to execute, the SQL query. We can then say if not result.success. This time we can specify .success, and I love this method. It's a lot of extra typing you have to do, but I love this method because you specify if result was a success. In this case, if it was not a success, you can just return, but in your case, you might want to handle a few errors here. In my case, I just want to return. Otherwise, if no issue had happened, we can just say cout database output and just another backslash in here just to give it an extra lengthy way before it's the full output. And we can use a while loop to go through each and every row inside of our SQL output. So while, and you say row, and that becomes equal to my SQL fetch row. This is almost like a for loop where each value becomes a value, and then result dot res, and this res comes from here. This is the res. If that is not equal to null, so while this row result we get here is not null, so while row is not null, this here is just like a one-liner, so we don't have to create this variable, then check against this variable. What you could do is you could say while true, and you can assign this row inside of this while loop, and then just break whenever it's null. But I like doing this because it's a one-liner. And then we can just say cout, and I'm going to just copy and paste this directly from the script, because this is a lot of typing, which I, to be honest, don't want to do. Okay, so we're just saying cout, and in the row we want to select, and this would be like the first column, so row at column 0. And here we're just adding a pipe symbol, row at column 1, pipe, row at column 2, and you'll see the output of this in a second. Then we need to clean up the database result. So my SQL free result, and result.res, so this will clean up this variable so it doesn't have all of these results in it anymore. And then you want to close the connection once we're done working with MySQL. So MySQL close, and then just con, and that will close the connection. Let's try and run this and see what our output is. Here we go, we do get a nice output. There we go, one Mike Wazowski, mike@gmail.com, password. This is the details we entered previously, so all of their actual details are now being displayed. What you could do is you could create a class that when you pass in this row, it will automatically structure it for you. So then you can just say row.mike or row.name or row.surname instead of having to say row at index 0, which can be confusing. But that's a little bit out of scope of this very long tutorial. Let's say we got an error. Let's say we said select from TBL users instead of star from TBL users. If we run this, then we get an MySQL error. You have an error in your SQL syntax. So it does throw a nice error for us if it is not correct. And that's the basics of getting SQL details or running SQL in C++. So you finally finished the C++ course, and really well done. It was a very long course with some very deep concepts. But you might be wondering now, what next? What should you be learning next? What can you do next? And here I will have a few ideas that you might want to take a look at. Like learning a few libraries. A few good ones could be Qt. You can use this to create UIs, user interfaces, like a window. That is pretty neat. If you don't want something as complex as Qt or with its weird license, then you might want to go for something a bit more minimal like FLTK. I have a bit of experience with FLTK. I'm not the biggest fan, but it is really simple and really easy to get into. If you want something that's a bit more modern, Juice might be a great way to get into it. It's also something you can use to make UIs that looks relatively modern. And last, you could use GTK. GTK is very popular, especially in the Linux environment, because it's fairly simple to learn and it has a great amount of support. Like, just take a look at this. Scroll down. Here's a C version of a GTK application you might want to make. You have JavaScript, you have Python, all of these languages. However, if you'd rather jump into game development instead of just going and doing boring GUIs, then I might recommend you to learn SFML. It's very basic, but it's also very powerful and great if you want to get into game development, especially if you would like a Love2D-like solution in C++. This is very similar to Love2D. However, if you want to do something a bit more powerful, Godot is a free and open source game engine that supports writing your code in C++. However, if you want something that is already very popular and really very big, you might want to go for something such as Unreal Engine. Personally, it's up to you to decide whichever you would prefer if you want to do game development. If you're not interested in learning any more frameworks or libraries or game engines, then you might want to consider learning another language instead. If you're coming from C++, then learning C can benefit you a lot. However, if you're looking for something a little bit lighter and easier to learn, especially that integrates very well with C++, then Lua is a great choice. In fact, I have a whole Lua tutorial if you want to learn Lua. However, if you want to learn something that's a bit more popular and being used a bit more, then you might want to learn Python then, because Python is very popular. However, it does not integrate as well with C++, but it still integrates pretty good. And it is much easier than C++ is. But if you want something that's a bit closer to C++ and not as easy as Lua or Python, then a language that's becoming really popular as well is Rust. Rust is a great language you want to learn because it's somewhat like C++, but it's more focused around type safety and concurrency. And last, let's say you don't want to learn another language. Let's say you just want to continue learning C++ and improving on the skills you already have. In that case, there are two good channels I can recommend you to go to if you want this. The first is Low Level Learning. He makes pretty good tutorials. I have watched a few of them. However, it does seem like he is now going a little bit further than just C++. And then, if you really want to go deep into C++, the Cherno has a great C++ course. And this course really helped me along when I first got started with C++. If we go here, then here we go, C++. This is a really good course with 100 videos, as you can see here. And it really goes into the nitty-gritty things, the things you don't usually look at when you just start off, when you first start out with a language. And that's that. Thank you for watching. I truly hope you all enjoyed this C++ course. And truly well done for following along and making it to the end. And I'll see you all again in the next tutorial, whatever language that may be in.